Colegas, muy buenas tardes. Entiendo que también estamos transmitiendo en internet, entonces saludo a los colegas, amigos que estén conectados en la red. Quiero pues darle la bienvenida a este seminario de impactos de cambio climático en la frontera norte de México. Es una continuación de un esfuerzo que ya tiene un año con distintas perspectivas y distintas temáticas abordadas. Le agradezco a la doctora Gabriela Muñoz la coordinación y la preparación de este evento, igual al director de nuestro departamento de estudios urbanos y medioambientales, doctor Juan Manuel Rodríguez. Muchas gracias. Y ahora en especial tenemos dos muy distinguidos visitantes que ya serán presentados, pero quiero agradecerle a la doctora Isla Bauer, muchas gracias por su visita, igual al profesor Krupa, muchas gracias por su visita. Son personalidades muy conocidas de ustedes, especialistas en el tema de cambio ambiental y sobre todo la cuestión ahora alimentaria. Yo solo quiero reiterar pues que la temática del seminario para COLEF es fundamental. Creo que estamos en una región donde por razones de geografía, por razones de interacción social y ahora además por toda la dinámica de cambio climático, que es un proceso global, pues nos ubica en una región en donde la gestión ambiental se vuelve crecientemente compleja y necesariamente binacional, necesariamente articulada. Y eso tiene pues muchas aristas, muchas dimensiones, desde el marco institucional para pensar cómo se gestiona un medio ambiente sujeto además a dinámicas de cambio climático, un medio ambiente compartido. Hay una dimensión institucional compleja, difícil, no resuelta, alrededor en general de los recursos naturales, pero también de toda la transformación que están experimentando recursos, actividades sociales derivados o asociados con el cambio climático. O sea, ya hay un tema institucional muy difícil, hasta los temas estrictamente más técnicos, más acercados a su especialidad de estudio de natural, hasta procesos biológicos ya muy especializados, que requieren pues estudios multidisciplinarios y requieren especialidades cada vez más afinadas, y abordarlas incluso en dimensiones y temáticas como la que ahora se presenta de seguridad alimentaria, mucho más focalizado y especializado. Entonces en ese reto está montado la perspectiva del seminario. Yo les agradezco que la continuidad y el esfuerzo de debatir a la frontera norte mexicana con estos enfoques, con esta especialización. Y en especial reitero la bienvenida a nuestros invitados que nos ayudarán a ubicar de mejor manera la problemática y el análisis que aquí hagamos. Entonces, el programa lo retoma ahora el doctor Juan Manuel Rodríguez y pues avanzamos a la sesión. Y bienvenidos nuevamente, doctor Grupa, profesora Isla Bauer, muchas gracias. Entonces, Juan Manuel, por favor.
Sí, muy buenas tardes a todos. Muchas gracias por acompañarnos en esta sesión, primera sesión del curso de Seguridad Alimentaria y Cambio Climático. Solamente me gustaría recalcar que esta sesión no sale de manera espontánea, sino que es gracias al apoyo institucional que tuvimos el año pasado, cuando se organizó coordinó en su momento la doctora Gabriela Muñoz uno de los eventos estratégicos, esa nueva forma que venimos trabajando en el COLEF para apoyar ciertos temas que consideramos como estratégicos. Algunos de ustedes estuvieron en la sesión de hace poco más de un año, en el que se analizó de manera general cuál era el impacto del cambio climático en el sector agrícola y ganadero. Fue una sesión muy general donde participó por primera vez la doctora de la isla. Ahí surgió este contacto para que pudiéramos tener hoy esta sesión, este curso que inicia el día de hoy. Entonces, los eventos estratégicos en el COLEF vienen ya produciendo productos concretos, y es esta continuidad en las actividades, y de manera concreta es un curso de esta naturaleza. Por otro lado, me gustaría recalcar, ya lo comentó el doctor Guillén, el tema de cambio climático es importante para COLEF y de manera específica para nosotros como investigadores del DEUMA, del Departamento de Estudios Urbanos y Medio Ambiente, ya que es un tema transversal. De hecho, el tema relacionado al cambio climático se viene elaborando desde el nacimiento del DEUMA, desde casi el nacimiento del COLEF hace ya 28 años. Sin embargo, no tenía esta connotación que tiene hoy sobre el cambio climático. Hemos relacionado estos estudios en la frontera desde hace 26 años por lo menos, en temas específicos sobre las cuestiones urbanas de las ciudades en la frontera norte, temas de cambio de uso de suelo, temas de gestión ambiental, temas, digamos, que en cierta medida estaban separados uno de otro. Sin embargo, actualmente, y no es porque sea un término de moda el cambio climático, sino que es una evolución propia del análisis de la problemática ambiental, que en estos últimos años, en los años recientes, se ha tenido la connotación de cambio climático. Entonces, a partir de hace 2 años, se viene apoyando ya el tema de cambio climático propiamente dicho, que es un tema transversal, que permea las esferas ambientales, sociales, económicas, políticas, incluso culturales, ya que el cambio climático no es una línea de estudio dentro de nuestra institución y dentro de instituciones internacionales, sino que es un tema que implica cambios en la esfera política, ambiental, y también en las cuestiones de los cambios de los consumos, los hábitos de consumo de la sociedad actual, ¿no? Entonces es un tema bastante, desde mi perspectiva, bastante noble, porque lo podemos abordar desde diferentes esferas. Y es a partir de hace 2 años que este tema se viene apoyando, ustedes lo saben, la doctora Gabriela Muñoz viene apoyando mucho esta línea de manera concreta. Y finalmente, pues me gustaría nada más señalar, ustedes ya tienen ahí el programa de actividades del día de hoy hasta el viernes. Solamente me gustaría definir que son 3 temas importantes en lo que se va a ver en estos 3 días. El primero sería el clima y su dinámica. De manera general, se va a explicar cuáles son las componentes del clima en un contexto, digamos, relativamente natural. Cómo funciona la atmósfera, cuáles son las implicaciones en las sociedades, y de manera específica sobre las cuestiones alimentarias. Otro punto, otro gran bloque de temas son las alteraciones climáticas. Ahora, bajo una condición de cambio climático, sea natural, sabemos que el clima ha evolucionado, experimenta cambios de manera natural. Sin embargo, en los últimos años se le ha dado una responsabilidad, parte de esa responsabilidad, a la actividad humana. Entonces, esa sería una segunda fase dentro del curso. Y finalmente, y quizás el más importante y sobre todo más central en este curso, pues, ¿cuál es el impacto del cambio climático en el abasto alimentario? Seguramente, y por unas condiciones de cómo nos distribuimos poblacionalmente, cómo ordenamos nuestros territorios, quizás sean las ciudades los lugares donde seamos menos perceptibles de cuál es la crisis alimentaria. Pero si vamos al campo, en los diferentes países, recientemente estuve en Chile, y ahí es la misma discusión. La gente a veces en las ciudades no somos a veces sensibles a condiciones del clima, sobre todo cuando hay una crisis alimentaria que ya tiene algunos años gestándose a nivel internacional, pero como son las ciudades de los medios, donde al final de cuentas son ecosistemas y sistemas artificiales, es donde menos a veces estamos más sensibles a este tema. Sin embargo, el cambio climático ha iniciado de hace muchos años, ya sea de manera natural o con un origen antropogénico, y lo que nos queda aquí, y que como resultado de este curso taller, será analizar cuáles son las implicaciones en el abasto alimentario de manera global, y por qué no de manera regional, que es al final de cuentas lo que también nos impacta por lo menos más directamente. Y pues no me queda más que agradecer la coordinación de este curso a la doctora Gabriela Muñoz, el apoyo del doctor Guillén, el apoyo institucional, y por supuesto a nuestros 2 invitados, a la doctora de la Isla y al profesor Grupa, por estar aquí con nosotros. Y bueno, esta es su casa, y muchas gracias por estar aquí.
Gracias, Donna, gracias, Juan. Gracias, colegas, por estar aquí, por acompañarnos. Está el de humo en pleno, ¿verdad? Muchísimas gracias. Yo Solo quisiera pedirle a la doctora de Bauer que presentase al doctor Krupa y entonces hacemos un pequeño paréntesis de unos 5 minutos, si les parece. ¿Sí?
¿Vas a hacer paréntesis?
Para que pues nos acomodemos antes de empezar la sesión, ¿ok? Entonces terminamos con the presentation of our Professor Krupa. So go ahead, please.
Sí, muy buenos días. Es un gusto y un honor estar aquí por segunda vez en COLEF y realmente siento que es una institución con un ambiente académico de excelencia y tienen además la gran oportunidad de estar junto al mar, junto a la naturaleza en un paisaje bellísimo. Desde la primera vez que tuve la oportunidad de estar con ustedes me quedé muy impresionada y agradezco a la doctora Muñoz, al doctor Rodríguez, al doctor Guillén el que me ofrezcan esta oportunidad de colaborar, pero esta vez acompañando al profesor Krupa, quien es un amigo de muchos años y que es un distinguido investigador, como se darán ustedes cuenta a través de unos cuantos datos que voy a presentar, porque su currículum es muy extenso, pero ya se enterarán los interesados más con mayor detalle posteriormente. El doctor Krupa recibió este grado, pero además con habilitación de la Facultad de Ciencias Naturales de la Universidad de Uppsala y ha sido profesor de Minnesota, de la Universidad de Minnesota desde 1972. Dirigió la Escuela de Graduados del Departamento de Fitopatología y actualmente, a partir de 2009, es profesor emérito de esa universidad. Ha participado impartido diferentes cursos, ha sido profesor visitante de Colegio de Posgraduados y de varias instituciones desde hace tiempo y fue profesor visitante distinguido de la Academia de Ciencias de México y además figura en los registros de los hombres notables de ciencia, hombres y mujeres notables de ciencia de Norteamérica. Es miembro distinguido de varias asociaciones y ha colaborado con la FAO, con el Departamento de Agricultura de los Estados Unidos y ahora está en un comité muy especial del Departamento de Agricultura de Estados Unidos con un nombramiento especial del ministro de Agricultura de ese país. Bueno, se ha especializado en la calidad atmosférica y ha participado en normas para regular, por ejemplo, la materia particulada y los oxidantes y otros fotoquímicos, además de ozono. Su labor editorial es muy distinguida, ha sido editor en jefe de las series de El Serie, que es una de las editoriales, como ustedes conocen, más especializadas y calificadas a nivel mundial, así que ha llevado la serie de libros de los desarrollos en ciencias ambientales de esta editorial. Numerosas publicaciones y una de ellas es su libro en inglés de lo que llamamos en español, ya que está publicado en español, Polución, Población y Plantas, este ejemplar quedará en la biblioteca a su disposición. Quiero decirles como cosa especial que aquí se mexicanizó este libro, ya que la autorización de la Sociedad Americana de Fitopatología fue para el texto de este libro que es muy popular en Estados Unidos para los cursos de este tema, se utiliza muchísimo, pero no autorizaron la portada Y este es un dato simpático porque la tuvimos que elaborar aquí. Aquí tenemos en esta portada la primera vez que encontramos los daños en bosques por ozono, nuestro volcán Popocatépetl contribuyendo, y algo que viene a ser muy de actualidad. En 1998 tuvimos una época de gran sequía y incendios forestales tremendos. Entonces, esta es una ilustración que publicó el periódico Reforma del Zócalo de la Ciudad de México, cuando no fue por la influenza, fue mucho antes, se comenzaron a usar los tapabocas. Entonces, es un libro que, a pesar de que ya tiene algunos años, cuenta con lo básico muy bien explicado, y como les digo, es muy popular en Estados Unidos. En la actualidad, el profesor Krupa dirige dos proyectos de investigación muy importantes, usando líquenes como indicadores biológicos de calidad del aire, y identificando más de 12 fuentes importantes de contaminación a nivel regional, basado esto en las huellas de las emisiones, y que con esto establece un enfoque muy novedoso hacia fuentes específicas. Bueno, como decimos, se ha distinguido por sus contribuciones en procesos atmosféricos, contaminación atmosférica y cambio climático, y todo en relación con las respuestas de la vegetación. De manera que pues lo recibimos con un aplauso.
Maybe it's too simple, but I want an answer from you as to how you describe the word climate.
¿Entendieron todos lo que está preguntando? Lo que preguntó es ¿qué entienden ustedes por clima?
Describe the word climate. This is not an exam. When you think of the see.
Maybe it's a group of characteristics about temperature, wind,
Precipitation,
wind,
radiation,
pressure, and all of these characteristics made change in the site in a place.
You see, this is the common perception of climate, because meteorologists cannot think past physics, and so everybody believes climate means temperature, precipitation, radiation, relative humidity, and wind. Surprisingly, there is another climate that people don't realize, and that is the chemical climate. Oxygen, carbon dioxide. Without these things, we won't be sitting here, because plants are absorbing carbon dioxide and we are absorbing oxygen. So there is a chemical climate. And would you be surprised that the evolution of the earth is controlled by the chemical climate and not the physical climate? The reason I'm saying that is, when you look at the publications and the media, the television, you're always talking about global warming. That's absolutely incorrect, because life has evolved in a chemical climate. So when I say chemical climate, there is a whole variety of chemicals in the atmosphere. So let's, for example, take a look at the natural climate of the Earth. There are a number of gases like argon, nitrogen, oxygen that occur in percent concentration. And these are natural components of the Earth. In fact, if you look, 78% of the atmosphere is nitrogen. If you look at the sources for these chemicals, argon is produced by radioactive reactions in the atmosphere. If you look at nitrogen, it's produced by biological processes and by volcanoes. If you look at oxygen, it's produced by biological processes. This is a naturally evolved composition of the Earth. Then there are a number of trace gases. Carbon dioxide. Carbon dioxide occurs in parts per million concentration, not percent, parts per million. It's produced by human activity and it's produced by biological activity. If you, for example, take carbon monoxide, which also occurs in the atmosphere, carbon monoxide occurs in parts per billion in volume. It's produced by human activity, biological processes, and photochemical reactions in the atmosphere. Reactions that are driven by sunlight. Then if you take compounds like chlorofluorocarbon, they occur in parts per trillion. And these are produced strictly by human activity. So if you look at the normal composition of the Earth, with the exception of chlorofluorocarbons, every chemical in this list is produced both by human activity and by natural reactions. Therefore, when you say air quality and air pollution, how do you define pollution? Anybody? Come on.
Well, I would say it's a change in the pattern of the composition, of the chemical composition of the atmosphere gases.
Background composition, did you say?
The chemical composition
Uh,
of the atmosphere gases.
When you say chemical composition, are you saying there are more chemicals added to the atmosphere?
No, it changes the amount of the...
Correct. Correct. Absolutely. So what we are saying is, when we say pollution, the background concentration is being increased. Now the question, how do you measure the background? Because there's no place on the Earth that's not polluted. Any guess? How do you measure the background?
Polar ice.
Pardon me?
By the analysis of polar ice.
And also what?
The ice in the polar.
But polar air is also polluted. You can measure lead in polar air coming from urban areas.
Then you can make an historical analysis of the change of the atmosphere.
Over how many hundreds of years?
I don't know that.
You see, there are two ways of looking at background. One is what you say, you go far away and measure. But then you can't, because there's no seguros as to how much is natural and how much is human. The other way of looking at background is to look at the concentration before the onset of industry and after. If you go back and look at the historical data, many of these chemicals have been measured in the 1800s, 150 years ago. They did not use modern technology, but they measured manual methods, like for example carbon dioxide. If you take sodium hydroxide and allow sodium hydroxide to expose the air, it will become sodium carbonate. The carbon dioxide will react with sodium hydroxide and you'll get sodium carbonate. So you measure the amount of carbonate because the reaction is stoichiometric, it's 1 to 1. One hydroxyl molecule or ion forms one carbonate. So when measuring the carbonate, you can back calculate the carbon dioxide. And this exists. In fact, in Europe, a French person by the name of Hauzou measured carbon dioxide at 350 locations in 1886. There's a very famous saying, we think we are discovering something, but most likely somebody else already discovered it. It's buried in the book someplace. Nevertheless, going back to, I don't want to philosophize, but going back to the reality, in 1886, the average carbon dioxide concentration was 280 parts per million. Today, the concentration is 380 parts per million. So in other words, over 150 years, the concentration is changed by 100 ppm. So if you look at the rate of change of carbon dioxide, it's occurring at the rate of 0.6% per year. Similarly, there is ozone at the ground level, produced by human activity. If you look at the ozone concentrations in the 1800s, it was 20 parts per billion average. If you look at the ozone concentration today, it's 40 parts per billion, double. So in the sense that, as she said, you can look at the background concentration and then say what you added is the actual pollution caused by civilization. Now, what has this got to do with the evolution of the earth and life? Here lies the answer. If you look at the temperature above the Earth's surface, which is the vertical axis, and if you look at the temperature in Celsius in the horizontal axis, you will see for the first 10 kilometers, the temperature declines as the height increases. This is the reason why when you go in a montaña, the further up you go, the cooler it gets. Okay. The reason this cooling is occurring is because the incoming solar radiation is being absorbed by the surface. All surfaces absorb heat. And there are two types of heat. There is what is called as sensible heat, and there is what is called as latent heat. Sensible heat is re-emitted back into the atmosphere, and I'll show you in a few minutes. Latent heat is stored in the substrate that's absorbing the heat. Now, once you go past 10 kilometers, the temperature increases with height. The reason this increases with height is the atmosphere in this area is absorbing the solar radiation in the wavelength of ultraviolet B. Okay. And the heat that's generated by the absorption of the ultraviolet B in this area is converted to heat, temperature. Now what is happening here? There is ozone in the atmosphere. 10% of the ozone is in the lower atmosphere, 80% is in the upper atmosphere, otherwise known as stratosphere. This 80% of the ozone is produced naturally. It's not produced by human activity, it's produced by natural reactions. This ozone absorbs ultraviolet B, and therefore the incoming radiation has very little ultraviolet B. If this is not happening, then you'll get an increase in skin cancer. Ultraviolet B is toxic to human skin and it causes melanoma. On the other hand, the ozone that's produced here is strictly produced by human activity, fossil fuel combustion, automobiles, power plants, anything that's burning fossil fuel combustion would lead to the production of ozone. So, any comments, questions? Yeah.
I would like if you can show the table before, the one that you put, the previous table, can we get it?
Sure.
Please.
This?
Yeah, thank you very much. Actually, I found quite interesting to see this table because the three first chemical constituents are related to radiation and biological, no human activities.
Right.
But most of them most of the chemical constituents are products from the human activities. And you are talking about the 150 years, the last 150 years, this climate change has been increasing or something like that. So we are relating this increase of chemical constituents mostly because of the human activity related to the production, because we are talking about the 150 years when the whole industrial process, industrial revolution, and all the consumption, level of consumption has been increased as well. So I found out that 11 constituents out of that table are produced by human activities. And the less related are the volcanic activities, which most of them are related as well with the human activities. So the major impact here in table I can read out is the human activity has been producing the climate change.
I'll come to that in a minute.
Okay.
There is more to this than this table.
All right.
By the way, I don't know what Dr. thinks, but the material I'm presenting is being stored here at the Centro. Everything I'm showing is stored here. A copy is sitting here.
Thank you.
Yep.
Yes, can I say something, Professor? And it's going to be available online and on a hard disk or CD if you are interested. So if you cannot follow the whole of the session because I know you have a lot of things to do, please feel free. It's going to be accessible later. Thank you.
Okay, any questions on this? No? Okay, the incoming solar radiation to the Earth can be classified into 5 categories based on their wavelengths. Anything below 280 nanometers is called UVC, ultraviolet C. 0% of it arrives at the Earth. The reason for this is oxygen molecules absorb UVC. So there is no UVC coming here. Now, I don't know how to put this. There's a relationship between the wavelength and its toxicity. Shorter the wavelength, more toxic. Longer the wavelength, less toxic. So surprisingly for us, 0% of the UVC, which is less than 280 nanometers, is coming to the ground. The ozone in the stratosphere is filtering the light between 280 and 320 nanometers, which is also known as UVB, therefore it only comes 0.5%. The wavelength between 320 and 400 nanometers is UVA, about 6%. But the 2 major wavelengths of light radiation coming to the surface are 400 to 800, known as the visible light, 50 to 51%. Wavelength above 800 nanometers, which is known as infrared radiation, 42%. Now, visible light is the one that is allowing us to do what we are doing, because if there's no visible light, I won't be able to see you, and you won't be able to see me. Visible light is also the wavelength that allows plants to assimilate carbon, red light and blue light, and they are here. Now, how is the ozone produced in the stratosphere? I mentioned it's produced by natural reactions. Oxygen molecules in the upper atmosphere react with sunlight, and one oxygen molecule produces 2 atoms of oxygen. One atom of oxygen reacts in the next step with 1 molecule of oxygen to produce ozone. Ozone then reacts with the second atom of oxygen and goes back to being oxygen molecules. Therefore, the reaction is a steady state reaction. The forward reaction takes you to ozone, the backward reaction takes you back to oxygen. So it's going back and forth at a steady state. That is the natural, normal process. The real concern is, as you started, if human activity is increasing chemicals in the atmosphere, some of which, like chlorofluorocarbon, can destroy this reaction or cause imbalance then you have a problem of loss of ozone. And that leads to the concern about increased skin cancer. Any comments, questions? No? The natural process we are talking about, here's an example, Mount Tonatiuh. This is one of the most violent volcanoes that occurred in 1990 in Philippines. The following summer, we had the worst rains in the United States in the northern part. And following that, we had the worst snowstorms in the eastern United States. The reason for that is there are two fractions of particles in this plume. There are particles you can see. Any time you can see particles, that means it's dust or something similar. On the other hand, there is a fraction in this plume that you can't see. And these are particles that are very small, less than 1 micrometer in size. I'll show you later on the difference between the two. And these particles are very small, actually circling. The volcano erupted in 1990, and we can still measure the dust in the atmosphere. Because these particles don't fall down, they don't follow the laws of gravity. But they cause condensation nuclei. How many of you know about the cloud formation? Anybody here? Clouds are formed by condensation of water molecules around particles. Because water molecules cannot condense unless they have a substrate. And dust acts as a substrate, and water molecules condense around the substrate to form clouds. And when you melt the cloud, you get rain, lluvia. So when this happened, the following summer and winter, we had torrential rains and huge snowstorms in the United States because of general circulation. Anybody know what general circulation is? Because the earth rotates at an angle, it's called Coriolis, the upper air in the northern hemisphere moves from west to east. So when, for example, you catch a plane and you want to go to Europe, and if you look at your timetable when you buy the ticket, you'll see always the time it takes to fly from here to Europe is smaller or lower than the time it takes for you to come back. Because in the northern hemisphere, the wind is going west to east, so you have tailwind, so the plane is going fast. When you come the other way, you have headwind, so you're slowed down. So when this exploded in the southern hemisphere, it simply circulated, came to North America the following year. Anybody know what this is? Oil fires in the Gulf. After the first Gulf War, the Iraqis purposefully burned all the oil so nobody else can get it. And this oil fire produces smoke.
Actually, no everybody, just United States.
What? What is that?
Because you said the Iraqis burn the oil
Yeah.
wells
You're saying,
because to avoid that everybody takes. No everybody, just United States.
anyway, independent of who takes it.
Okay.
What happened was, after this plume that's coming is water insoluble because this hydrocarbon, unsaturated compounds like hydrocarbons are water insoluble. And therefore, these particles essentially allowed water molecules to accumulate from the Gulf of Arabian Sea, and they got torrential rains in Pakistan, in Iran, every place downwind. Remember, these hydrocarbons are carcinogens. So a lot of people who did not realize this, kids and children and whatnot, were playing in the rain, getting coated with this thing. So there has been an increase in cancer in these places. You don't hear about it, but there has been. Then there are fires like this. Stupid gringos. I will tell you why. back in the 70s, copper was in short supply. And they make wire, electrical wire from copper. And it's insulated with plastic. And so some stupid gringo decided if you take all the best wire and burn it, the plastic, you get copper. And so they took these wires, tons and tons of this, and burned it. And you generate hydrogen chloride. Because plastic is polyvinyl chloride, so when you burn it, you generate hydrogen chloride, which is one of the most toxic compounds in the atmosphere. This is the reason why when you have an accident in a train, for example, carrying chemicals, they evacuate because you'll be killed otherwise. Here is another example, Siberia. This is before Amazon. In Siberia, they were burning, in Siberia, they were burning forests, hundreds of square kilometers of forests, to recover the land for agriculture. And these fires generate 30% of the global composition of hydrogen chloride, methyl chloride, two chlorine compounds. Then you have this problem. This is in Canada. Somebody decided they want to get rid of all the tires from cars because there were too many tires. The very first time I came to Mexico in 1967, I was stupid. I had no idea that it is very difficult to drive in Mexico City. So I rented a car in Morelia and drove through all these things and got up to Mexico City. And something immediately hit me in the eye like a fire. I found out they were stealing all the caps for the tires, and they made a pyramid out of it. And if you lose the cap in your car, you go there and you can buy it back. You follow what I mean? So what these people did was to burn the tires, to burn the tires without realizing rubber is a polymer of chloride. So they generated massive amounts of the same kind of thing. Now remember, these pictures are very impressive. They don't occur very commonly. I just wanted to show you the extreme cases. These days, the so-called air quality change is very subtle. It's not as dramatic as you see here. Now another natural process is this. Here is Africa, and this is the Saharan dust moving across the Atlantic to Estados Unidos. Everything is Estados Unidos. Everything goes there. Okay? So this comes to Florida. This comes to Florida, and in fact, if you go to the right place in Florida in the spring, you'll see that the soil is red because of clay. And when this happens, you get a slight white coating. And the purpose of this particular issue is this dust act as condensation nuclei, and much of the monsoons you get in Florida is because of this. What this is telling you is pollution is not restricted to the local scale. Air pollution is transported across the globe. We can pick up pollution from Asia in Europe. We can pick up pollution from China in Western United States. So when you're talking about climate change, you should put these things in the proper perspective as to how this play a role in the so-called climate change. Here is another example. China. Here is Beijing. You can see the amount of smog on any given day. It's almost like 1/4 of China. I was in Taiwan some years ago to do some work for the government. I finished the work very early, sooner than they thought. They thought I was going to need 1 week. I finished in 2 days. So then they said, we are going to give you the royal treatment, show you everything. So they drove me around, and then we got up on this big mountain. They said, there is Shanghai. I said, where? Believe me, it's there. Because the pollution is so heavy, you could see it. It's the same thing. About 4 or 5 years ago, my wife came with me to Mexico City. And we were staying in this big hotel near Chapultepec Park. And my wife got up in the morning, took her fancy camera, went to the balcony and wanted to take a picture of the montaña. There was no montaña. She says, where did they go? I said, they're there, believe me. So, this is a big problem. Now let's talk about a continental scale problem. If you look at the weather, it will show you this type of picture, which is called the cold front. Cold front simply means the air from the west is moving below the warm air to the east. The cold air from the west is moving below the warm air to the east. Warm front means the warm air from the west is moving above the cold air in the east. These are very important in transport of pollution. Because when you're talking about transport of pollution produced in one place to long distances, you need to understand this phenomenon. You have low pressure and high pressure systems. And when you have low pressure system, in northern hemisphere, the air always moves anti-clockwise. If you have a high pressure system, the air always moves clockwise. So for example, the most polluted part of our country is the eastern United States. And California, I remove California, most of it is in the east. That's where most people are living, that's where most of the pollution is. If you have a high pressure system in the east, the air is moving clockwise. So it's picking up all this pollution from the east, moving across the Gulf straight into the central part of the United States. So although the states in the middle of the country are not producing the pollution, they're getting it. So from a meteorological point of view, you need to know these basic functions at various levels so that you can then interpret these issues on a climatic change. Now at a local scale, this is what you'll have. Normally, if you look at the temperature will decrease exactly 1 degree Celsius for every 100 meters in height, normally. But sometimes the temperature will increase with height. This is called inversion. When you have inversion, the pollution is kept close to the ground. That's when you get the most smog, most pollution, and most effects. It's very common in Mexico City, for example. This occurs about 70% of the time in the summer. People have been fumigated with ozone several hours a day for all summer in Mexico City. That's what happens. And Doctora has the right answer for it. Don't worry about this. We are adapted. Here is a high pressure system. This high pressure system developed in Atlantic. This is Katrina. And so what you see here, the high pressure system is moving clockwise, and that's very typical when you have severe weather. This is Katrina. I think that's the last one. Okay, now we can move on to number 2. Dos, por favor. Any questions, comments on what I said? What I'm trying to do is to walk you through 4 steps. In the first step, I've been discussing the basic concept of meteorology, because meteorology is the basis for climate. In the second step, I will take you to what are the sources of chemicals in the atmosphere and where are they coming from. In the third step, I will actually take you to climate change. And in the fourth step, I will take you the effects. Why are we concerned about this? So I'm going to take you through 4 steps. Now I've finished the first step because it's very simple, quite easy. Any discussion, comments?
The only comment I think that I would like to make is that I'm the only chemist around. So
Maybe I should ask the question. Could you please tell me what you do, one person at a time, so I can get a better understanding of what you do? Starting with our gentleman to the left here.
Well, actually, I don't have any contact with the field.
No. I would like to know what is your specialty.
Oh, right. Well, I work on political analysis.
Okay.
I'm interested in the process of governance in the environment.
On politics.
Yeah.
Okay, that's easy.
It's very easy. But I have a question.
Sure.
Please, I would like you to remind me of my old classes on oceanography.
Can you speak into the microphone? I can't hear you.
The point is that the last slide you presented was you mentioned that high pressure system in the Atlantic Ocean are clockwise. My question is, what happened in the Pacific Ocean? Is counterclockwise?
You get a similar problem. Like for example, if you look at LA, Los Angeles, anytime you have ocean like this, the water in the ocean is cooler than the water on here. So when you get pollution, for example, in Tijuana, if the pollution on the high pressure, let's say, the pollution will move around and go into the ocean, except it can't. The reason it cannot is the air coming from Tijuana is warm and the ocean air is cool.
Mm-hmm.
So the cold air pushes the hot air back into Tijuana. And if this happens frequently, you'll get more and more accumulation of pollution in Tijuana. This is what happens in Los Angeles. Los Angeles is much bigger, of course. They produce much more pollution. That pollution is trying to go into the Pacific Ocean. Except the ocean says no. With Los Angeles, there's a different problem, namely on this side, there are montaña. So it's caught on both sides. On one side the ocean, on the other side the montaña. And so what happens is the smog that's produced in Los Angeles, you know where San Bernardino is in California?
Mm-hmm.
If you go to San Bernardino in the Mount Sierra Nevada, not Sierra Nevada, what do you call what mountains are there? Sierra. Anyway, if you go to the mountains in the San Bernardino and stand there on top of one of the open areas and sit and watch, you can see this thing coming at you. About 2 o'clock in the afternoon, it's all from Los Angeles, sitting on top of San Bernardino. So that's the same effect you get here. So anytime you have an ocean, you have a problem. And this happens in the Atlantic, it happens in the Pacific. But the composition would be different. Like for example, if you take Yucatan or Mexico, most of the time the hurricanes can come from Atlantic. That hurricane would have, because of a high pressure, that hurricane would have a different composition than the hurricane that comes from the Caribbean, because the Caribbean hurricanes are coming under low pressure. You see what I mean?
Mm-hmm. Mm-hmm.
So it's not only the number of times you have this, it also depends on where it's coming from.
All of these events are related with the Coriolis effect, isn't it?
Correlation with?
Correlated with the Coriolis effect.
That's at a global scale.
Mm-hmm.
This we are talking about a continental scale. You have to look at different levels.
Mm-hmm.
Local, continental, global.
Right.
Okay.
Okay, thanks.
Well, I'm finished my master degree in the Colegio. I study veterinary medicine, so I have been working in agro ecosystems. That's
I'm a linguist from Long Beach, and I teach English here.
Okay.
But I'm also doing workshops about reuse of materials in communities that don't have access to them. I am technical assistant, and I'm working with GIS.
I am doing political analysis of water management in agriculture.
Yeah, I work for the Department of Environmental Studies department, and I do environmental economics.
Well, I'm an ecologist. I work mostly with plants, and well, most of my work is related with conservation issues. I'm very interested in your research related with lichens. I would like to have a talk to you later, or maybe some other day.
I have a question for you. Agricultural economics.
I do environmental.
Environmental economics, pardon me. How do you put value to effects that you can't actually quantify?
Oh, that's a good question. Actually, that the economics they can arrive to an agreement to do that. There are a lot of techniques to put some valuation. To evaluate services and environmental goods as well. It depends on what kind of value you want to input on a service or environmental goods.
The question I have is, how do you quantify the uncertainty with your results?
That's a good one. I don't know. I have no proper answer for that.
See, this is the problem we have in our country. There are air quality regulations. These regulations are based upon the way the air quality regulations are set up is to prevent increases in certain pollution because it will cause negative effects on human health or human welfare.
Yep.
Welfare being the environment.
Yeah.
Now, US is the only country where in order to regulate, you have to analyze cost and benefit analysis. In Europe, they don't do this. And the cost and benefit analysis is the most controversial part. Because, for example, in the last review on particulate matter, I was one of the reviewers. I don't think people are going to argue that increase in particulate matter will cause asthma, emphysema, bronchitis. Nobody's going to argue that. But when you say 100 million people are going to die because of this without any basis, the question arises, what uncertainty you have with something like that, and how do you put a value on a human being's death?
Yeah, may I have something? May I say something? These issues that you came out related to cost-benefit analysis, and they are very, they've been changing to the times, because now, in order to deal with uncertainty, they put some other factors, not just the cost and benefit, just put human welfare and morbidity or mortality, and as well, there are new ideas related to ecological economics, not just the environmental economics, which is more complex. And in ecological economics, it has this kind of difficulty to measure some issues related with energy and transfer of energy between levels of human activities.
You see, when you can quantify a variable, you can do something like you're saying. Like, for example, there are 423 national parks in the United States. Believe me. 423 national parks in the United States. You don't hear the names of all of them. You only hear about Yellowstone and Rocky Mountain and Big Bend National Park and what do you call Sequoia National Park and so on. The National Park Service has, I think, close to 1,000 monitoring stations to look at visibility. One of the things that happens when you have the particles that are submicroscopic, they cause visibility problems. So, for example, if you've been to Big Bend or to one of the other parks where there's a lot of people, you'll see haze and loss in visibility. The air is not clean enough for you to see, like even Grand Canyon. And the problem is, Park Service knows there's a visibility issue, but they have never quantified this. The only way you can quantify is if the number of people going to park are getting smaller and smaller, but it's not happening. This is a problem when it comes to certain aspects of environment where you cannot quantify it. Like, for example, they have a regulation for ozone. They did studies on ozone in a plot about this big and tried to say this is what is happening in the entire North America. That's not true. So this causes a lot of controversy. Matter of fact, this is really ironic. When I was young, my father was a jurist. He was an attorney. He wanted me to become a jurist. I said, no. Jurist is not for intellectual people. This is for people who cannot count, who cannot do chemistry, who cannot do physics. No, not for me. I'm going for the big time. Now I'm cursing myself because these people are laughing at me. In my country, every time we have one of these laws, the first thing the industry does is to take them to court. Immediately, take them to court. And for the next 5 years, they're arguing. Meanwhile, the attorneys are getting paid by the hour, $500 an hour. By the time the case is over, this attorney has got $15, $16 million. I'm sitting here earning university salary, and these guys are laughing at me. And they're using my data. So this is the problem. In Europe, they don't have cost-benefit analysis. In the US, they do. Net effect, it ends up in controversy. And same thing, you are a political analyst. There are two things a dog can do. A dog can wag its tail, or the tail can wag the dog. In my country, scientists collect data. And to a large degree, they have to publicize the data. Because in order for them to continue to do research, they need money. So immediately they publicize the data. And the news media sees they can sell more news because it's very interesting. So the news media grabs this and publicizes. Immediately, the politicians see this. Oh my God, the sky is falling, so we got to do something. They pass a law in the Congress to get money. The money goes back to the scientists who started this whole thing. This is how the system works. Acid rain, for example, when it became an issue, the politicians allowed $700 million in research money. At the end of 10 years of research, spending all this money, they could not prove anything. So the Congress said, no more, none of us. No more research money. They took all that money, put it in climate research. And these people are not foolish. The same scientists who are acid rain experts now are climate experts. See what I mean? The reason for that is the politicians in my country have no understanding. I mean, like yesterday or the day before, somebody asked me what I thought about Al Gore. And I said, he's laughing at me. I said, what do you mean? he's charging $50,000 per lecture. And I had to pay 5,000 rupees or whatever it is, dollars, to give a lecture. He's not a scientist, I'm not a politician. But it works, you see, for them. You see what I mean? Anyway, pollution does not cause the same effect everywhere. Here's an example for you. This is also from China. On this particular day, here is pollution forming clouds, dust. And so you have increase in cloud cover. Therefore, you'll get increased precipitation. Here, on the other side of this mountain, the pollution is actually reducing the amount of clouds. You can ask the question, how can pollution reduce clouds in one place, increase clouds in the other place? Very simple answer. There's a balance between the amount of dust and water vapor. If the water vapor happens to be in higher levels than the dust, you get clouds. If the dust is higher than the water vapor, you don't get clouds. You get drought. You have no water coming down. So the same pollution can have two different roles. Okay. So when you say climate change, you should not use a single conclusion that's good for the entire world, because much of this are local issues. What are the kind of chemicals in the atmosphere? I won't go into the great details, but to give you an example, there are chemicals that occur at a very local scale. Ammonia. Ammonia, for example, is produced by animal agriculture. The biggest source of ammonia at the ground level is the animal source. Now, I have a question for you. Ammonia is a cooling gas. In order for warming to take place, you need gases that can heat. Ammonia cools. In fact, in my country now, because chlorofluorocarbon is not allowed, they're using ammonia in the refrigerator and the air conditioner. So the question is, should we control ammonia?
I don't know. If you say that agriculture is the main source of ammonia, we need agriculture in order to survive.
We need agriculture.
Yeah.
At the same time, they want to control ammonia because of the smell. Water is the issue. And they want to control ammonia. And I've asked the question, ammonia helps to cool the atmosphere and not heat. So should we control ammonia because of water, or should we allow ammonia because it's cooling? Which one?
I suppose that we need rather to go through looking for a balance between the cooling factor and the heating factor.
Well, the real problem is the following. Since ammonia is a very local issue, you can only get cooling very locally. Like, for example, 1 square kilometer maybe. It has nothing to do with global warming.
So that's a matter of scale.
Yeah. There are substances such as sulfur dioxide. Sulfur dioxide is produced by coal combustion, and it's a local problem. Then there are regional problems like ozone. Ozone is a regional problem. Then there are global issues: carbon dioxide, temperature, moisture, UV radiation, winds. So depending on the nature of the pollution, the effect can be at different levels: local, regional, continental, global. Now let's talk about the source of sulfur dioxide. The major source of sulfur dioxide, of course, is fossil fuel combustion. 80 teragrams or 10 to 12 grams per year. Look at this. The second biggest thing is the ocean. It has nothing to do with people. oceans produce dimethyl sulfide. If you go here on a very hot day, have any of you smelled the air? It smells like rotten eggs. Have you ever smelled that?
Mm-hmm.
That's because of dimethyl sulfide. And you see, dimethyl sulfide is the second biggest source of sulfur in the atmosphere. If you look at soils and plants, they're also a source. Volcanoes, another source. So there are both natural and anthropogenic or human-made sources for sulfur dioxide. Similarly, if you look at oxides of nitrogen, fossil fuel combustion is the biggest source. Biomass burning. Biomass burning means agricultural burning or forest fires. In the northern states, we don't burn. The reason is very simple. Our entire summer is 120 days per year. Every crop, for example, in the Midwest is made to grow and mature in 120 days. If you don't have a crop harvested in 120 days, there is no guarantee you'll have a crop. And then snow comes. So all the plant material is under snow. So by the end of this winter, when the spring comes, all the biomass that's inside the snow decomposed. So the farmers go into a field and simply mix it up. So there's no burning. On the other hand, if you go to California, they grow 3 crops a year in a given field. Correct? Am I correct? They don't grow crops in Long Island, Long Beach, but nevertheless.
Central Valley.
Yes, San Joaquin Valley. They grow 3 crops a year. And therefore what they have to do is to grow one crop and get rid of the residue. And the only way they can get rid of the residue is to burn it. Now in California, the illustrious governor is trying to pass more strict laws to prevent burning. So if they prevent burning, they don't know how to grow a second crop. Okay. Sugarcane, for example, the only way to harvest sugarcane is to burn. You burn the leaves and then you have the cane to harvest. So biomass burning is a major source of oxides of nitrogen. Now what is more interesting is this, lightning. Lightning produces nitrogen, oxides of nitrogen. Now question, how can lightning produce pollution? Anybody? Any comments?
Because it's giving enough energy to break the bond that exists in the atmospheric nitrogen. That's why.
Pardon me?
Because lighting is providing enough energy to break the bonding that exists in atmospheric nitrogen, that already exists in the atmosphere.
Nitrogen is 78%, N2. So when lightning strikes, it has enough energy to convert the nitrogen into oxides of nitrogen. Now, why are we concerned about oxides of nitrogen? Oxides of nitrogen is one of 2 chemicals that produce ozone. Okay. I'll come to that in a short time. Anyway, methane. Methane is a heating gas. And the largest source of methane is natural wetlands. The second biggest source of methane is rice paddies. Can you guess what percent of the global population eats rice? Huh? More than 60%. Of which 80% is in Asia. Now imagine the population of Asia is increasing very rapidly. There are 2 reasons for it. What is the country that has the highest population? Anybody know? Country with the highest population.
China, of course.
Used to be. There's a difference. For the last several years, in China, families are not allowed to have more than 2 children. In India, there's no control. So if you look at the population of China and India now, India has more people than China.
Absolute values.
Pardon me?
Absolute numbers.
Absolute numbers, yes.
No.
Oh yes. I can send you the statistic. If you can give me your email.
Yes.
And the reason I'm saying it is, whether India, China, it doesn't matter. The reason I'm saying that is, as population increases in Asia, more and more land has to be converted to rice to feed. That means more and more methane emissions. You know the word discrimination, what that means?
You said yesterday.
Discrimination?
Discrimination. You know what that means?
Segregate. Kind of segregate.
For example, discrimination, natural discrimination, takes place in these gases. For example, if you assume carbon dioxide causes heating of the atmosphere equal to 1, it's called the global warming potential. If you theoretically assume the molecule of carbon dioxide causes global warming by 1 unit, global warming potential. Methane will cause global warming by 26 units. In other words, 1 molecule of methane is 26 times more potent than 1 molecule of carbon dioxide. If you take nitrous oxide, it's hundreds of times greater than CO2. If you take chlorofluorocarbon, it's thousands of times greater than CO2. See, people don't know this. It's not just the amount that's of concern. It is the effectiveness of a particular gas and how much you should control it, because if you control a particular gas, certain amount of percentage, it does not necessarily mean you'll get full benefits, because the other gas might not be, is not controlled, it'll keep going up. See what I mean? You understand what I'm saying? Everybody? Now let's talk about carbon monoxide. Carbon monoxide is produced by conversion of methane in the atmosphere. That's one source. Hydrocarbons are also converted to carbon monoxide, another source. If you look at human contribution, fossil fuel combustion, forest fires. Now, carbon dioxide and carbon monoxide are like twins. CO2, CO. If you have more complete combustion, you'll get more carbon dioxide than CO. If you have less complete combustion, the CO2 concentration will increase. So it's the amount of combustion that's important. Carbon monoxide is not involved in global warming, but it's involved in the fact that 1, it's part of the ozone production. 2, it's one of the most toxic chemicals in human health. It's a colorless, waterless, tasteless gas. So for example, when you hear somebody is being killed in a fire in a house or something of the kind, what do you think is killing them? If you look at the newspaper, they'll say smoke. Carbon monoxide. The person is dead immediately, not from smoke. The issue is, why is carbon monoxide so poisonous? What makes your blood red? Anybody know? Why is your blood red?
Hemoglobin.
Hemoglobin. The function of hemoglobin in the blood is to control the oxygen flow. So when you have carbon monoxide inhalation, the carbon monoxide goes and displaces the oxygen and forms carboxyhemoglobin, which means your body is starving from oxygen. And the first effect you'll get is you lose your brain because there's no oxygen in your brain. That's how we die from carbon monoxide poisoning. Oxygen depletion. Now let's talk about ozone at the ground level. The ozone in the stratosphere is produced naturally. The ozone in the troposphere is primarily produced by human activity. Now, however, there is a natural ozone, however, there is a natural ozone profile every year. If you look at this, the peak natural ozone occurs in March-April period. That's spring. So if you get high concentration of ozone in the spring, it's primarily due to natural production. There is also natural production of oxides of nitrogen, right here. And they increase the concentration of ozone. Then there is local ozone production from pollution. Then you get transport of pollution from another place. Now what you see here is the following. The peak concentration you have in the spring is extended all the way into the fall when you have pollution. What does this mean? It means crops and forests are exposed to longer periods where you have pollution as opposed to places where the air is clean. So in other words, this is the reason why you get negative effects in places where you have high ozone. So for example, here's an example, Minnesota, North Dakota. I always tell the total population of Minnesota is 4.3 million, smaller than Guadalajara. If you look at the population of North Dakota, it's 3 million, lesser than, maybe slightly bigger than Tijuana. And so if you look at the ozone peaks, here is April, May, we have the highest peak here because the air is relatively clean. Now let's look at another one. Here is another curve. This belongs to Pittsburgh, Philadelphia, Baltimore, which are polluted areas. You see now the peak is started here, is moved all the way there. So depending on the crop and the forests you are looking at and their maturity, they are affected differently because they are exposed to different amount of time. So when you do economics of crop loss, if you don't consider this, you won't get the right answer. Any comments, questions? How is the ozone produced at the ground level? Remember, in the stratosphere, ozone is produced from oxygen molecules directly converted to ozone by sunlight. So there is only a one-step reaction. Here, at the ground level, the ozone is produced from hydrocarbon and nitric oxide. Hydrocarbons and nitric oxide react to produce nitrogen dioxide. Nitrogen dioxide in the presence of sunlight produces nitric oxide and oxygen atom. Oxygen atom reacts with oxygen molecule and you get ozone. This reaction is driven by sunlight. That means the highest amount of ozone at the ground level is produced in the summer when you have the highest amount of sunlight, not in the winter. Okay? Any comments, questions? No? So if I were to draw a theoretical diagram, here is the morning. The automobiles, thousands of people are driving to work. There's a lot of traffic. So the nitric oxide that's produced is being reduced by conversion to nitrogen dioxide. In the afternoon when the sun is high, this nitrogen dioxide reacts with the hydrocarbons and you get ozone. So the highest amount of ozone you get in a given day would be in the later part of the afternoon when the sun is hot. There's a direct correlation between temperature and ozone. There's an inverse correlation between relative humidity and ozone. Okay. Particulate matter, dust, you think. Wrong. Particulate matter everywhere in the world has three categories of size. You have what are called as nanoparticles. These are 0.001, 0.01 micrometer in size, and you cannot see them. Now, is there anybody here that is expert in refrigeration, repair refrigerators, air conditioners? The reason I said that is, if you take a refrigerator, there's a coil in the refrigerator. This coil contains freon or ammonia or something. Normally, they're compressed. There's a compression that runs and compresses this gas. But when the refrigerator needs to cool, this gas is slowly released. And when the gases expand, they cool. And so when the temperature is reached, it's compressed back again. Okay. So every gas, when it expands, it cools. The reason I'm saying that is, if you take a chimney and the smoke is coming out, that smoke is hot. Otherwise it would never come out. In order for it to go up, it must be hot. So the plume, the smoke that's coming out of the chimney is hot. But then when it comes to the outside atmosphere, it's cooling because it's expanding. When it's cooling, the molecules in the smoke collide and they form particles. These are the particles that are called nanoparticles, right here. Then the nanoparticles collide to form what are called as fine particles. And these are approximately 0.1 to 1 micrometer in size. Now, if you were to go by a place that's very dusty, you're taking a walk and there's a place where it's dusty. You inhale the dust. How do you react?
Sneezing and coughing.
Coughing? Yeah. What else?
Sneezing.
What is it?
Sneezing and having some.
Sneezing?
Yeah.
Okay.
Having some effects on
Sneezing.
your eyes.
The reason is the bronchial system can be divided into two parts, up to here and then here. And the so-called dust you're inhaling is finished here because you're coughing, you're sneezing, you're spitting, so they're all gone. But the nanoparticles and the fine particles that you cannot see are here. And that's when you start getting problems because of your lungs. Once it enters the lungs, that's when you get difficulty breathing, asthma, emphysema, even cancer. Then there are particles that are very large, 10 to 100 micrometers. This is dust. Now, the summary is nanoparticles and fine particles are produced by chemical reactions. Dust is produced by mechanical activity. Dust is a local problem because dust follows gravitation, falls down quickly. If you, for example, go to the agricultural field and you see the fellow plowing the field and you stand there and watch, you'll see the dust come up. And the dust will immediately disappear in almost 100 meters because of gravity. On the other hand, these are regional problems. One of the main problems these cause is smog. So when you see smog, that smog is mainly composed of this. This is very similar to fog. When you have fog, you have water droplets that they are so small, you cannot see them. All you see is the haze or the fog, as you can see. On the other hand, with a raindrop, you can see it. That's the difference. Why am I showing this? This also is part of global climate change. When you get the sunlight coming to the ground, there is direct sunlight that comes to the ground. There is what is called as diffuse sunlight that comes to the ground. What these particles do, is to intercept the sunlight and change the angle. So instead of coming straight, the angle is changed to the side. So it becomes diffuse. And when they become diffuse, they're actually cooling. So when you say global warming, people don't realize it's a balance of heating and cooling occurring at the same time. If the heating is more than cooling, you'll have warming. If the cooling is greater than heating, you'll have cooling. So you cannot generalize. Any comments, questions? Now, let's look at the composition. The particles, as I told you, the so-called large particles are gone from here. The so-called small particles are here. Now, there's a difference in the composition of the large particles and the small particles. Like, for example, if you take aluminum, it's primarily in the large particle. The reason, the main source of aluminum is soil. Soil dust creates aluminum in the atmosphere. If you take calcium, the same thing. The large particles contain much more than the small particles. If you take iron, it's the same thing. Large particles contain more iron than small particles. But if you look at ammonium, you see the small particles contain more ammonium than large particles. The reason for this is ammonia is a gas. It's converted into the atmosphere to ammonium, which is a particle. So it's produced by chemistry in the atmosphere. Similarly, if you take sulfate, you see the fine particles contain large amounts of sulfate and the coarse particles contain much less. The reason is this sulfate is produced from sulfur dioxide in fossil fuel combustion. So you see, not only the physical size is important, but the chemistry is important. So if people are breathing small particles into their lungs, the small particles contain the toxic material, so you get health problems because you actually have more toxic material in your body than what you have given up. Okay. Organic pollutants. I won't give you a lecture in chemistry, but these are all carcinogens. Carcinogens are produced in combustion. These are very difficult to measure, so you don't hear about it. So when you talk about environmental economics, one cannot place values on a problem like this because we simply do not have enough measurements. And we also simply do not know what is the threshold concentration of these compounds on humans. Because you cannot go and test people by feeding carcinogens, can you? Anybody think they can? You get a bunch of guinea pigs, human guinea pigs, and test them with carcinogens? You can't. So all the data they have is based on two things. One is experiments with animals. Experiments with animals. I've seen people work with rats, rabbits, donkeys. You know what a donkey is? They've even used donkeys.
I do beg your pardon, the Tijuana donkeys are famous. Huh? The Tijuana donkeys are famous.
So that's the problem. You cannot put a value because there's no way. So that's one technique of experimenting with animals. The second technique is called epidemiology. Anybody know what epidemiology means?
It's the study of disease in a very big number of animal, of person. That's
Epidemiology is a science where the sum of all factors measured either show the cause or do not show the cause. That's epidemiology. Now, epidemiology is based largely on statistical correlation. Okay? I teach my students, correlation does not mean causality. You know what I mean? Correlation does not mean the cause. Let's assume for a minute. I went to some Pemex in a red car and showed the gunman the fellow in the Pemex and took all the money and drove away. The fellow calls the policia and they come, he describes the red car and he says, that's the fellow who robbed my bank, I mean my Pemex. Meanwhile, you are driving a red car over there somewhere. And the police see the red car. They say, we got the man. Just because both of us have been driving the same red car, are you the person who robbed the Pemex or me? Causality, correlation is not causality. Okay? This is a joke. This happens in our country all the time. If you watch TV, I tell this to my wife, who is not a scientist. I'm trying to make her one, but kind of late. Okay. After being married for 43 years, there's no chance for her to become a scientist with my... Nevertheless, if you look at the TV, they'll tell you scientists have found if you drank 2 glasses of vino tinto, you won't get cancer. Today, the same TV channel 2 months from now will say scientists have found if you drank 2 glasses of vino tinto, you will die 10 years sooner. What does that mean? Because these people are using correlations, but they cannot explain why. So epidemiology is a very dangerous field because it does not really establish true relationships. On the other hand, you can establish true relationships with plants, with ecosystems, because you can subject various components of the ecosystem to various forms of stress and establish cause and effect relationship. But then there is also a bias on the part of people, and that is when we as environmental scientists, the first thing we do is to look for a bad or a negative effect. That's not true. That's only part of the response curve. Unfortunately, there's no blackboard here, otherwise I'll show you one. And that is, I don't know how to do this. If I had a blackboard, I can draw a picture, but I can't.
I can get you one, but it's going to take some time.
Yeah, we can take a break, talk a little.
Talking about breaks, we are going to have lunch at 1:45.
Okay.
And all of you, of course, are invited.
Well, we can talk a little bit if you want to go get the blackboard.
Okay. Okay. There is something else. Here we have our professor of statistics. He may say something to that point.
Well, he can. He can, but he'll be surprised as to what I'm going to show.
Oh, that's a surprise. Great.
There are the human toxicology people have done much more advanced work on toxicology than plant people. Rightfully so, because people are concerned about their own health. So there has been a lot more research done on human toxicology than on ecotoxicology. Therefore, they have proven a lot of things in concepts of toxicology. And unfortunately, the ecologists ignore it. Because, like for example, assume for a minute I'm working with frijoles, and my objective is to show ozone is reducing the yield of frijoles. I will design an experiment to prove ozone is reducing frijoles. But I would not design an experiment to prove the true relationship between exposure and frijoles. So I'm biased. I'm going with a biased idea in my mind before I even start. And so what happens is, when they establish new mathematical curves, the whole section of the curve is missing. You know what I mean? Anybody? I'll show you in a minute. I'll show you, draw a picture, you'll see. Well, I'll give you an example. Let's assume for a minute you are having a party. You drank one cerveza. What happens to you? What happens? You feel good. You have two, you feel a lot more good. But if you had 10, you don't feel good. So what it's telling you is, in small amounts, air pollution is good. For example, if I take sulfur dioxide, if I allow relatively low concentrations of sulfur dioxide in the atmosphere, it will stimulate the crop production in a sulfur deficient soil. There are soil is the major source of sulfur to plants. And there are soils that are deficient. And if they are, if you have low concentration of SO2 in the air, it will actually make the crop grow better because the sulfur is missing in the soil. On the other hand, if you have sulfur sufficient soils, it will reduce the yield because the plant is already saturated with sulfur from the soil. So if you draw the relationship, if this is the concentration times time, and if this is the response, let's assume for a minute the crop yield is 100%. So here's the 100% yield. What people normally do is to design an experiment to prove that this 100% is being reduced. So they already start with concentrations high enough to show there is a negative effect. So let's assume for a minute there is a negative effect. These are the different exposures. You see, they started here, and there are no exposures below this being 0. So here is your 1 beer, 2 beers. And here you start with your 5, 8, 10, 12. Okay? Now, if I were to design an experiment to go this way, this is what will happen. You get stimulation. Harvesters is the term used in human toxicology, and you get stimulation. And you do not know where the stimulation is going to intercept. It could be here, or it could be here. So your entire equation of dose response is artifact. See what I mean? Biologists are paranoid. They're crazy people. They are not looking at this. Oops. You know, I looked at, my colleague and I looked at, I think about 80 experiments. In these experiments, we found this effect. But when we read the manuscript, there was no mention of this, because they don't want to see this. So immediately they wrote saying, this is experimental noise. Everything is noise. They make a lot of noise. It doesn't mean anything. So you see what I mean? So when you deal with carcinogens, you have no way of doing this. But the human toxicology people have bacteria on their side. So they can use bacteria in test tubes to study this kind of thing. The plant people can do the same thing. So when you say environmental economics, does anybody consider harmonic effect? No. Yeah, this is what I'm saying. There is an inherent bias in what we do. I think I'll skip some of this because it's not really relevant to you guys. I just threw this in for fun. These are forest fires in Africa. What you see is, depending on the growth season, in January it starts in the northwest Africa, north central Africa. By August it's moved to South Africa. So when you are looking at climatic change, you are not only looking at climate change spatially, you also have to look at it temporally. Like for example, I'll show this later when we talk about climate change. There are a lot of people who believe that the growth season has been changed. That's a temporal effect. I'll stop there and ask for number 3. Phrase. That's fine.
Number 3. Yes.
Delayed reaction.
I hear you.
That's not number 3. It's the
That's
wrong
not
one.
number 3. Okay.
No?
That's a correlation.
There's a space. Está bien. As I said, pollution has no boundary and is transported across place to place. Here is an example of forest fires in Greece. Oops. Here is an example of forest fires in Greece. The smoke from the forest fire is transported across to Africa. I showed this picture already. This is a natural climatic process. The question then we have to ask is, how are humans changing this? And I've shown this to you already, so I'm not going to use it now. Let's talk about climate change. Now we are really getting to the meat. There is a natural control of climate. This control of climate has been here before you and I came. This natural climate effect is also called the greenhouse effect. The reason it's called greenhouse effect is because if you take a greenhouse, the sun is penetrating the roof of the greenhouse and all the surfaces are absorbing the heat. And then some heat is being released. This heat is being trapped by the roof of the greenhouse, therefore it's a greenhouse effect. If you look at ambient environment, solar radiation is coming in. Remember, this radiation is predominantly in the visible wavelength and in the near infrared wavelength. So this radiation is coming in and all the surfaces are absorbing the heat, including people. That's why you sweat, because you are absorbing the heat. Okay. So all surfaces are absorbing the heat. There is latent heat and sensible heat. Different surfaces absorb different amounts of heat. Like for example, if you take a black road and compare it to a road made of concrete, you will see the temperature of the two surfaces are not the same, because black absorbs more heat, white absorbs less heat. How many of you own black cars? Don't ever buy one. You'll be cooked if you buy a black car. All right. So the heat that's absorbed, part of this heat that's absorbed is released back into the atmosphere, and the outgoing heat is long wavelength infrared. Incoming radiation is short wavelength, outgoing heat is long wavelength. There are certain trace gases in the atmosphere. Water vapor, carbon dioxide, nitrous oxide, methane, and ozone for given. These gases block this heat from going out. A large percent of the heat that's going out is being sent right back into the atmosphere. That's what keeps the air warm. And that's called the greenhouse effect because the effect of these gases is very much similar to the roof of a greenhouse. The concern is these concentrations of these gases have been going up since industry came along. Therefore, these gases must block more heat going out. Therefore, you must have warming. That's the whole concept of climate behavior. Any questions or comments? Pregunta? Boy.
Well versed.
Well, I mean, did you tell them they'll be examined this end of this? Let's plot the global climate from an agricultural viewpoint. From an agricultural viewpoint, the amount of sunshine is very important for photosynthesis. You don't have crops growing in Greenland because there's not enough sunshine. So if you plot the normal global pattern of number of hours up, number of hours of sunlight, that is every day how many hours you have per daytime sunshine period. Sure, Africa, North Africa, a little bit of South Africa, Middle East, inside Australia, California, are the ones with the largest number of hours of sunlight in a given season. Now let's plot what is called as growing degree days. Anybody know what that is? Growing degree days. You simply the highest temperature of the day plus the lowest temperature of the day divided by 2. This gives you the average temperature of the day. You take the average temperature of the day and you subtract what is called as T base. Now what is this T base? T base is the temperature where the growth of a particular crop will not change. In other words, it won't grow. So if you take corn, for example, it will have a particular T base. If you take papas, it will have a different T base. Because once the temperature goes below the T base, it won't grow. It's the minimum temperature above which a plant will grow. So if you take the average T per day and subtract T base, you'll get a growing degree day. And so what they do is they count the number of growing degree days per summer for a given crop. And this is what they do in the US. There's what is called as a Farmer's Almanac. It's published every year. It's like a dictionario in which the climatology people calculate this for every major crop. And the farmer then decides when to plant the crop and when to harvest the crop. That's the purpose of this particular high-powered mathematics. You can get this on Google. In the US, you can download this on the Google by crop. Huh? Yeah. So, if I plot the global growing degree days, assuming the T base is 5 degrees Celsius, this is what I get. Highest number of degree days in Africa, Northern South America, California, Middle East, India, Australia. Does it make any sense to you? Are you trying to tell me the longest number of sunshine hours is in Africa, the highest number of growing degree days in Africa, so theoretically Africa must be the one producing most crops? Correlation. The answer is no. The reason is this. This is a map of global precipitation. And if you see here, Africa has virtually no precipitation to speak of. So is the Middle East, so is inside Australia. So you see, this is the natural, current, present global picture. Now, where are these greenhouse gases coming from? From a political viewpoint, you'll be happy to know that 15% of the greenhouse gases are coming from tropical forest activities. Now, how can forest activities be involved? Very simple. Trees are a major sink for carbon dioxide. They absorb carbon dioxide. So when you cut off trees, the sink goes away. Therefore, your carbon dioxide concentrations start increasing. So tropical deforestation is a major source for carbon dioxide and other trace gases, that's 15%. If you look at energy production, that's 50%. Namely, carbon dioxide, nitrous oxide, carbon monoxide, methane, ethane, all these are produced by energy industry, fossil fuel combustion. If you look at in the chemical industry, by chemistry it means chemical industry, you have 20%. Namely, for example, products that are produced and use of CFC. Then 15% of it is from agriculture. Here you see rice paddies, which we know, and we also know about what you may call fertilizer use, cattle farming, and landfills. These are all sources of greenhouse gases. And so if you look at the change in these activities, it will reflect the change in the concentrations of the so-called trace gases. And this is what I was saying, if the population of India and China are increasing or relatively large, and you have to cultivate more land for growing rice, you are going to create more methane. There's a fellow in my country by the name of Jeremy Rifkin. He's an environmentalist. And he wrote a book on how to control climate change. And he's one of the people that does not like to be confused by facts. But he wrote a book. And one of the ways he said we should control methane production in the US is to ration cattle products. So in other words, every person gets a ration card, and you can only get so many kilos of carne per month. You can only get so many liters of leche per month. You can only get so many blocks of mantequilla per month. That way, you can reduce the amount of cattle in the country. People are saying silly things like this. That's okay. But I can imagine you going to Asia and telling them not to grow rice. The only beneficiary of that is Mexicana Airlines, because you'll take one trip and you'll never come back. This is the issue. Here is some real data of carbon dioxide. I'm showing data here from 1955 to approximately 2005. This data came from Mauna Loa, which is in Hawaii. There's the observatory on top, and this is one of the longest sets of data on trace gases. Now you can see that the carbon dioxide concentrations have gone up from approximately 1960 to approximately 2005. Now, does anybody know why this graph looks like this? There's nothing wrong with the figure. Huh? No, this is where the vegetation is a sink. This is the place where the vegetation is not a sink. In other words, this is the growing season, and this is the non-growing season. You follow what I mean?
There is no relationship with the eruption process with the volcanoes in that area?
With this data, no.
Okay.
No, this is in my, this data, no. Any other comments? I like the CO2 people. They have a global CO2 measurement network. What they do is they take a glass flask and they remove the air from the flask and close it up. And then they go someplace wherever they're studying and they open the flask. Immediately the air enters the flask, they close the flask, bring it to the lab and measure the CO2. Oh, that's all right. But the most interesting thing about these guys, and I get these letters from them, they have an annual meeting every year. These meetings are Monaco, Sardinia, Las Vegas, Salzburg, every fancy place. That's where they meet to discuss that CO2 is increased by 0.6%. I wish I was part of this team. I mean, they're having a good time.
But how can they differentiate between anthropogenic and natural sources? I mean,
Well, technically, if you do it right, how many people are here know the word isotope?
which isotopes?
Can somebody tell me what it means?
Yes, it's the same form. It's the same form. It changes depending on the. Is the mass?
Mass.
Mass.
For example, if you take sulfur, the highest sulfur isotope is sulfur 32. That is the most abundant isotope on the earth. There are also isotopes of sulfur, 33, 34, 35. 35, for example, is radioactive. 32 and 33 and 34 are not radioactive. These are called stable sulfur isotopes. You can use the proportion of stable sulfur isotope to the most dominant isotope, sulfur 32, to determine how much is not natural, how much is anthropogenic. Okay. You can do the same thing with carbon. You can separate the proportion of what's what. Okay, like for example, right now, in one of the projects that I'm doing, we are using lead isotopes. We are using lead isotopes to determine how much is produced by local industry and how much is coming in. So you can do a number of things.
Well, with lead is easier, but with the CO2 is
No problem. What you do,
which isotope?
it's no problem. You go back to the 1800 method. Don't try any new tricks. Okay? You trap the CO2 in there, sodium hydroxide. You precipitate the CO2 into carbonate, and you measure the isotope ratio in the carbonate. See what I mean?
Yes.
And we are using mercury isotopes. We are using mercury isotopes to find out how much is new mercury in the atmosphere, how much is old. So you can do a number of things if you want. It's a matter of having a little imagination. Now, I have a big mistake in this slide. I made the stupid mistake when I made the slide without knowing what was going to happen. Namely, if you look at the slide, oh, I keep doing that. Here is chlorofluorocarbon, the green color. It keeps increasing. The first chlorofluorocarbon was produced in 1950s. And if you keep seeing it, it keeps increasing. 1990, 2000. Except after 2000, there has not been any chlorofluorocarbon manufactured. So this is non-existent chlorofluorocarbon. Because I didn't know. I took the trend and calculated the last two values without knowing there's no chlorofluorocarbon.
You are going to get in trouble with the mantra.
Now, At Christmas time, in our country they have a classical movie that they show on TV called Harvey. This fellow, James Stewart, imagined he was a rabbit, 6 foot tall rabbit. And Harvey never existed as a rabbit, it was purely imaginary. That's what this is, imaginary data. But the others are correct. So if, for example, you take carbon dioxide, you see from the 50s, it's progressively increased. If you take methane, it also progressively increased. If you take nitrous oxide, it too increased progressively. Now, all this Montreal Protocol, Copenhagen Protocol, Cancun Protocol, what does it mean? I don't know. Because these people are all hung up on carbon dioxide. And all they want is to control carbon dioxide. Meanwhile, the other gases are much more active than carbon dioxide. Now, I got a surprise for you. Are you ready? All right, here's the surprise. If I assume that the air temperature is a constant 33 degrees Celsius, CO2 contributes 22% of the heating, 7.3 degrees Celsius. Methane contributes 2.4%. The reason methane contributes less than carbon dioxide is because right now carbon dioxide is in parts per million. Methane is in parts per billion. Yet 1 molecule of methane can heat 26 times more than 1 molecule of carbon dioxide. If you take nitrous oxide, 4.2%. If you take ozone, 7.3%. But here is the surprise. Water vapor, 62%. In fact, CO2 is not the main greenhouse gas. It's water vapor. See, this is the reason why I said Al Gore is not a scientist and I'm not a politician. Politicians like to latch onto this because it's politically convenient. Now, what do you think is the major source? What do you think is the major source of water vapor in the atmosphere? Dust. No, on a global scale, the main source of water vapor is evaporation and transpiration. But there are also reactions in the atmosphere that will produce water vapor. If you oxidize chemicals in the air by sunlight, you'll end up with water vapor. Now, how many of you heard about the catalytic converter on the automobiles? In a car. You know what that is? What does it do?
It's a device to control the combustion of gases.
Emissions of?
It's a device.
Yeah. Emissions of what? What emissions?
Gases. I don't know what gases.
No, chemicals I mean. Do you know?
Chemical. No.
It is designed to control hydrocarbons and carbon monoxide. Okay, at high temperature. The product of that is water vapor and carbon dioxide. So, on one side, you want to control carbon dioxide. On the other side, you're generating carbon dioxide by more and more cars having catalytic converter. Does it make any sense? No. Yeah.
But how much of that water vapor comes from anthropogenic activities?
Well, automobiles are anthropogenic. They're made by people, driving by people. Fossil fuel combustion is anthropogenic. See, it's not as simple as people like to believe. They like to use fancy words. carbon footprint, carbon sequestration. This is all by modeling. I will show you this afternoon that carbon sequestration is one of the most uncertain phenomena in modern science. If you go across the country and count the number of carbon sequestration experts, in my country, there are 6 people in the same department. And ultimately what is going to happen is nobody will be able to prove what these people are saying, and it'll go away.
Well, actually, no, it won't go away because it has been accepted by, and it's being promoted internationally. And there are places that have been practiced for years, even in...
Doctor, I'm going to put here 100 pesos on this table.
Okay.
And I bet you the Cancun protocol won't go.
There is not going to be such a thing as a Cancun protocol.
In my country, there's no carbon dioxide reduction. It's going up, it's not going down.
What?
The carbon dioxide concentration.
It's going up everywhere, worldwide.
Yeah. So what do you mean by carbon sequestration? It simply means they're looking for a way to prove that they have other methods for reducing carbon dioxide so that they don't have to change their emissions. This is what it's all about. And the point is, they have no data to do this kind of work, very little. And so everybody's running mouths. I'll give you an excellent example. The amount of carbon dioxide fixed by a plant is directly regulated by the amount of nitrogen available to the plant. People don't realize this. There's a saturation point where the plant will not fix any more carbon dioxide. And to fix that, you need to keep adding nitrogen. And so, for example, if you have a forest that's been fertilized, you'll get sequestration of carbon at a different level than a forest that's not fertilized by nitrogen. Now here's the problem. You cannot fertilize a forest. You know why? The root system will collapse. This is what happened in Duke University in North Carolina. They have the largest experiment in the world on carbon dioxide effects on fully grown mature trees. They were the first people to do this. Hundreds of thousands of dollars a summer. Everything was wonderful. At the end of the 5th year, the trees started collapsing. Turned out the roots could not take the excess nitrogen. And so when you say you're going to sequester carbon, that's not easy as you think. It depends on the composition of the residue on the ground.
And even on the type of tree that you are using.
Yeah, of course.
But I was referring not only to biological sequestration, but to geological sequestration, which is widely practiced as well.
Well, I don't know anything about oceans and caves. I'm sticking to plants.
Yeah.
I don't like to comment about some guys telling me they can pump carbon dioxide into Carlsbad caves. That's not what I'm talking about.
They do it, believe me.
So, I'm not there.
Okay.
But my opinion is, the so-called plant carbon sequestration people are creating another controversy. That's all they're doing. That's the point I was making. Because yeah. Let's ask this terrible question. Is global temperature going up or not? Now, don't bring in the little ice age and dark ages when I was dead or gone or never here. Let's talk about now. Are temperatures increasing or not?
Scientific evidence
There,
claims that they are.
well, it's not that easy. I will show you in a minute. Even the scientists are changing their mind right now as we speak.
After the battering of the IPCC.
Pardon me?
After the battering of the IPCC before Copenhagen.
IPCC report is full of mistakes. Full of mistakes.
There are some misleading.
They're full of mistakes. I don't use them. They're full of mistakes. By the way, IPCC was not written by scientists. It was written by government employees. I can tell you a little joke about IPCC, Intergovernmental Panel on Climate Change. If you look at the authors of this, there are about 20 volumes. If you look at the latest volume, there are about hundreds of authors. And let's take, for example, Estado Unidos, always numero uno. Let's go there. Almost 90% of the authors are government employees, for a starter. Then, the models are driven by emission inventory. Emission inventory is the process where you identify sources of a particular pollutant in a particular country and calculate the emissions of a trace gas from that source on a cubic meter mass ratio. Okay? Are you trying to tell me your emission inventory, for example, for Mexico is correct? Of course not. The uncertainty attached with it is so high. Can you imagine how many taco stands are in Mexico City? They're all emitting trace gases. See what they do conveniently, they only look at the ones big enough for them to see. That's not right. There's full of mistakes like this. But nobody can argue with them because they are the majority of the government. What are you going to argue? Anyway.
So you're saying that you develop any inventory of greenhouse gases emissions?
No, this is where I disagree. You don't need to use global climate change as an excuse. Do it anyway.
Yep.
I teach my students, you don't need acid rain to clean the air. Clean it up. Why are you taking a shower every day? These people are looking for an excuse. Do it. There's no need for an issue. That's the point. Is there warming? The answer is very simple. It is one. Traditionally, air temperatures, the measurement methods, the methods used to measure air temperatures have changed. In the old days, there were no steamboats. People were traveling by yachts. For example, from California to Hawaii, they'll go in a yacht. The temperature of the ocean is in equilibrium with the temperature of the air. Remember now, 3/4 of the earth is water. So what you do is to calculate the air temperature over oceans, you simply take a bucket of water and measure the temperature because it's in equilibrium with the air. In the old days, they were using baskets. And then baskets were replaced by metal buckets. Metal buckets were replaced by steamboat turbines, where the water comes into the boat, you measure the temperature before the water enters the engine. The problem is, there's no way to convert the data from the basket to metal bucket to turbines. So in the long run, we really do not have measured data that are reliable. On the contrary, there are true data, at least in my country, from 1900, where people actually have measured the temperature. Like for example, there's a family in Minnesota that started measuring temperature at 7 in the morning and 7 in the evening. And they wrote it down meticulously in a book. Now, the 5th generation of people in that house are still measuring this. There's a problem. When you measure temperature on land, there are two issues. One is you cannot use urban areas because urban areas are heat islands. They generate a lot of heat, disuniform heat. Now, for example, if you take the town I live in, there are parts of town that are very industrialized, a lot of traffic. They generate a certain amount of heat. Then there are places like where I live, there is very little traffic, no industry, so no much generation of heat. So for example, if you take a particular day when it's going to snow, the fellow on TV is telling me there's going to be a big snowstorm. Absolutely nothing at my house. The reason is, he is telling there's going to be a snowstorm, measuring the climate 100 kilometers away, where there's a heat island. So what he is predicting doesn't happen over where I am. This is a natural variability controlled by human activity. And therefore, you cannot use heat islands to measure temperature. So what happened was, in this case, Tom Carr, who is a famous climatologist, took every possible measurement in the United States. There were like 6,500 stations, of which he found 453 were not in urban area. So he plotted this graph. The upper panel in this shows the daily maximum temperature. What that means is, it's the highest temperature of the day, or the daytime temperature. The lower panel shows the nighttime temperature, which is the lowest temperature of the day. Now look at this slope here. If you look at the slope of the daytime temperature, it's relatively small compared to the slope of the nighttime temperature. In North America, the nighttime temperature has gone up by 3.5 degrees Celsius. The daytime temperature has not significantly changed. So if you average the two, you cannot establish a clear trend. But if you take the nighttime temperature, you can. In fact, there's warming at night. No question. Now, why is it warming at night? The cloud cover in North America has increased by 30% in the last 50 years due to pollution, cloud formation. And therefore, at night, the outgoing heat is being trapped by the clouds. This is also true in Europe. This is also true in China, Russia. So now all of a sudden, the so-called modelers figured this out. If you look at the latest efforts they are doing, they are trying to separate the daytime temperature from nighttime temperature. And I'm not going to predict. The results may not be the same of what they're saying. I'm sure there will be a 21st IPCC report soon, if this keeps going. I mean, this is phenomenal. My wife has a cousin. This is true. I'm not making it up. My wife has a cousin. This man is not a scientist. He is an engineer, retired. And he works for the paper producers of the United States. So they appointed him to the Committee on Climate Change. And his name is found in the latest report. Do you know he won a Nobel Prize for this? I'm not joking. He won a Nobel Prize with Al Gore. You know what they did? They took the Nobel Prize and cut it in half. Gave Al Gore one half of the Nobel Prize, and they gave the other half to IPCC. IPCC contains like 5,000 people, something like that. So one day I sat down and calculated how much money my wife's cousin could have gotten. Because what they did, when they gave the IPCC Nobel Prize, the chairman of the IPCC got the paper. He turned around, copied this, and gave it to everybody. And my wife's cousin has got it on his wall. Nobel laureate, Robert T. Wickham. And I calculated, if I took all these people and the money they gave, each guy probably got about $500. Hey, someone tell me about this. Anyway, so you see, there's a clear increase in nighttime temperature. Now let me show you an independent set of data. This is data we collected. And again, you can see there's the daytime temperature, and you can see the nighttime temperature. Similarly, daytime temperature, nighttime temperature. So there's no question that the nighttime temperatures have warmed up faster, and much more so than daytime temperature. And you won't see this if you use the average. This has implications in agriculture. Nighttime temperature speeds up flowering. Because it speeds up flowering in cereals, it makes the seed filling less. So you have less yield due to increase in nighttime temperature. This is known in plant physiology. Also, there are diseases that occur more frequently if the nighttime temperature goes up. You know why? Anybody know? Ecology?
Mosquitoes? Because there are more mosquitoes?
Mosquitoes? No. When you increase the nighttime temperature, well, let's go back. I want you to come with me in my car. Okay? I don't have air conditioner. So you get in. What happens to you about 5 minutes after? You sweat. Plants sweat. So when the night temperature goes up, they sweat. It's called guttation. You get droplets of liquid along the edges of the leaf. These droplets contain nutrients. So organisms, spores of organisms, germinate in the nutrients. And so they infect. I mean, Dr. Ra can tell you more about this than I can because he's a plant pathologist. And you increase the disease. Any comments?
Some groups do photosynthesize at night, so they won't enter in this group. The CIM photosynthesis.
I don't know. I don't know what CAM plants do not constitute the main population of plants on Earth.
Well, yes.
Obvious. We are talking about C3 and C4. And so there's a problem. I was a member of United Nations Committee on Agriculture, or FAO. One of the people at the committee showed the data, how wheat trigo completely behaves differently if the nighttime temperature goes up. So I think the politics is dictating what is in this report. And that's the reason why 90% of the people in my country are all government employees. They already made up their mind what to write. There are always two sides to a coin. Just because some guy wrote a report doesn't mean it's the next Bible. I can challenge it. There are still others, forget me, at least I admit what it is. There are others that don't believe in any of this. They think it's all a natural process. I mean, I go to the gymnasium in the morning in my town. One of the people there who knows me wanted to know whether it's going to rain that day. And I said to him, it's going to rain sporadically maybe, but I can't tell you what time. And this other fellow was standing there, I never met him before. He says, are you saying there's global warming? I said, I never said anything. I'm talking to this guy about rain. If you want to argue about global warming, I'll argue all day. It's a lot of bunk. That's what some people feel. They feel that this whole thing is made up. Now, let's talk about a separate phenomenon. Because of the rotation of the Earth, the upper jet stream, the air goes from west to east in the northern hemisphere. It goes from east to west in the southern hemisphere. Now, how many of you are cooks? How do you like to cook in the kitchen? Any experts in cooking? No? No cooks in this room? You are? Yeah, you are. I am too. I cook for fun.
Baking.
Huh?
Baking and frying.
What is that?
Baking and frying.
Is your expertise, huh?
No, it's just the survival. Not depending on the cafeteria too much.
When you wash dishes, the water is flowing. How it's flowing? Yeah, vortex. There's a hole in the sink and the water is going through there like this, like a spin cycle, vortex. That's what happens here. When the jet stream moving from the the west to east and east to west, they collide over the pole. Over the south and the north pole, they collide. That results in a vortex. All these chemicals are concentrated, like a centrifuge. That's what it is. And they are concentrated. Except you see, if you look at the temperature of the clouds, or air temperature in the winter over the poles, it's minus 150, minus 200 degrees Celsius. So these chemicals that are transported towards the pole become ice. They form ice clouds. These are called cirrus clouds. There are two major types of clouds. There are clouds here, close to the ground, called cumulus clouds, and there are clouds in the upper atmosphere called cirrus clouds. These are plain ice. So, here is an example. You can use satellite imagery and photograph different clouds. And different clouds would have different color depending on what chemical is in the cloud, ice cloud. Because different chemicals absorb different wavelengths of light, absorption spectrum. So you can look at the absorption spectrum and decide what ice cloud is made of. So in this case, this is chlorofluorocarbon. These are chlorofluorocarbon clouds. And you can do this for into nitrous oxide, you can do it for other chemicals. Because there are satellites that have multi-band spectral data you can get. From that, you can plot this. Okay. These clouds are sitting there. In the springtime, the sun rises. It's called the polar sunrise. When the sun rises in the springtime, it's melting the clouds. And so you got a soup. So for example, if you have chlorofluorocarbon, the chlorine atom in the chlorofluorocarbon will react with ozone to form chlorine monoxide and oxygen. So this ozone is being converted to oxygen. Now, if you look at the chlorine monoxide, it will attract an atom of oxygen, will result in the release of chlorine and formation of oxygen. So you see, you are losing the ozone, you are creating oxygen. So therefore, the balance that I initially discussed is no longer present. You follow what I mean? This is what causes the loss of ozone in the upper atmosphere. When you talk about ozone hole, things like this, that's when this, because of this particular problem. Now, there's an interesting situation here. The temperature in the troposphere is cold, first 10 kilometers. Temperature above the troposphere and the stratosphere is hot, warm temperatures between 50 and 50 kilometers. If you have warm air here, you have cold air here, you think this cold air can go up? Can't, because the warm air will keep it down. But slowly they can come to a balance and mix. So for example, if you look at these chemicals that are produced by human beings at the lower atmosphere, it will take years for that chemicals to completely go to the stratosphere. And this is the reason why if you were to control CFC, now you won't see an effect probably for 10-15 years. It will take that long for this to slowly go up and mix and go. So the remedy or the solution would not be immediate. It's a slow process. Any questions or comments?
I wonder if we can break at 2:30.
Okay.
Yeah.
That's
Okay.
fine.
Thanks.
Now here is some real data. I didn't make this up. Real data. Satellite data. What you see here on August 23rd, Here is the ozone at the Antarctica. Here is the Antarctica. Here is the ozone at the Antarctica. And you see the chlorine monoxide concentrations rising. On September 2016, you see the chlorine monoxide concentrations keep rising, the ozone concentrations keep declining. This is a one-way reaction. Once this reaction takes place, there's no reverse gear. The only way you can control this is to get rid of chlorofluorocarbon. But like I said, even if you controlled every molecule of chlorofluorocarbon today, the net effect you won't see probably for 10, 15 years. Can we stop there?
It's
It's a good place to stop.
okay. You feel so? I like to make a comment. We are in an institution dealing mostly with social issues. I would like to suggest that we have sometime a discussion of the participation in Cancun of Mexico at the IPCC meeting. What you think about, I think is very important. Mexico is making big efforts, spending a lot of money. I know that because we have all the time meetings and meetings and things like that. And since you have a special view of the social issues, I would like to hear something from you.
Were you at the Cancun meeting?
This Cancun meeting for December,
Yeah.
Mexico has to deal with. Yeah? And there is a lot of discussion now. And since you are in social sciences, I would like to hear a little bit about your opinion. I think it's interesting for all of us.
Are you going to be there?
I want to be
Huh?
No, I don't know. I don't think so. But I would like to hear your opinion.
Yeah.
What you, especially you, what you think about this participation of Mexico at this level and in this meeting. Perhaps it's a nice
Well, we can bring this some others. Like I said,
sometimes.
no. I'm trying to get these people to discuss. You ever gone to a dentist for your teeth?
Yes, and what about the dentist?
It's like pulling teeth. These people need to talk.
Okay.
Or if you know of somebody who is in here
No, actually, it is quite likely that I'm invited to go to Cancun, but it's going to be the summit is going to be organized by the Secretary of International Affairs, not for the Secretary of the Environment.
Yeah.
And the Secretary of the Environment, the Institute of Ecology, are going to organize a parallel academic event. For that, they are going to present the plan, the work that is developed at the state level. And because we are supposed to be one of the most advanced in that, it is quite likely that our work is going to be presented there. What is going to happen in Cancun? Not the second period for the Kyoto Protocol. Actually, we have already been told what they are going to deal with. And what the Secretary of International Affairs is going to try, they have already got the deal by now, is going to push in two senses. One is to rescue what happened in Copenhagen regarding the red, and the second it will be to sort of bring back the Bali roadmap with its 4 points. And they are going to push the second term of the Kyoto Protocol for next time, for the next summit. They are not going to go for that. And I think that Mexico doesn't have the figure. Yes, is quite enthusiastic about it. Actually, is the most active non-Annex 1 country signing agreements and too enthusiastic signing agreements. I would say.
There's somebody I know who is not going to sign.
There are many that are not
No,
going.
I know one.
Okay, tell me.
The U.S. scientific panel already decided they're not going to sign.
Yes, and China and India and Brazil and they are not going to sign. So it's
That was the latest report in the U.S. They're not going to sign.
and even if they sign it, I mean, who is going to be there in an institutional level to see that the binding is being fulfilled? Who is going to really take care of that, of all the countries? No, there is not such thing to carry out with that. Laboratory costs money, and they are less funded as time passes by. So for that you need money, you need equipment, you need people that is trained, and sometimes you don't get that. So it's cheaper to go to modeling.
Let me explain. Let me ask you a question. You've seen FACE, right?
Mm-hmm.
FACE. Can you explain to them what it is? Briefly? Huh?
Should I explain?
Yeah, briefly.
No, I can explain. Perhaps she does. What? Face?
FACE experiment.
Ah, yeah. No, face. I was thinking of something. Face is when art experiments with computer and artificial communication and the field. So they have a equipment very, very costly. Face is just in one or two places or something like that. Very few groups are able to have financial support to do this. Just imagine at the open field to maintain certain concentration of CO2. Yeah? And they fumigate, and then and the equipment open field. They fumigate, let us think, beans or soybeans or whatever at the different stages of growth.
Are they in the greenhouse?
No.
Open, completely open.
Just imagine.
Let's explain. It's called FACE. Free air carbon dioxide exposure.
Free air. Yeah.
Now, I will make life easy.
But how do you control the...
No, wait a minute. Don't get excited, everybody. Slow down. It's a circle, and the circle contains pipes, like this.
Are they on the ground or they are...
Above ground, about this height.
Above ground, okay.
These pipes have holes in them.
Okay.
Through these holes, they release CO2. Okay? When the wind is blowing this way, they release it from here,
Okay.
going that way.
Okay.
The wind is blowing that way, they release it from there, this way. Okay? But they can only use one concentration.
They can do a lot of things.
Huh?
Okay, they can only use a concentration.
One concentration at a time. Okay?
Yes, okay. Yeah.
And Dr. kept saying, open field, open field. This is also open field.
That's okay. Yeah, but they maintain certain concentration.
Yeah, so what's the use?
Okay, and what these sort of experiments, what sort of result have you got? What do these...
This is the point. These guys are all like mafia.
There is a scientific mafia everywhere, but okay.
That's the point. My point is, if you want to model or do anything,
yes, you need to have an experimental support. I do agree with that. You need to assess and cross-check and validate.
no, here.
Okay.
Here is exposure.
Mm-hmm.
Here is response.
And what you are having is only one response.
Wait a minute, let me ask these people.
Right.
If you have only 5 treatments, would you prefer that? Or if I had 50 treatments, would you prefer that? 5 or 50?
50.
Mine is 50, theirs is 5. See what I mean? You follow my reasoning?
Do you follow?
No, yeah.
Here. They only have one exposure. So if they have 5 of these, it's 5 treatments. Because in this, it takes $100,000 a summer for carbon dioxide alone. So they only have 4 or 5 or 6 rigs, everybody, because that's all I can get money for. So the treatments are 5 or 6. Here, each one of these is a treatment. And I can have 30 of them from here to the door. So I have 30 treatments in one shot.
How much that costs?
I do not know for the carbon dioxide.
Okay.
For the ozone, it doesn't cost anything because you can produce ozone continuously.
Well, carbon dioxide is cheaper as well. It's a cheap gas.
Just a generator. The reason I'm doing the ozone experiment is because somebody wanted me to help them find aerobal resistance.
Okay.
So this is not climate research, this is ozone research. But I'm just saying the same technique can be used for CO2. So when you, for example, have 30 treatments, or let's say 50 treatments, whatever it is, you can make it bigger than this room. I just pointed in the room. So in this case, in the circle, you have 5 treatments. First of all, you start drawing linear regression, so that forget about that.
Yes, you should forget about that because
I just did,
resources are not available.
yeah, because data is not normally distributed, so you cannot do linear regression. It's given.
Yeah,
So,
but you, allow me to just say something about it. Most of environmental data are not going to follow any normal distribution.
no kidding.
No kidding. And then all people consider that they do. And they treat it linearly as if they were
Yeah.
normal.
This one is,
On top of designing a broad experiment, they do treat data in the worst possible way.
yeah, this one I'm saying is like a mafia.
Yeah, no, that's not a mafia, that's stupidity.
So, on the other hand, in my case, you have all over the place.
Yes.
So I can define the exposure surface completely, more or less.
Because what we have there is not, it's only one measure that is being repetitive. The other, is covering a range
Yeah.
of responses to exposure.
Yeah, so now, whatever technique you use, I won't go into that, but whatever technique you use, the intercept here would be the control.
So the control, yeah.
That's what nature is.
Indeed.
The least polluted place is the control. See, this is my problem. That's why I don't do this kind of research, because it's bad research.
It's very difficult.
And so expensive.
Huh?
On top of that.
Tremendously expensive.
No. Well, the good news is they are shutting down all these people.
You don't have anything to do with that.
No. No.
I have a comment about that. I have the opportunity to work in animal science with people with made experimental, and in Mexico it's most common to make cheap experiments. The problem that in front these people is that when they want to publish the work, to make a paper, the journals doesn't accept because it's not the last technology, it's not the expensive machine.
This is what I was telling the doctora, but she thought I was being funny. When I say mafia,
Yes,
this is very true. I'll tell you why.
Exactly.
I'll tell you why. All the people using this circle keep having the paper reviewed by the other guy who's using the circle also. And so the second guy with the circle says, publish this. Next time when the second guy submitted, the first guy says, publish this.
But they refer to the one shoulder.
Yeah.
Yes, in that I told you, no, I don't think that is funny. I think that is quite tragic.
Yeah.
Yes, of course there exists these mafias, academic mafias. You saw it, I mean,
Yeah.
no fields like that.
I mean, listen, I've seen papers that should never be published, but they're published.
And some that are being banned and something, despite that it's a nice and interesting and useful contribution.
Yeah, the point I'm saying though, where it's going back to the climate change, you cannot use this kind of data to make predictions. That's my point. Any comments?
I haven't said anything right, and she's after. Yes, I agree with the lifestyle. It has to be lifestyle, it has to be reduction, and it has to be a lifetime compromise. So you start from home, then if you can, you spread the word. And that's what I have been doing in the workshops I have been conducting. So even if I cut back on my use of packaging, plastics and everything, I still need to communicate that to other people and to tell them that they can save money by using less and to be more informed about what they can use, choices they make. But the other thing is that people will see more in this place, they see it as a benefit to be developed. But being developed also means using more and being not removed from the land, but being more focused on being economically well.
Well, could you tell your associate to open the file called TUSLA? No, Global Climatic. It's the file number 1, before 1. It's a Word file. Oops. It's a Word file.
It's a Word file, there's global climate change and food security?
Okay. Here's the paper I wrote. It took me exactly 2 nights to write this paper. It was on a conference in Tuzla. When was that, Dr. 2 years ago? November? They invited me to come and give this paper. They said, we like a paper that people can understand. We like a paper that people can understand. So, this paper I wrote in 2 nights. Right? Next.
Next, please.
Can we do it from here?
No, this is a Word file.
No.
Down.
No, up.
Up.
Okay, here. This table.
Hacia abajo. ¿Puedes mostrarnos la tabla, por favor?
Keep the door open a little bit, maybe.
Hacia arriba. ¿Dónde está la tabla?
There. So here's a very simple table showing you what the concentrations are or temperature is and what the contribution is. Now, if you go further up,
Arriba, hacia arriba.
no, the other way.
Hacia abajo.
Further down, I should say. Okay, okay. Here is the climate change mechanism. I'll show this on the screen shortly. The first question I ask is global climate changing? Next. Is there a change? He went the other way. Is there an increase in the harmful solar radiation? Then if you go further up, down, okay. Okay, here is another one that gives you the concentration of greenhouse gases in the past, the present, percent change, how long do they exist in the atmosphere, what is their global warming potential. Here is where you should see carbon dioxide is 1, methane is 25, nitrous oxide is 298. You can see chlorofluorocarbon is 4,750. Okay? ¿Está bien? Next question is there global warming. Now, keep going. No, está bien. Is food security sustainable under global climate change? Down. That's it, conclusion. I wrote this for this conference in Tuzla. I sent it to Washington, to USDA. There's a friend of mine who is the Deputy Director for Energy and Climate. I sent it to her just for fun. Next thing I know, I get an email asking, is it possible for me to copy this and give it to everybody in the USDA Energy Division? Very simple. I wrote this in 2 nights. Because these are the fundamental questions that people are not answering. Yeah, you have it on your hard drive.
Okay. No, I was interested in reading what were your conclusions. Okay. So there is a likelihood that the global change is going to cause a negative impact on food production?
It's causing already.
Good. Okay.
It's not a question of is it going to cause. Already in Africa, farm production has gone down.
Yeah.
And India, for example, in New Delhi, 20% of the people have no drinking water.
Yeah. Then water is water scarcity.
How do you like it if I told you the population clock keeps going with 2.5 more children being born every second? That's how fast the population is increasing. Any comments? No, I just wrote this to get some discussion.
Well, I'm in the place of common people in Mexico. There's a big problem about education, and it's because most of the people are educated by television, manipulated television in this country. So I think if these numbers, for example, will be used by the Televisa or TV Azteca, it will be a new vision for the people.
Yeah.
But it's not convenient for the public interest.
Well, this is the problem.
It's alarming.
This is the problem in developing countries. Making them understand this kind of issues is very complicated. I'll tell you why. I'm going to let you guess. I have 5 diplomas, college degrees. I have 5 of them in 3 different fields. You think I'm environmentally educated?
Yes.
No. No, I don't think so. I may be environmentally educated in a particular area, but I am not environmentally educated in all aspects of the environment. Environmental education is very different from education. They are 2 different things. And even the so-called most educated need to be aware of the other aspects of environmental concern. And that's where we have failed. I'll be the first guy to tell you we are not doing a good job. We are allowing the media to manipulate us. And they only do what is good for them.
Yes, that's true. So I'm trying to invent a new strategy to promote things, or
I mean, look at this. For the last 50 years, people have been trying to get India to accept birth control. It has not succeeded. It's failed completely. Because people who are not educated are not willing to listen to you.
One thing I read about birth reduction in India was that they were designing underwear for men, that it was made from a synthetic fiber, that it would discourage the production of seeds. So it would drop down the but I thought, how could they make it widespread?
I don't
It's
know.
effective or not? And it was humorous in a way.
I think somebody is joking. I don't think so.
How can they make underwear too?
Well, I heard that in Indira Gandhi times, there were very aggressive programs going to some small villages and then perform operations to men without their knowledge and then given them a radio or something.
Yeah. They gave them radio.
Because
You could be apparently you could be traveling in a train, and the train stops for an hour in some station. They were giving instant, operations at the railway station, and then giving them a radio. Absolutely correct.
Yeah, an Indian friend of mine told me.
however, this climate change mainly related with increasing population.
Yeah,
From your point of view?
if you look at the population, carbon dioxide emissions are directly proportional to the population of a country. Because more the people, more energy are producing, and so they are producing more carbon dioxide.
However, according to the statistics on energy consumption, the United States is one of the main consumers of energy.
Correct?
Biofuel, not biofuels, fossil fuels, and they don't have they are not the most populated.
No, there's one other reason. The more you want to export, the more you have to consume energy. So in the US, until now, they were primarily exporting country of goods. And to manufacture the goods, they had to consume more energy. Now let me ask you a question. Is there any other country that has the same kind of energy consumption other than US?
Well, actually, in the workbook of the CIA 2008, China was a bit higher. in the energy consumption.
Oh,
of
they
the
will
states.
by the end of,
Well, I am talking about per capita consumption.
yeah, per capita consumption.
Okay.
Guess who is at the same level as the US? Australia. Australia has less population, but they have the same per capita consumption.
It has to do with lifestyle. So the more they take in and also the buying power.
I think that, and that takes me again to the development problem, is because the pattern of consumption and production as well. Of course, population is growing, but an impoverished population in Africa is not going to consume whatever is consumed in San Diego. So there are two aspects which are important to consider regarding climate change, just to be basic, just to start with. Thank you.
Well, we can go back to the
Presentation,
what? Yeah. I left everything. I left everything. I didn't take anything back with me because I don't have any secrets. And I'm not looking for money from IPCC.
Well, mind you, you're not going to get more than 500.
True. Okay. What happened now?
Did you push the button, the central button?
No. Uh-oh.
Remember that this seems to be
Yeah.
not the
No,
other
now
one.
this is working better.
It changed just because.
Delayed reaction.
You see, Joanne, too dynamic for us.
I can always take a siesta.
Siesta, not yet.
It must be on a timer.
I'm curious, what are you keeping that graph? Because
I had to redo it.
exactly.
Okay. Everybody agrees that there is thinning of the ozone over the South Pole. The question he asks is, why is it not happening in the North Pole? Right? It's also happening in the North Pole, except it's difficult to measure. The atmosphere over the North Pole is very turbulent, so it's very difficult to measure. So people like to measure the easy way. Now, the US has been monitoring ozone concentrations over the South Pole since 1970s. And here is a series of pictures starting in 79 to 85, 86 to 92. This pink area is the area that is where the ozone is thinning. If you go through this carefully, when you come here, look at this pink area. It's grown. Some people like to think this is because of solar radiation, flares. When the sun bursts, they think this is. But if you look at this, you can actually document increase by year by year by year up to 1992. Okay. What happens if you have a loss in ozone? You get increase in ultraviolet B. So here is an example. Here is total ozone. Low numbers here increasing as we go. up to 500 units. Here is ultraviolet B. You see there is an inverse relationship between the amount of ozone and the amount of ultraviolet B. Low ozone, high ultraviolet. High ozone, low ultraviolet. Ozone is a global problem in the troposphere. You can find it everywhere. So for example, if you look at July, August, that's when we have the highest temperatures and solar radiation in the northern hemisphere. So if you look at the ozone, the pink color here, it's mostly in the north. If you look at November, December, you see it's mostly in the south. You know why? Anybody? Our summer is their winter. Our winter is their summer. So you can see here more clearly, here is ozone, high ozone, low ultraviolet. Low ultraviolet, high ultraviolet, low ozone. So what is this telling you? Ozone concentrations occur high in the summer, ultraviolet concentrations occur high in the winter. Okay? Plant scientists have been exposing plants the wrong time of the year.
Okay, so they may be masking some effects.
They are doing it in the summer instead of the winter.
Oops.
So let's ask the question. Is global climate change, greenhouse effect, global warming, global change, are they all the same? Okay, what's the difference?
As I have understand, they occur in different seasons, different places of our atmosphere.
So what's the difference between, for example, global climate change and global change?
Global change is not specific enough, and climate is telling you what the change is about.
What's in the globe?
No, the global is telling you that it's happening everywhere.
There are, in the globe, there are non-living entities and there are living entities. Among the living entities is the people. All right? Global change includes people. Global climate change only discusses climate, but not people. To give an example, there has been concern about the ozone problem in the stratosphere. And people concluded it's caused by chlorofluorocarbon. The society turned around and said we will not allow production of chlorofluorocarbon. The lack of production of chlorofluorocarbon had a feedback effect in helping improve the ozone concentration in the upper atmosphere. So in other words, what I'm saying is this. They observed loss of ozone. This loss of ozone influenced the society. Okay? The society then decided we are going to reduce CFCs. This has a feedback on changing this. So it's an interaction between the environment and the human being.
Okay.
But if you say climate change, all you're talking about is this.
Yes, and not all climate. Actually, they focus very much on precipitation and...
Yeah, I'm just saying this is an example.
Yeah.
Essentially, they're not including the response of the human being to the climate change, that is. So this is global change. On the other hand, the others are only discussing the physical, chemical environment, but not the influence of the society. So like for example, when Dr. was saying at lunch, mitigation, adaptation, pollution prevention, that is the effect of the society on the environment. Here, that thing is only telling you about the effect on the environment, but not the society. You follow what I mean?
Very, very much.
So then, if you go back and look at the so-called climate change, it should be looked at as an integrated system of processes and products. It's like a bank book. If you take your checkbook from the bank, you put some money, it changes the balance of your account. If you take the money out, it changes the balance. Putting and taking money is the process. The product is the balance. You understand?
Yeah.
So, let's look at it in that respect. This is what you have. You have a system of processes. Loss of ozone would increase UVB. If you increase the trace gases, you'll change all this. It's not global warming. Look at how many things influence each other. It's a chain reaction. So when you are talking about global warming and all this, you should consider this kind of interaction. And the point is, many of these will have direct effect on agriculture. You don't need any warming. And this is where these people are making a mistake, like the CO2, people studying CO2 effects on plants. If they were only doing right things, by now they could have had a better idea what increasing CO2 will do. Instead they are gassing plants one concentration at a time. I mean, by the time these guys find out the whole story, the problem will go away.
Yes, we must have wiped out the
Any comments?
So do you think that the approach of looking at the problem, at the real nature of the problem is the problem, so
Yeah.
to speak?
Yeah.
I do believe that as well.
To conclude, there are not analysis in the promotion of global warming. There's just marketing. There are not analysis.
What is the comment?
Well, I think that we need to look at this from more integrated perspective. I mean that there are not, no, there are more disintegrated, non-affiliated works on that. I do agree with that, but that doesn't mean that there are not other people looking at this, Professor, as we're trying to do.
See, the point is, environmental issues are not controlled by one discipline. It's multiple disciplines. So that if you want to understand this kind of thing, it cannot be done by biologists alone. It must be done in collaboration with other disciplines. And that's a big mistake biologists are making. Because a lot of times they are doing things that are incorrect from a different perspective. I know one guy, Dr. knows him too, but I'm not going to explain his name, did studies on exposing plants simultaneously to ozone and UVB. That's impossible.
I know.
High ozone, low UVB, high UVB, low ozone. But this guy mixed it all up.
I know who he is. I know he is. Yes, I know who he is. It's a common friend, I think. It's a common English friend, British friend.
Well, there's also one here in the U.S.
I see.
Oh,
That's
yes,
exactly.
that's true.
There's another one here.
You are talking about that.
You see, this is the problem.
And the way we look at the problem defines how we try to solve it.
Well, look at this. I've got a project right now, which I won't bore you with. It's an atmospheric project. And they came to me, the people that are interested in this problem, want to know whether I could do the work. I said, let me think about it and I'll call you back. I call back and says, I want to put together a team. And I want to have a meeting with this team, and I'm going to discuss with them for 2 days. And then I'll get back to you. So the people said, fine, we'll pay for your airfare, whatever you want, go have your meeting. First I collected 2 fellows from EPA. These 2 guys are top-notch atmospheric scientists. Then I collected a fellow from another place who is world-renowned for his work on lead isotope. Then I collected another fellow who is mercury isotope guy. Then I collected 2 other guys that are simple analytical chemists. Then I collected a modeler. 9 people. And I locked them up in a room for 2 days. I said, this is my plan. You guys want to get in and tell me what you'd like to do. All of you who want to do this, raise your hand. All 9. No money was discussed. There was no discussion of money. I said I want 1 paragraph, maybe 2 paragraphs from each of you how we are going to do this. So I got about 9 times 2, 18 pages of material. I sat and read for a couple of days, then made some secret phone calls to a couple of people I know to ask them what they thought about this idea. They all agreed. Then I went back and asked 9 people, how much money you think you need to do this work? So they all gave me a budget. I'm always careful. I immediately increased the budget by 20% and gave it to the people. It's funded, I'm doing the work. And as we were doing the work, one of them came to me and says, looks to me like we need to do some more work because I didn't realize the results will be like this. And he says, I need another $25,000. You see, initially, I overestimated the budget by 20% of the total. So when this guy came and said he wants 25% more, I took 25% of the 20% of the total I already had, said, go, here. That's how you get the best results. Without understanding what you're doing, you don't do this. So in this particular study, the first 6 months, we did pilot studies to make sure we are not wrong. I told the granting people, if I'm wrong, I don't want your money. I'll come and tell you in 6 months. So I went and told them in 6 months, here are the preliminary results, and we think we are on the right track. And so I went at a time when these people were looking at all the research budgets. Mine was the only one that was not cut. All the others disappeared. They cut them off. So anytime you deal with this kind of situation, no single person can do this. You have to have cooperation. This is what it is. Everybody understand this? Gustav, Hurricane Gustav. Here is Yucatan. Extreme event. This is Nebraska, South Dakota, North Dakota, Minnesota. We had the worst drought in 50 years, about 6 years ago. Extreme event. This I showed you, Sahara dust going to Florida. Here is another example. Vietnam, Cambodia, Laos. You can't see this, but there are hundreds of forest fires. See this? All the red dots. China, I showed you. And this is India. You went to India. Guess where the Calcutta is? Oh, sorry.
Where there is that smoke of over there.
Here is Himalayas.
Okay.
Right there. This 1/3 of the population of India is in this area, northeast. And this whole area in the summer is nothing but smog.
Is that smoke?
That's Himalayas.
No, the face.
Right here. You can see this is how the picture looks. It's not clear, is it?
Not at all.
In summary, when I say climate change, this is what you have. In the lower atmosphere, there is increase in greenhouse gases. Some of these greenhouse gases go into the stratosphere and destroy the ozone. Destruction of ozone increases ultraviolet day. Meanwhile, the stress gases increase the temperature of the surface. So you see, there's an interaction between all these at the same time. This is not global warming. Global warming is a component of the system. Any comments, questions? None?
Very much same moment household words.
So anyway, I would, shall we continue? Or shall we leave it for tomorrow?
Well, it's 5:39. Did you prepare with
We can save it for tomorrow if you like.
Yes.
And I don't want, after a time, the brain can only take so much. Overload.
The famous 20 minutes of attention. Span. Okay.
Any comments, questions?
What you were saying, the global change, to me it is more general, the phrasing, not the context. So if it were global environmental change, to me it would make it more specific. Just the wording, not the issue.
Well, the wording has to reflect this feedback. How do you do that?
So we could say, I'm proposing a global environmental change.
Yeah, but the environment is not people.
Yes, if people are part of the environment, as I understand. So it's about everything, environment.
Well, I understand people are part of the environment. The question I have is, how do you include the importance of people into the system in a title?
So we can make it even longer. To me, it has to be specific, whether short or long, and global change is not specific enough.
In what sense?
Because it's telling us change, but we don't know what type of change. And if we say that it's general...
Well, here's the thing. If you say global climate change, that's what you're saying?
No.
Global environmental change.
Because climate is just weather, but environmental, to me, is encompassing.
Okay, but you don't know what change is occurring, do you? You're back where I am?
Yes. So I know that if we use global change, it does refer to alteration, but to me, environmental, even if we think of other word, even if we say anthropogenic global change, or anthropogenic environmental change.
We can't say that because some of the change is natural.
Yeah. So to me, the phrasing, we could think more about how to modify it.
I think you should think about it tonight and come up with a term you can mention tomorrow, and we can discuss.
Okay, so that is going to be our task for tonight. Okay, let's call it.
Anything else?
Well, maybe we can not just thinking about the term tonight. We can think about another kind of solutions about how to integrate this in.
Well, like she said, part of the remedy for global change is population control. That's one side of the coin. The other side of the coin is more efficient use of energy, decreased use of consumption. Okay. Now, more efficient use of energy is a approach for developed countries. For developing countries, it's not, because their priorities are survival. I mean, Dr. might disagree with me, but I've been coming to here since what, 76? I never tell people what to do when I come here. I only tell them what I think we do, but I never tell people what to do. Because you have to be sensitive to the societal issues. You cannot come from Estados Unidos and tell people what to do.
Oh, they do it all the time.
I know that. I know that. I know that.
It's
I know that.
Of increasingly.
I know that. In fact, I once told the doctor, I said, don't call me anymore. You should listen to somebody else.
Why did you say that? You're so rude.
No, I mean, I told her one time, the students should receive a different perspective.
I see.
And so I said, invite somebody else. And I think she invited a person who came here once and never came back.
Yes, because he came to give a recipe of how to do the exam.
I don't know. I mean, this is the thing.
It's your charming personality, Professor.
This is the thing. You're supposed to tell people what you know, but not tell them what to do. It's up to them. If, for example, birth control is, compatible to the Mexican culture, sure. If it's not compatible, you do something else. And I very clearly remember there were two Australians. These two guys were church people. And they went on a mission from Australia to India, to the northeast part of the country in the Himalayas. And they were going there to preach birth control. They never came back. They found out after 2 months they were killed by the local people. So you don't do that.
And on top of that, in appraise of that, I was saying, no, that they were killed, no, I'm not meaning that, but I think that measures are going to be successful as they are understood by the community, and it's when community-based projects make the whole sense, not only regarding climate change or environmental problems, but problems, all sorts of problems. Okay, guys, thank you very much. Honestly, few, but the best. Okay, then see you tomorrow. 10:30. Okay. And it's going to be. I think that we are going to condense as we don't have a lot of current. Tomorrow, we are finishing the course tomorrow. Okay.
Reduction is the amount of photosynthesis and carbon assimilation by all vegetation. That's what net primary production is. Now, if you look here, the highest net primary production, you see this is 0, that's colorless, and if you go this way, the darker green it gets, the more production. So if you look at this, the highest primary production occurs in North and South America, Central Africa, USA, and some Canada. Now the bottom panel on this is calculating how much net primary production is required by people. Percent of local production and how it's in imbalance with how much is needed. So for example, if you go here, the browner it is, the more you must import. The redder it is, the less they are importing. So for example, if you look here, the brown areas are in Africa, Middle East, India, Eastern China. These are the areas where there will be food that has to be imported. And as you probably know, India is already net importer of food. In spite of the so-called Green Revolution, India is already an importer of food because the Green Revolution has failed. And I'll discuss that in a few minutes, why it failed, but nevertheless, that's what it is. So when you talk about climate change, you have to superimpose the change in the variables that allow crop production to be superimposed on this. Okay? Everybody understand what I'm saying? Okay, we already discussed this. Global climate change is not simply global warming. Global climate change is a system of atmospheric processes in the products. Yesterday I showed you like a balance of bank book. You have on the left side the processes, on the right side you have products. And that's what you have to look at. Now let's look at this. Here's an example of transport of pollution across the world. The red areas, the red areas tell you the concentration of fine particles. And remember now, in the southern hemisphere, the wind moves from east to west. So if you look at China, eastern China, it's moving all the way across India, across the Indian Ocean to Western Africa. This is a global circulation pattern. And this is what regulates the air temperature. Because one of the things fine particles do, when the sun comes to the ground, it's coming directly. It's called direct radiation. And if you have fine particles in the atmosphere, it deflects the light. So you have diffuse radiation. And diffuse radiation produces much less energy than direct radiation. For example, if you go outside on a clear day when the sun is coming directly, you'll feel the heat a lot more than a day when there is a lot of salt. Sea salt is a fine particle. It's naturally produced. When you have a lot of salt drifting, you won't feel the heat because it's diffuse radiation. This you should know. These are all forest fires. If the light was dimmer, you could see it. It's all in red. This is Sinaloa. And from Sinaloa, the forest fires are going across the Baja Gulf, and it's going to Baja California, and then on to California. Mexico City, very typical in the summer. It's because it's surrounded by mountains. The air that's produced, the hot air that's produced by the city is held down. So till about high afternoon, this continues, and then in the afternoon it's broken up and you can see the town. It's very typical of Mexico City. Smog. Now, having talked about air quality, the second limiting factor will be water availability. Oops. Water availability. What's going on here? I'm not doing anything. It's changing. It's changing by itself.
See, you don't have any animation there.
Huh?
You don't have any custom animation.
I don't have it. See, look at it. This is what I want to show.
I see. That one?
Yeah.
Okay.
Let's look at water. Water would be the second most important factor. If you look at what this slide is showing, this slide is showing the amount of water that's used by various countries. If it's brown, the country is using more than 40% of the available water. If it's light yellow, it's using between 20 and 40% of the available water. If it's light blue, it's using between 10 and 20%. If it's dark blue, it's using less than 10%. That means they are saving a lot of water here and they're losing water here of what is available. So if you look at 1995, all these countries in blue are using less than 10%. South America, you know the reason why South America is using less than 10%?
Because it has less people and it has more resources.
There are lots of water. All the rivers in South America, there are lots of water. Amazon, Orinoco, lots of rivers. So there are lots of water. So if you take South America, Canada, you're right. In Canada, there's very little population. Australia, same thing. So if you look at this, these dark blue areas, right now in 1995, we're using less than 10% of the water. Then if you look at the light blue, 10 to 20%, that's how the unit goes. Some of the African countries and Europe, they're using less. But most importantly, if you look at the brown color, which is more than 40%, you see the entire Middle East is already using up the water resource they have. If you compare that to 2025, see how the colors have changed. This went from 10 to 20% USA to 14 to 40%. If you look at India, for example, right now it's using 20 to 40%, but in 2025 they'll use more than 40%. So you see, water is going to be a short supply.
What is so different with the African countries?
In what sense, Dr.
So much using a little and so much using a lot. Here, in Africa.
Let's see.
If you look at Africa.
Yeah, let's
in
look at
other parts they are using a lot.
First of all, there's not much cropping systems here. So the water use is much less. Cropping systems globally are the biggest users of water. Okay. Like for example, if you go to the US, which you have, corn is an irrigated crop. And so in the areas of the Midwest where corn is predominantly grown, you'll see intensive irrigation. If you go to southern United States, corn is not the major crop. Because of the fact it's hotter and drier, sorghum is the major crop. So it's using much less water. So if you go to Africa, this part of the Africa is where the agriculture is. If you go further up, no, there's no agriculture per se, because this is the Sahara. And you're dealing with sub-Saharan agriculture. Any questions, comments?
Okay. Would you believe that because the people that are already living, that have lived in the Sahara, so and there are nomad groups, they are sort of used to water scarcity anyway, and they are not going to, it's not going to hit them that bad because they are already used to that? Well, what would you say about that? I mean, it is quite probable that the people...
What is the major emphasis of this institution?
What is the main?
Major emphasis.
Social sciences.
In social science, what is the major emphasis?
What? There are many migration, for example.
That's all I mean. Do you know there's a tremendous amount of migration from sub-Saharan Africa
Yeah, sure.
to Europe? And if you look at, these are illegal migration,
Illegal.
illegal. And so what they do is they come to Gibraltar, for example, and from Gibraltar, they tend to take the Gibraltar Straits to España.
Yes,
This is the Canary Islands, Torremolinos and Buenaventura and all this. 1 out of 2 people never make it. Because the Straits of Gibraltar is one of the most dangerous waters to cross. So 1 out of 2 people are killed right in the Straits of Gibraltar. And the remaining people, when they get to Spain, to Canary Islands, and then on to the mainland of Spain, their primary objective is not to go to Spain. Their primary objective is to go to France. Because they are French-speaking people.
Or even close to go to the UK because they used to have a certain labor arrangement that allowed that it was.
Yeah, but it's not from one country. That's the point. If you look, I work in Spain, so I know this.
Yeah.
And if you look, it's the same thing that's happening, for example, Central America. If you look at Central America now, they are trying to go through Mexico into the United States. Same thing is happening. So a lot of times when you look at, I'm going to hold this. This is big for let's see what it stays. A lot of times, Dr. When you say why is it changing, it's because of 2 things. One is many of these countries are not known for their cropping systems. They are subsistence cropping. And this is where, for example, UN is spending a lot of time. And the other part is the so-called illegal migration. These are the 2 main reasons why you have change.
Well, not only illegal migration, there are going to be some transboundary water problems as well because there are already, yes.
There's a book that I suggested to your colleague the other day, but I don't think he was interested. There's a book that's published about 3 years ago on transboundary crises.
Who is the author?
GAO, G-A-O. If somebody has a, I wish I had my computer here. It's in it.
Transboundary, what's your name?
I'm trying to think of its name.
Okay, go.
Let's do it when we take a break.
Okay.
We'll go to Google and search.
Yeah, so it's transboundary.
No, go to Google and put developments in environmental science, comma, Elsevier. See what you come up with. I have a bookmark so I don't pay attention. Did it come?
Yeah.
Then put, let's see, it should give all the search. Then put GAO. Let's see what it is.
In here?
And search toolbar. Just put GAO and see what it is.
In here?
Yeah. Yeah, let's see what it is.
Okay, you continue.
Remember,
Okay.
yeah, let's see where it goes.
Let's take a look at the other side. Okay, let's go.
GAO.
corresponding because this sort of migration to U.S. game, transboundary species, environmental.
No. I'll have to give it to you.
Okay.
I have bookmarked on my computer. Unfortunately, I didn't bring my computer, otherwise I'd give it to you.
Okay.
I tell you what.
Okay.
But developments in environmental science, Elsevier, comma, L-E-G-G-E. L-E-G-G-E. See what it comes.
Well, I came out with two things. The two-file system, modulation of viral and cellular processes, and brochure, the GTLA symposium. Okay, well. Never mind.
I'll give you the. Anyway, now let's compare the current status of agriculture. If you look at the demography, populations by statistics, if you look at the total population in 2003, first of all, is this the right one? It seems to be skipping there. Strange. If you take Africa, there are 59 countries in Africa. Current population of Africa is 851 million. Rural, that means away from the urban areas, the population is 522 million. By 2030, in Africa, the population will increase by 65%. At the same time, the population in rural areas will increase only by 20%. In other words, 2/3 of the increase in population will be urban, and only 1/3 will be rural. Similarly, if you take Asia, there are 51 countries. Current population is 3.8 billion because of China and India. Current rural population is 2.3. Okay, about slightly over 60%. If you look at 2030, the population will increase by 39%. But look at the rural population, -4. There will be a tremendous imbalance between the rate of total population growth and the rate of population remaining in the rural sector. This is going to be a critical factor in food supply. If you look at Europe, there are 51 countries, current population 726 million, of which only 197 million is in rural areas. By 2030, the population of Europe will decline, -6. At the same time, look at this, the population of rural communities will decline by -32. See, this is going to be a real problem. Canada, Mexico, USA, the NAFTA countries, current population 429, rural population 90 million, will increase by 26% by year 2030, but the rural population will increase only, -3%. There are two issues. When you look at population growth, in the developing countries it's because of increased birth. In developed countries it's because of increased migration. So those are two different underlying mechanisms for this. But the net effect is, in the next 40 years, there will be a decline in rural populations. I'll show you in another picture. Mexico has the same thing. The rural populations in Mexico will decline as we go along because there will be more and more growth of urban centers. And this is going to be a critical issue in world food supply.
Before going further, I'd like to ask you if you know about, during the last years of his life, Dr. Borlo was very close to Africa, and he tried to develop a kind of green revolution over there. How successful Was he, how far?
He could not do anything.
No.
The world, how do you call it? World Bank has taken over. And the World Bank is investing large amounts of money into grain production in Africa and into other type of staple food supply the African people need. And in fact, where was this? Bill Gates.
Yeah.
Bill Gates has recently given $500 million just to control one disease in Africa. Remember now, food production is not simple food production. It's the result of production minus loss. The residue is the food production. Food production is not food production. Like for example, you could have, let's say for example, you could have 100 kilograms per hectare of food production. So what you have done is production minus loss is the net production. In other words, when you have a crop in a field, you are not getting 100% return. You are losing crop, certain percentage of the crop because of lack of water or lack of something, incidence of disease, insects. So you essentially have production minus loss equals net primary production. So in as much as in one hand, you are trying to increase production by new varieties. At the same time, you have to increase production by limiting factors that control the production. So for example, when the World Bank is doing the production part, Bill Gates is now working towards the disease control part. The two have to be combined, and that will result in improvement in the net production.
Which countries are mostly involved?
That I don't know, Dr. The Cornell University is the one that's doing this. Cornell University received $500 million from Bill Gates. And if you want, there's a fellow in my institute who is involved in this. I can find out what countries are involved. They are particularly interested now in the wheat rust, I gather. There's a new variety, what do you call it? That is dangerous, it's killing the crops left and right in Africa. It's a disease on wheat. And they don't have any control at the moment.
How controllable is that? Yes. How controllable is that?
No, if it is new, it takes years to get resistant varieties.
How many years?
Depends on the crop.
All depends. But at least I would say in wheat, 4 to 5 years, I believe.
One question, Professor. This Canada, Mexico, and USA, I can believe that there was going to be a sort of decrease in rural populations, and of course, an increase in the.
Remember now, this is not just Mexico.
Exactly, but I think that I can believe that the Canada and the USA are going to follow more or less a similar pattern, but Mexico is a bit different. You wouldn't expect to have a higher?
Let's look at the next slide.
Okay.
Let me first of all say.
When I look at the total, because the U.S. has 3 times as much as Mexico in population, so it would influence the total.
Let's look at the next slide. Before I go any further, let me say all these calculations I made was from the UN statistics. I didn't collect the statistics. United Nations has statistical database. I simply took the database and recalculated for the purpose of our present discussion. Okay? Now let's look at a different aspect of this. If you look at the total population in the year 2003, in India the population is 1.07 billion. In China it's 1.32 billion. In USA, it's 294 million, and in Mexico, only 103 million. The global population is 6.3 billion. Now remember one thing, this is something people don't understand. Population increase is exponential. It's not multiple, it's exponential. You know what exponential means? So it's not a linear multiple. I remember that. The rural population in the year 2003 in India is 764 million. In China, 851 million. But you see in the US, only 58 million out of 300 million. And in Mexico, only 1/5, almost 1/4, excuse me, 103 million versus 25 million. On a global scale, it's 3.26, in other words, almost 50%. If you look at the all rural population, necessarily does not mean agriculture. There are people who live in the rural community that contribute to other things, not necessarily to agriculture. So the agriculture population should always be less than the rural population. So for example, if you take the ag population, in India it's 557 million, in China it's 8,802 million. You see, in China, the rural and the agricultural populations are almost similar, but not in India. And in the US, it's even worse. Only 6 million out of 58 million. And in Mexico, almost again the same. 25 million rural, 22 million agriculture. If you look at the ratio of rural population to total population, 71% of the population in India is rural. 65% is in China, rural. If you look at USA, only 20%. Mexico is somewhat similar, 24%. There's a reason for this. If you go, for example, to Yucatan, you will see farmers that are subsistence farmers. They are not meant, see, this is the point. Last year when I was in Tuzla, one of the people in the audience, there were 100 students in the class. This one fellow said, I was discussing about shortage of food supply, and he said, we should go back to traditional agriculture, like the chinampas and things like this. That's okay for him. But remember, how can you feed, let's say in India, 1.08 billion people with traditional farming? You can't. You have to have mass production, because you don't have land to produce enough food for 1.08 billion people in India. So they have to produce by mass. So I think we have to be careful how we value life. If you are a subsistence farmer, it's one thing. I mean, I was quite impressed. In Yucatan, I went there for a week looking for a problem that I thought came from there, and it did ultimately. I was doing survey. I went there to look at the cropping systems to see whether in fact there's evidence for what I thought it was. And it was very interesting. These people grow corn, maize, and they harvest the maize. But they leave all the stems in the ground. And then they brought climbing frijoles and use the stem as a stick. That's the traditional agriculture. But if you look at the agriculture in Yucatan, they're all very small farms like this side of the room. And there are no records where these people are. So we look for the so-called, secret thing that's somewhere lying around, because we drove and drove and drove trying to find what we're looking for, because there's no other way. On the other hand, if you go to any of these other countries, there are big farms. They are written down in a book in the local agriculture department, and you can go read the book and go. So there's lots of difference. So when you look at, for example, US and Mexico, they're somewhat similar for two different reasons. In Mexico, it's similar because of subsistence farming. In US, it's very similar because of corporate farming. If you look at the ratio of rural agricultural population to rural, you see in India it's almost identical. In other words, virtually all the people living in India in rural areas are agricultural people. There's a reason for this. If you take an average hectare of rice in India, it's cultivated by 6 people by manual labor because they do not have mechanical production per se. So it's still practiced as a manual labor. If you take China, you see 94% of the 65% is agriculture because humongous population, still in many parts of China, agriculture is practiced as manual labor. On the other hand, if you take US, you see it's only 10% or half of the rural population is agriculture. Mexico, again, it's very similar to India and China because much of the subsistence farming is done by manual labor, not by mechanical. The only place in Mexico, I should say this, of the places I've been to, of the travels I've done in Mexico, the only places where I've seen mechanical intensive farming is north of Mexico City, between Mexico City and Saltillo.
North of Mexico City.
Well, between that area, further north.
The coast of
In Sinaloa,
exactly, the coast
they
of
are
Sinaloa.
very advanced.
That's what I'm saying. That's what I'm saying. And there's another interesting problem in Mexico, and probably you don't know. I sit on this committee in Washington on agriculture. And in the US, government is clamping down on agriculture. They're clamping down on agriculture for agricultural pollution, both in groundwater and in the atmosphere. And people like Schwarzenegger in California think they are the pioneers by making it even more difficult. So the agricultural groups in California, the big ones, they are now decided they are not going to farm in California some of the major crops. They are going to only farm specialty crops like strawberry, raspberry. They are not going to farm the major crops. And so what they're doing is they have formed consortium with Mexican people. And they're buying up land in Mexico. These are California people buying up land in Mexico. It's not in their name. It's in the name of the local Mexico person because the government of Mexico does not allow foreigners to buy land for farming.
Wow, that is really interesting. Have you seen Mexicali by any chance?
No.
Mexicali is around 2 hours away.
Yeah, I know where it is.
Okay, and they have a huge, maybe the biggest agricultural region in Baja California. That one and San Quintin, which is to the south. And what happens there is that we get the only source of water.
Yeah, I know.
Colorado River. And it is known because they have, it is really cheap, so that it's heavily subsidized, the water in Mexico for agricultural purposes. So they use that water if they belong to them.
Yeah.
There is not metrified, they don't know. There is estimated that 1 million cubic meters are struck per year. Okay, it is known as well that these people rent the lands.
Yeah.
It has happened all the time to California.
Yeah, this is it.
And they come here to grow water demanding crops.
Look at this. This committee I'm on, I am the only true atmospheric scientist in the whole committee. It's appointed by the Secretary of Agriculture, and he appoints political, I think. I don't know how I got to this, and I didn't want to be in this committee, but the people who know me keep pushing me, come on, you go there and fight.
Exactly.
These are, of the 23 people, 7 people are from California. And 3 people are from Texas, 5 people are from Iowa, because it's a big farming community.
There is a, where they're growing the biofuels in
I'll come to that in a minute.
and what happens in that?
So these people in California, what happens is when we go to this meeting, it's just like this. And the Secretary of Agriculture comes and gives some bullshit and leaves. Okay. He's there for a half hour, I gotta go, and he's gone. The undersecretary is the one that runs the meeting, he's the chairman. And these issues come up every time. Biofuels, agricultural air pollution, air quality regulations, water pollution, transboundary pollution. This is what they talk, mostly. And I'm sitting there as listening, whatever it is. And these people, you know what lobbying is in English?
Pushing for legislature.
By what mechanism?
Pushing for either propositions or legislature.
By doing what?
So they influence either through ONG funding. So they they pay whoever is the decision maker to encourage.
They take them to dinners. They take them to vacation in Bienvenida.
Buying favors to influence law.
So a lot of these people are lobbyists. If you look where they come from the American Cotton Growers Association. Well, they are powerful people. I feel like nothing sitting there. I mean, these guys are big time, and they can call Washington directly. I mean, the first time I went to this meeting, somebody told me you must put tie and coat and go there because the secretary is sitting there. So I dressed up and went. And there's this one fellow sitting over there. He was in jeans and regular shirt, at least I think it's cleaned. And he's got boots. Short guy about this tall, sitting in the corner. I kind of looked at him and said, everybody else was in coat and tie and this guy is sitting over there. So then they had coffee break. And there was a lot of discussion about something. So I got up and decided to go to my room to call my office. As I was standing at the corner, this guy was standing there with his cell phone. And I could hear him. He's calling directly White House Office of Science and Technology. This guy I thought was nobody. Turns out he's one of the most powerful guys in the country in the Democratic Party. So this committee is made up of these people. Cotton growers, fruit growers, all kinds of people. And they're standing up and telling that they have decided to go to Mexico because the government is becoming too difficult.
And they are coming from the Imperial Valley to the Mexicali Valley.
Yeah.
And in the Mexicali Valley, we don't have enough water. That is a problem. And what do you mean, I would like to ask, when you mention about technification in the agricultural communities? Are you talking about irrigation systems or
No, what they're doing,
stations, or what are you talking about?
they're doing a whole bunch of things.
Okay.
One, they are using more and more biotechnology. That's one. And part of the biotechnology is to have less water. That's one philosophy. The second philosophy is precision agriculture. They map the entire farm by GPS, geographic position system, and they turn this into a grid, the map. Then they go and actually analyze the soil for major fertilizers, nitrogen, phosphorus, potassium, whatever it is. And obviously, any soil scientist will tell you, if you go from here to there, it won't be the same because of the variability. So what these guys do, the company actually has this. They go drill a soil and they can measure what's in there. So they map this on this grid, the nutrition map. And then they have a computer program in the tractor. And based upon whether a particular area here has enough nitrogen, the computer will tell the tractor not to put any here. It'll go and tell the tractor to put more over there because there's nothing there. Their argument is they're conserving. In other words, until now, they just fertilize, whether you need it or not. And the excess fertilizer, for example, goes into the groundwater and pollutes the groundwater. So their thing is, they're not really environmentalists. These people, chemical companies, are never environmentalists. They're convincing the farmer is, we are saving you money because you don't need as much fertilizer now as you did before. At the same time, the company already made the money selling the equipment. So, everybody's got an agenda. Those are the kind of things they're doing. They are doing less input of chemicals. They are using biotechnology. They claim they're using less water, which I don't know about. So those are the kind of things. Most importantly, however, they're escaping the U.S. because of the laws. That's the key. Independent of how Mexico is different or not, they're not interested. They're interested, let's go right here.
Yeah, sure. And there is something how common is to find desalinization to irrigate crops. Is that what is happening in the San Quintin Valley?
Yeah.
Which is the second most important agricultural valley.
So anyways, those are the things that regulate the agriculture to rural population ratios you see here. If you look at the change in rural population, but in 2030 and 23, you see there's a 10% change in India, minus 31 in China. Because China is becoming more and more and more industrialized. Actually, they are importing more. China is #1 importer of soybean in the world from Brazil.
From Brazil?
For biofuels and oil.
Yeah, that's why they are clearing some parts of the Amazon, because the demand for soybeans is increasing.
Yeah.
Yes.
That's one of the reasons I don't use any soy products.
You see, this is the problem with maize and soybean and some other crops. They are shifting from food production to oil production, biofuels.
We have that problem, you know, when the United States dedicated the surplus production that was sent into Mexico for creation of biofuels, it caused here's a problem that it was denominated the tortilla war, because there was not enough corn to make tortillas. So the market speculated a lot. We have already suffered that 2007, I think.
This is the thing. In Minnesota, corn is #1 crop. Okay? Much of the corn is not for human consumption. Much of the corn is produced for animals. The only corn that's produced for human consumption is what is called sweet corn. And they grow it in much smaller proportion of land compared to the total production of corn. Now, when biofuels, ethanol became important, Minnesota has the highest number of ethanol plants in the country. Now, ethanol did not come because of this. Minnesota was the first user of ethanol in the U.S. for a different reason. It had nothing to do with this. In the winter time, our temperatures range from -10 to maybe -30 Fahrenheit. Very cold. So there are major highways where there are 4 stoplights. The cars come and they sit there because the lights have to change. And when they are sitting there, they are running very hard because of the cold temperature. And therefore, they don't get complete combustion of the gasoline. So they produce carbon monoxide. So these carbon monoxide concentrations at these 4-way stoplights was above the government regulation. Now remember, the more completely combust fuel, the less carbon monoxide, more carbon dioxide. And one of the ways to increase combustion is to add oxygen. Ethanol produces oxygen molecules during combustion so that it improves the combustion. Net effect, they reduce the carbon monoxide. The problem went away. And so the government of Minnesota decided that all cars must use ethanol in 3 of the coldest months of the year, December, January, February. Because there's a problem with ethanol. If you add ethanol to the fuel, the amount of ethanol consumed per kilometer would be 24% higher than gasoline. People don't realize this. They had to buy more gasoline, ethanol gasoline, than gasoline. because it'll reduce the efficiency by 24%. So when gasoline, when the US government decided everybody is going to use ethanol all the time, the mice people in Minnesota, for example, the government said, if you produce mice for ethanol, we'll give you additional money. So immediately, all these mice fellows that would normally produce food moved on to ethanol production. They not only moved on to ethanol production, all the people growing trigo also moved to corn because they figured they could make more money.
What was the shift? How many producers, what percentage
Of what?
of the wheat people going to?
Oh, it depends. It depends. Not a
In Minnesota?
Yeah, what percent is not the issue? The percent is who?
Oh, well, what amount?
Here.
Was not stop produce.
Here's Minnesota.
Okay.
There is what is called the Red River. It actually flows from south to north. If you go to this section of Minnesota, it's all forests on its peak. So you cannot grow any crops. It's acid soil forest. The further you go west, you are into Great Plains. That's where most of the agriculture is. So, if you look at how much trigo was being grown in Minnesota, in the past, it was grown almost that. And this is soybean and corn. And all these guys here shifted to corn because they were getting money.
Yeah, sure. Well, I think that, I don't know, check, please tell me if it's right, but I heard that it is heavily subsidized about the production of biofuels. So it's more or less $1 per gallon that is given by the government to these people. Is that right?
The amount I don't know. All I know is they are subsidized.
Heavily subsidized.
Well, not anymore. They are
Not
now.
anymore?
I'll explain to you.
Okay.
Human beings have this capacity of shooting themselves in the foot. First you shoot yourself and then ask the question, oh, what happened here? Lost 2 toes. So these guys shifted. But then suddenly they found out after 2 years, trigo was in short supply, and you can actually make more money than the mice. So they all went back to trigo.
People.
So you got to remember, human beings are fickle.
Okay.
So don't use linear logic. That's not the way it works.
It doesn't work like that.
So now these people are gone the other way. Meanwhile, the government says the ecologists are making noise that arable land is being wasted for biofuels. So suddenly, everybody's got an alternate idea. How many of you know BP?
BP, British Petroleum.
Yeah. They gave $500 million in research money to University of California, Berkeley. Find a biofuel source that does not use arable land.
Okay.
It's like a Zatropa issue. So now they found this grass species that are not cultivated. These are native, not native, these are wild grasses. Like for example, there is a plant called miscanthus. This miscanthus is a grass that actually produces 10 times more carbon per hectare than corn. So they now want to grow this. And biotechnology. UC Berkeley is developing biotechnology to produce super miscanthus.
How do you spell the word?
Miscanthus? I think this is what it is. I'm going to botanist, but I'll try. I think it's called
TUS at the end?
I think that's how it's spelled. If you put in Google, you'll get it. They'll change the spelling if it's wrong. Okay? Now, are you impressed that BP has put $500 million in this project?
No.
Why not? $500 million?
It's a lot of money, but they made more than that. Much more.
Would you like to know the truth? Okay. $500 million is 1 day of profit for BP. Now, in the Gulf, you had this oil business. And BP is saying, so far, they have given the people $2 billion, 4 days of their profit. That's what it is. People don't know this. $2 billion. More than the government.
Run away.
4 days of profit. 500 million times 4 is 2 billion. Any other comments or questions on that?
What are they getting on with these mescantos? Have they already developed something? What is going on with that research?
Well, let's put it this way, this is really interesting. My ex-professor, he was a great scholar. He came from the old school in Sweden. He spoke 6 languages. He came from old school. And he said to me once, what do you think you have discovered somebody else already has? Only thing is, they didn't publicize, you are doing it, and you think you're better. He says 99.9% of the discoveries have already been made in a different way. I mean, these guys are sending rockets to moon, Mars, whatever. If you read Jules Verne's books, he already sent them. Now, what was the question I missed out here?
This mescantos business.
Oh, okay.
What is going on with it?
Mescanthus is a semi-tropical grass. The people who originally studied this were Danes, Denmark.
Okay.
A fellow by the name of Jorgensen published several papers in peer-reviewed literature on Mescanthus.
How many years ago?
70s. 60s, 70s. It's published.
UC Berkeley is rediscovering this?
No, they didn't risk it. Now, let me tell the story.
Okay.
So, these people ignored those papers. Nobody bothered to follow them. And so Mescanthus went away until now. There is a carbon physiologist by the name of Steve Long. He came from England to Illinois. He's a carbon freak. So he, when biofuels became a problem, he brought this from someplace and planted in Illinois. Okay? When BP said we are looking for, what they are looking for is a source of cellulose without disrupting the animal life. And there are 3 sources of cellulose that are not related to cultivation. One is grasses, wild grasses. 2 is algae. 3 is wood. So these people are trying to digest every one of these by biotechnology to get the maximum cellulose decomposition. Because you need the decomposition to ferment. And without fermentation, you don't have ethanol. So this guy Long is trying to increase the carbon by selection, whatever they do. Meanwhile, Berkeley people are developing all these tools for fermentation of complex cellulose.
Tell me, what do you think about all these biofuel businesses and using arable land and the rest of that? For example, not to exploit more cellulose agricultural waste or agricultural waste that is high in cellulose content. That would be a source of biofuels and not to...
No, that's the point I'm making. They know the cellulose content of various types of plant material.
Yes, it matters, of course.
The 3 sources I told you, every one of them has much, much higher cellulose than any crop. Mescanthus has got 10 times more cellulose than corn.
Okay, but of course, no. What I'm saying is, why not to use the agricultural waste to create biofuels?
That I don't know. I don't know whether you can ferment and get enough ethanol, I'm not sure.
Okay.
I'm not sure.
Production,
But because ethanol production is controlled by the amount of soluble sugar. The less the soluble sugar, the less the ethanol. Ethanol production is very easy. All you have to do, if you take a molecule of sugar, if you take a molecule of sugar, C6H12O6, normally if you have oxygen in the system, it becomes respiration. It produces energy in your body. But if I cut off this oxygen, essentially I'm diverting this to ethanol. So for example, if you go to a cerveza factory, that's all they're doing. They're taking this, adding yeast, which has the enzymes to ferment, and cutting off the air supply. And you get ethanol. So it's no rocket science. But the issue is how much ethanol molecules can you get per molecule of sugar or carbohydrate you're burning. And the more complex the carbohydrate is, the less the ethanol. And that's the reason why this biotechnology guys in UC Berkeley are doing special microorganisms to decompose wood, which is the most complicated carbon in plants, and turn them into ethanol. So when you say why can't they use residue, I'm not sure that the residue has got enough source substrate of carbon for these guys to get enough ethanol.
However,
Because remember now, a residue in a plant would contain the least amount of usable material, because the plant itself is conserving the carbon into fruits and into the roots. If you're dealing with a potato, papas, the carbon is in the root, in the potato. And if you're dealing with a maize, the carbon is in the grain, not in the leaves or the stem. So when you say residue, you are not using the carbon, you are not using the seed in the case of maize, and you are not using the root in the case of papas.
would it be better than just farming, for example?
So do what?
It wouldn't be better to, even if they have a low content, try to do something with them with biotechnology help and not burn the residues, the agricultural residues?
They don't burn residue everywhere.
No, but in the places that they do.
In one place they have to do it sugarcane, because it's the only way they can harvest sugarcane. They have to get rid of the leaves. So the only way they can get rid of the leaves is to burn. And the only place in our country where sugarcane is grown is Florida, Louisiana, and a little bit of California, no other place. But it's a bigger problem when it comes to tropics, because sugarcane is a C4 plant. And it grows in tropics. Mexico, Africa, Brazil, maybe someplace like this. So burning is not the problem. In fact, there's a bunch of eco-freaks that actually want to burn this in power plants and recover the energy from burning the residue. Except there's a problem. Anytime you burn things like residue, you generate fine particles in the atmosphere. And the control of fine particles is extremely difficult and expensive. The only place where I know they control fine particles is surgical units in hospitals. Because when they do cardiac surgery or whatever surgery is, they got to keep the dust out. They spend a lot of money. It's not cheap. They use what they call absolute filters in hospitals, good hospitals, where they do heart surgery and things like this. They use absolute filters. And there's absolutely nothing coming in. They actually allow the air to get out, forced air circulation. Zero input type systems, but it's expensive. You see, years ago, Dr. Ram, these eco-freaks are always doing this. They drive me crazy. Years ago, they had this. RFD, refuse derived fuel. RDF, excuse me, refuse derived fuel, pardon. So these eco-freaks got the idea, they take all the basura and burn it up. And the state was going to build 6 of these in our state. Until some people started arguing, asking the question, what kind of emissions would you get? For example? Because remember now, plants are the source of a lot of trace metals. Arsenic, nickel, vanadium, beryllium, gallium, you name it. Boron. You can control those because they're in fine particles. So ultimately people got mad and they started shouting. The government said, we won't do this. So they never took those. The idea is good. The technology exists. But who is paying the bill? I mean, here's the thing for you. I think Dr. knows about 60, 70 kilometers from my house. There's a huge power plant. Coal. It's using coal to generate power. But they built this power plant, it cost them $680 million. This was 30 years ago. Okay. They were required to control sulfur dioxide. And that cost them 40% of the total cost. So there is technology, but somebody must pay the bill. That's the key. And this is the reason why, if you go to some of the communist countries and some of the developing countries, you won't see any controls because it's expensive. So this is the point I was making. There needs to be a balance between the amount of cost and the amount of benefit that you're getting. If the cost exceeds the benefit, you're busted. You're bankrupt. That's the problem. I mean, people have lots of ideas, but one needs to sit down and think what it means.
One thing is to produce ethanol from corn or from sugarcane and some electrons or residues. But what about biofuels from soybeans?
They're using it too, diesel. Diesel fuel.
Diesel.
They're using soybeans for diesel. Now they're saying the new ecological idea is let us not use the land. Let's grow algae. There's humongous testing going on now of growing algae in lakes and extracting the algae. I don't know what they're getting, but a lot of talk.
Because I have read that in Argentina and Brazil, and they are very much criticized, they are cutting off trees, forests to cultivate soybeans.
Well, what they're saying in the U.S. is this is a new wave. There are lakes that have, these are single cell algae. These are not the ones you see in the ocean. These are unicellular algae.
Okay.
Chlorella, cytonema, and things like that. So what they're saying is there are whole lakes that are not being used. You cannot use them for drinking water. You cannot go in a boat because they're they're more or less second-class lakes. But they have algae, a little bit. To increase the production of algae in these lakes by adding more and then extracting them and allowing them to come back because they reproduce. It's like bacteria, except they got chlorophyll. That's the latest trick.
So they need to sort of seed and cultivate that Trepocalas lake, as you mentioned, to grow this out. I mean, they don't just grow spontaneously.
No, but you see, believe me, these lakes have plenty of phosphorus.
I see.
And
Okay.
plenty of nitrogen.
So they are eutrophied, right?
Yeah.
Okay. And the audience are going to clean up as well?
I don't know. I'm not in the field.
That's
what's
interesting. I mean,
That's what these people are saying. Because on one hand, environmentalists are saying you're using up food production, so don't use it. On the second hand, even if you use something like miscanthus, it still requires land. Maybe old land, maybe land that's not being cultivated, but still requires old land. And if I really want to be a difficult person, I could get up on the street and shout that miscanthus is changing biodiversity. Well, this is the thing. It depends on who you talk to.
So as a whole, there is no way, still no way to produce enough energy to substitute our fossil.
There is enough energy, as is, I think. The only difference is we have not learned how to conserve. Like, for example, in my class, Dr. I asked the students, I also, by the way, teach combustion technology in my class, about how controls are working with various sources. And one of the questions I asked my students is, how many of your parents have this big sports utility vehicle, the big monsters that go around, people are driving?
The Hummer ones.
No, it's not the Hummer. It's the big, what do you call them? Like these are not cars. These are not big vehicles. They're,
Okay.
The trucks.
what is it?
The trucks.
Like, for example, if you take Toyota, they have a big vehicle called Highlander.
Like USVs?
SUV.
SUV, that's what I'm saying.
You said sports utility vehicle.
SUV.
That kind of cars.
SUV.
Uh-huh.
Now, until now, in the US, SUVs were not classified as cars. Until now. That means they were not subject to emission control as the cars. They were subject to emission controls of trucks.
That's right.
That means they were allowed to emit 7% more carbon dioxide per SUV. Because it's monstrous engines, that's all they can do. And so now they're passing law, starting next year, SUVs are going to be classified as cars. So they have to comply with the lower regulation. That means they have to add more whatever they do, increase the price to reduce the emission. The point is, I asked the students in my class, how many of your parents have SUVs? 2 out of 3. So I asked the question, are your parents have a lot of things to carry? No. Do you have a huge family? No. Do you have a house in the woods somewhere where there are no good roads, so you're driving it? No. Why are you driving it? Answer, my mother thinks she has better control on the road. She feels safe. See, she's sitting here. I'm sitting here in my car. So when she looks at me below, she feels safe. See, this is the kind of problem we have. And if you don't buy SUVs, you can save gas. Like, for example, I have a car that's almost 10 years old. Okay? Nobody can tell it's 10 years old. It does not even have a scratch, inside or outside. Now, how many kilometers do you think I have on it? 10 years old.
Less than average. You use it just to go to work and
I'm not telling you. How many kilometers do you think I should have?
I would assume less than average.
Okay, what's the average?
I
Per,
don't know.
per year?
Yes, I don't know what own a car. And I don't plan on for as long as I can.
In 10 years, I've driven 100,000 kilometers. 100,000 in 10 years.
And how does that compare to
the
residential users?
Compared to the average, By the way, the 10,000 kilometers, 4,000 kilometers were when we were on vacation. Okay, then you put more kilometers because you're driving further distance. My wife and I drove to Colorado and Wyoming and all this. So 4,000 kilometers is an artifact. But if I actually, don't worry about it, 10,000 kilometers is what I have in my car. The average in Minnesota is 18,000 kilometers per year.
It would be twice as much for 10 years. Double.
Yeah, almost.
So you need to conserve. I don't drive unless I have to. I drive to work, Dr. knows. I drive to work every day, or sometimes I drive to some other thing by in the Mercado or something. My wife wants, I don't know, Papa's fritas or something. I just go buy some. That's about it. And very rarely I go out to eat. And if I do, then maybe I'll drive.
Yeah, but you see, from the family point of view, in U.S. they have much more cars. Family.
Much more what?
One family.
As what?
As somewhere else.
More cars.
In U.S.
No, that-
they have a lot of cars. They spend a lot of fossil fuels because each one has a car.
Yeah.
It's completely different as here.
Independent of what, whether it's US or Yugoslavia or South Pole, people need to conserve.
Yeah.
I'll tell you, I was standing at the gasoline station. I know the guy who owns the place. And he usually likes to talk to me because he knows who I am. So I went there to put up some gas in the car. These two girls came, maybe 16, 17 years old. They were driving a Porsche Cayenne SUV. It's the most expensive SUV in the world. 16, 17 years old. Their parents bought them and give it to them. Because these people have so much money, they don't care. A Porsche Cayenne costs $65,000. Can you believe this? Wastefulness is a problem. And it's in conflict with conservation. The two don't go together. If you're a conservative, you don't waste. If you're a wasteful person, you're not conservative.
Conservative not in the philosophical way, I hope.
No, I'm saying, what do you do about the energy situation? You need to conserve.
And the water is
Same thing.
Yes, we could also just say conservation as instead of conservative, because that has more political conservation.
Well, no, conservationists are other things, something really different that I don't really.
Well, there's also another issue.
Yeah.
In the US, we may have more cars than here, but if you look at the traffic here, it essentially negates the value of having less cars. You spend more time on the highway driving than we do.
And the what?
I would.
Oh.
Do we?
Yeah, I mean, because they're in traffic jam, go to Mexico City.
Okay, no, in the traffic jam, but the distances.
Hours, traffic
In the
jam.
middle of the traffic jam and the state of the roads are.
Actually, cars are consuming more gas in traffic jam than when you drive. Every car has an optimum performance. That's not in a traffic jam. If you look at most cars, the Japanese type cars, they perform best at 55 miles an hour. They conserve gas. I mean, it's really funny. My wife has got a car with a turbocharge,
That's what I was going to say.
and I have a car without turbocharge. My car is 6-cylinder, hers is 4-cylinder. I've driven both cars, and I've shown it to her. Exact same mileage per gallon. because of how you drive and the conditions. So conservation can occur in many ways, but when you take something like Mexico City, whether you drive 5 kilometers or 15 kilometers, the traffic jams are so bad, you're consuming energy. And it's actually, when you drive, it's a lot easier. So independent of what, that's what people need to do. Now, of course, in the US, as usual, they have all this modern technology, electric cars, you know, hybrids, and this electric cars, you have to plug in, they're only good for 500 kilometers maybe, before the battery dies. And you have to take it somewhere and plug it all night.
Now, what about electric cars? Is the residue, is it
Too early. Too early.
too much residue from the batteries to
No, the batteries are such that they don't use a regular battery. They use some kind of a special alloy that stores the electricity. The problem, let me put it this way. How much is a battery in a car? Anybody tell me?
Any kind of car?
Any car.
$100?
About
Good.
80, I think.
Now, I'll even say 120.
Okay.
I'll give you guys credit. You know what the battery in an electric car costs? $3,000.
And how long does it last?
I don't know.
It's still the
Electric car. Yes.
No, what they do is these people who are driving electric cars are buying seguros from the car manufacturer, not from the insurance company. They are buying it from the manufacturer, that if the battery goes bad, they have to replace it. So it's better buying the seguros than paying $3,000. And you can't find this battery in a shop anyway. You have to go back to the dealer. So if you have a Toyota, the battery dies on a Toyota, you have to go to a Toyota guy.
or have an extra battery with you, like they do with tires. So you carry an extra tire, so you carry an extra battery.
I don't know. But whatever it is, I mean, these are the problems why people don't. If you're trying to conserve, again, it's going to cost you. Everything goes back to cost. All right, where were we?
But the future is solar energy. The problem with energy, I work on energy. And the problem with energy, renewable energy, is that fluctuates. You don't have a continuous source of energy. And it's not per se clean. Of course it has some impacts. The variability, the idea is not going to beg for one single source of renewable energy, but for a mix. It's not practical to have this type. What? To have electric cars and to have hybrid and to inject CO2 in a saline.
Then I teach a class in the School of Engineering. And so when I go to the School of Engineering to teach, the chemical engineering people are right across from the classroom that I'm teaching. And invariably they have student competition. And so they have put all these posters on the wall. I found out there's a faculty member there that's actually using electrolysis to generate electricity in a car.
I see.
What he does apparently, and this is going to be the future, is they have a membrane. The membrane is charged. When the water molecules flow across it, it becomes hydrogen and oxygen. The hydrogen is then used to drive the car.
So hydrogen cars.
Well, except it's controlled. This is not a bomb.
Oh, no.
And it's unlimited. As long as you can control the electrolysis, it's unlimited.
That is the plasma, nuclear plasma. It wouldn't be an excellent source of energy, and it hasn't been developed, the technology to be able to use it. You break it immediately. Sorry.
Okay. Now we are in this particular situation where we look at the total area harvested in hectare. You see, India harvested 83 million hectares. China harvested 83 million hectares. This is in 2003. India harvested 83 million hectares. And so on. You tell me why 3 of these countries have the same hectares. This is not incorrect statistic. This is in UN book. And how they calculate this is every county or every area of land in a particular county reports how much is being cultivated. Except there's a problem when it comes to a place like Mexico. This is an underestimate, clearly. Clearly this is an underestimate because there's no way of them accounting for the subsistence farmers because there are no records. So that's an underestimate. I don't know what it is. Then if you look at the percent of total area harvested in the world 2.1 billion hectares is harvested, of which 13% comes from India, 13% comes from China, 13% comes from USA. Because they have the same amount of land cultivated, therefore it's the same percentage. What is the total production in metric tons? This is where separation starts. India, 280 million metric tons. China, 381 million metric tons. USA, look at this, 447 million metric tons. Same amount of land, but look at the production. Because here they are still practicing manual production. Here it's corporate farming, mechanical production, biotech and everything else. If you look at the percent of total production in the world, 10% India, 18% China, look at this, 21% USA. 1/5 of the total production in the world comes from across the border. Harvested area per capita, per person. So here what you're saying is, I'm taking the production, I'm normalizing the production for the number of people in my country. So population starts now influencing what you're producing because it's most important. Because what's available per person is either causes normal food supply or causes deficit food supply. So here if you look, the per capita production in India is 0.07. In China it's almost the same, 0.06. US, look at this, 0.7, 0.28. 4 times more. Mexico, 0.12, certainly double of this. And it's higher than the world average. If you look at production in metric tons per capita of total population, you see 0.2 in India, 0.3 in China, 1.5, 5 times more in the US. Mexico again is 0.76, 3 times the global average. I won't go here, but you see there's a distinction. The reason the distinction occurs is because of the nature of crop production and the efficiency of how we are gaining per hectare per person.
And despite having that huge for that area harvested, India and China need to import food.
Yeah. Mm-hmm. Yeah. China much less than India because Indian population keeps growing. China's population is more or less steady. If you look at the major crops and how they are ranked, maize, USA is number 1 in the world, China is number 2, Brazil is number 3. If you look at rice, China is number 1, India is number 2, Indonesia is number 3. If you look at wheat, China is number 1, India, USA. Soybeans, USA, Brazil, Argentina. Here, the reason this is very high is because, as Dr. Ra was asking earlier, they're growing soybeans like crazy for diesel fuel.
But that's 2003 and now it has changed and Brazil is number 1 or what?
No.
No, it's still...
No, there's more and more land in the USA now going to soybean because of diesel fuel. Because our main transportation in the US is diesel, not trains. If you go into any of the major highways, you will see trucks going one after the other forever. Because in the old days, that's what they did. They removed the railway system and converted everything to highway system. And the highway system is all diesel.
And we have here the same problem. We follow this pattern.
If you look at barley, Russia is number 1, Canada is number 2, Germany is number 3. Now, we don't know much about this. If you take this distribution of these crops and apply climate change, this might change completely in the future. If you look at the genetics behind these crops, most of these crops, there are 2 types of crops. There are crops, 2 types of plants. There are wild species. The wild species have been domesticated to become crops. I mean, these crops didn't come here by spontaneous generation. They were derived from their ancestors of the wild variety. If you look at the wild species, the genetic diversity is very high. Any time you have genetic diversity that's very high, although production may not be high, their ability to survive conditions are much superior to narrow genetic traits. Because when you have narrow genetic traits, if something goes wrong, the whole thing will go wrong. So for example, when you domesticate this wild genome and you compress this, you end up with domesticated species. The more you compress, less the diversity. And this is one of the reasons why you have epidemics of plant disease. For example, you know what an epidemic is? The reason you have epidemics of plant disease is because with the modern cultivars, you have essentially compressed this genome to here. There's no diversity. And it's terrible in the US because these breeders keep compressing it because they're only interested in yield. In the process, they're compressing and compressing and compressing. They end up with this kind of lack of diversity. Now what happens is, if this keeps going, it can only go to a point and it will stop. After that, independent of what you do, you will not get more yield. Because that's the end of the line. You have used up the genome. So, they now apply biotechnology. Because since they are running out of genetic capability, they are introducing foreign genomes into a particular host genome. So for example, if you take mice, one of the limiting factors of mice is insects. Okay? And they use chemicals, which is forbidden. It's not allowed anymore. Because environmental people don't like spraying chemicals. So you have to control the disease. Because like I said, production, net production is the product of production minus loss. So they have to cut down the loss in order to increase the net production. And one of the ways to do this is, for example, there's a bacterium called Bacillus thuringiensis. This bacterium produces a toxin that kills these insects on corn. So what they've done is taken the genome from the bacterium and stuck it in the mice. So now the mice produces its own toxin to this insect. So there's no chemical use. the insect is kaput.
Does it have any second effect or
What?
does it have any other effect apart from the insects, the mice?
This is the argument. Some people believe when you change the genome, in addition to changing the trait that you're looking for, you might have changed some other trait you don't know. I'll give you an example, and I'm not a geneticist. When I first went to Minnesota, the university told me that I told them I don't know anything about air pollution. They had said I had to work on air pollution. I said I don't know anything about air pollution. I'm a chemist. They said that's why we hired you. You use your chemistry to study air pollution, and then you use the information you're getting from air pollution to tell us what effect it's got on agriculture. So one of the things I did was I had to learn. So I took a bunch of students and run around the state looking for something in the bush. Ultimately, I stumbled on the soybean. And the soybean had ozone injury on it. So I came back excited, showed it to the soybean breeder, and asked him what's unique about the soybean. There are two kinds of soybeans. There's what is called as the determinate cultivar. That means the plant will only fruit once. So if you get early frost, you lose the crop. There are what are called as indeterminate cultivars. Once they start flowering, they'll keep flowering in steps. So you'll get fruits all the time. Like in a, what do you call a cucumber or whatever plant, tomato, it'll keep fruiting. So if you get frost, you won't lose 100%. You may lose 10% because already the plant has got 90%. So he said, this is the first year we planted this new variety. And I was excited. I checked with a lot of people who know the subject. They all told me it's ozone, don't worry about it. So I was excited. So 2 years later, all of a sudden I could see this anywhere. Nowhere could it be seen. It turns out these cultivars that he produced were susceptible to root disease. And so people started complaining. So he went and did whatever he did to make this plant resistant to root disease. In the process of making the plant resistant to root disease, he also made the plant resistant to ozone. No symptoms, no disease. So by manipulating one genome, you are changing something somewhere that you never knew. In this case, accidentally I happened to see it. You know?
So you can turn out in a very different way.
This is what Europeans are saying. Europeans are saying we do not want biotechnology in Europe because you have to show us that it has not altered something else. That's tough. You know why? What do you think is tough that you cannot show something else is altered? Or how would you show something else is altered? Let's start the right way. How would you go about that when you altered one gene, you have not altered another gene? For example, how do you go about it?
There are many genes and the possibility of combinations are immense.
No, the problem is something else they don't want to admit.
Which is
You can map a genome.
Yes.
That's only a map. You have to identify which gene controls what. They can't do it. It'll take them years.
And not only what it does independently, particularly, but in the interaction.
Whatever it is. The Europeans are saying, you first have to prove to us this is harmless. So if you look at it, in 1996, 1.7 million hectares of land was cultivated under biotechnology. In 2004, 81 million. If you look at the number of countries that are using biotechnology, in 2004, 6 industrial countries and 11 developing countries. There's a difference. The industrial countries can afford to challenge the question. What is the effect of changing the genome? The developing countries don't have that luxury. To them, immediate supply of food is more important than standing around arguing. So developing countries have accepted the idea of biotechnology more easily than the developing countries that are actually doing this. Okay? If you look at the countries that are by rank in 2004, of course USA is number 1, Argentina is number 2, it is Mexico, number 12, out of 14 countries. What are the factors that actually influence production in developed countries? First, let's look at developed countries. US, for example. The factors are increased urbanization. Urban areas in my country, or developed countries, are growing. In 20 years, the house we built 20 years ago was at the outside the city. Now we are totally surrounded by houses because they're growing. Can you believe now they have built houses past ours to Forest Lake? 20 miles out?
No, they don't. Yeah.
No.
But
Huh?
you take them.
Yeah. They've grown. Every city is grown in size because of migration from rural to urban areas.
He lives in a very nice area. Minnesota is a beautiful state. There's 10,000 lakes, and they live close to a lake, very nice lake. And it was completely isolated when they built the house. And now you are
Surrounded.
by new houses.
So it's a suburb of now.
What?
It is a suburb. No. This idea of the horizontal growth of the city in America is quite,
It's a very bad idea.
it is a very bad idea.
It's a very bad idea because, like for example, where I'm living now, there is only bus service twice a day.
Mhm.
Once in the morning, once in the afternoon. And if I don't get one of these buses, I have nowhere to go to work. And even if I catch this bus service, I have to switch the bus. By the time I do all this, I did it once just for fun. It took me almost close to 2 hours to go to work.
That is transportation and services. I mean,
Yeah, the
to
problem.
take water, to take electricity, gas. It
Yeah.
is
Yeah, but the problem is they cannot afford to do services and transportation because the size of the city. It grew uncontrolled. Like for example, in our town, there are no houses next to each other within 20 meters, just on the side. Then if you look in the back and the front, like for example in my house, in the back, I have 50 meters of space. In the front I have 50 meters of space. Then on the side I have 30 meters there, 30 meters there. So the town is spread. So it's not very easy to have a bus system to pick up a lot of people.
Yeah.
And it's not very easy to put a train because there is no facility for the train to go to a place where most people can catch it.
They are used to have everything for every convenience. I mean, no public transportation, but each one of them having a car, because of the noise in the area. Also the members of the family having car, own car, yeah. And now they are facing this problem of needed public transportation, and it's very difficult.
They have public transportation.
Very scarce.
They have public transportation, but that's only in the inner city, where houses are built differently. But they don't have any in the outer circle of the city because that's where this problem is.
Yeah, but as time passes by, people prefer to live in the suburbs. Or that is the model, that is sort of the perception that I would like to live outside.
Shall I tell you a joke?
Please.
The people living in the suburban areas are actually being exposed to more pollution than the people living in the center city.
Because of the wind direction.
These people don't realize it. They are being gassed by ozone and everything else much more.
Like in Mexico City, the residential areas receive more ozone than other areas. Yeah, it's a north to the south, south and west, was the wind, the dominant wind carries or ozone.
Yes, I did my MSc on the air quality of Mexico City, aerosols, heavy metals. And all the industrial part of Mexico City is at the north. That's on the Rosa, Valle, all these places. And I was working with the monitoring network in Mexico City, collecting their fiber glass filters of high volume test. And then I analyzed that. In the whole city there were 32 stations, monitoring stations at that point. And the ones with the highest lead concentrations were at the south because of the wind.
If you look at the summertime ozone, the most frequent and the highest exposure occurs in Pedregal.
But at the north part, they have a problem of particles.
Yes, they do.
Very bad. So there's no choice. The particles or
The other thing is population migration. These two are connected. Because as the population migrates, there's increased urbanization. Increased mechanization. This essentially means more production, but less manpower. That influences the migration, because most farmers no longer cannot compete with mechanized farming. Decreased dependence on labor, that's what it is. Better disease, pest and weed control, biotechnology. That means higher yield. Like I said, if you take the net production and subtract the loss, that's your net production, and because you have controlled the disease, pest and weed better, you get better production. Higher yields. Farm consolidation. This simply means the major companies are coming and buying up all this land from the farmers. And so these farms are huge, thousands and thousands of hectares. For example, if you take Minnesota, 36% of the land is owned by corporate companies. And so the farmers cannot compete with them. What about developing countries? Of course, increased population. You also have rapidly growing urbanization. Same as in the developed countries. More people migrate, the more they grow. Decreasing cropland. When you have a place like India, as the urban centers keep growing, the croplands get less and less. Like for example in Rwanda, one of the people that I used to work with, he said, if things went normally in Rwanda, by year 2020 there will be no land left to cultivate.
Yeah.
But there's always an independent variable. The Rwandans had a war, big war, and killed each other, half of them. So they controlled it. Declining farm resource. Remember I told you in Africa, for example, in the next 20 years, there will be a decrease in the availability of fertilizer. There's a decrease in the availability of water. So these are farm resources. And this takes money. And unless the government subsidizes farming, these people cannot afford to produce, buying fertilizer, trying to redirect water availability. They can't do this. And this is where, for example, I'll give you an example. How many of you know of the Green Revolution? People didn't realize the Green Revolution, Borlaug's work, the high production of wheat is based upon higher use of fertilizer and higher use of water. Okay? In India, Trago production is all in one corner of the country, northwest. The entire northwest is nothing but Trigo. So what the Indian government did was to give money to the farmers to drill holes in the ground to get the water out for irrigation. They gave money for fertilizer. They gave money for electricity to get the water out. For some 20 years, everything was fine. Then all of a sudden they realized everything. What happened was, when they drilled thousands of wells and drilled the water, took the water out, the water table changed. And so as the water became less and less here, the water table kept moving towards areas where there was more water, gradient. And when the water went that way, the fertilizer went with the water. So in effect, you have a whole area now where the land is totally dry, no water, and they can't do anything. They have a whole bunch of land over there where there's excess water, but it's all salt. They can't do anything. So net effect now in Punjab, there is no green revolution. Dead. This is the problem. Because the farmers thought the more better yield they got, let's add more. Because they must get more. You know, it's like this. When I was working in southern Minnesota, I borrowed a piece of land from a farmer who was growing soybean. He was one of the biggest soybean growers in Minnesota, and he was a very well-educated fellow. So I went and said, can I get a piece of land to do an experiment? He said, of course. So I started this experiment, and we became friends, and I used to talk to him. One day, I was standing there in my work, and I saw him going around spraying fertilizer on soybeans. So when he came back, I asked him, why are you spraying fertilizer? See, if I sprayed fertilizer and there's already nitrogen fixation in the roots, I get more nitrogen into the plant, and it's got to produce more. What he did not realize is fertilizer suppresses nitrogen fixation. So at the end of the summer, I didn't say anything. At the end of the summer, I went there and says, what happened to your experiment? He says, you know, the yield was the same as last year. I said, Howard, I can tell you now, you essentially killed all the bacteria that fix nitrogen, so you replace the nitrogen fixation with your stupid fertilizer. See, that's what these people did. The more they were able to get increasing yield, they decided, well, we can do even better. Then, in fact, ultimately the whole system collapsed. Declining crop products down there in the land, and declining biodiversity. Because when they did the Green Revolution, they essentially compressed the genome into one narrow trait, yield.
There is a factor there, exogenous factors, importation, public policies, exportation, economy and political factors which influence a lot of security.
Now let's look at something else. What is the total increase in population during the last 50 years? If you look at the total population, it increased at the rate of 1.8% per year. If you look at the urban population, see, 2.7%. So in other words, of the total population, most of the increase is here in the urban, at the expense of rural population. If you look at the fraction of urban population to the total, in 1900 it was only 13%. In 2000, 47%. If you look at the increase in the number of mega cities, that is population of over 10 million. In 1950 there were only 2 of them in the whole world. Now there are 28 of them and growing. So there's a clear imbalance between the distribution of population and food supply. Well, no. More people are sitting around in the cities and less people to produce the food.
Yeah.
So we are heading towards,
Huh?
we are heading towards a not very nice scenario.
Well, this is what John Malthus wrote.
Yeah.
John Malthus wrote that the population will increase exponentially, agriculture will only increase arithmetically. So the two will never meet. As the population keeps growing, the gap between the population and the agriculture will keep increasing this way. Ultimately, you'll have to starve. So at some point. Now let's look at it a little bit here. Did I show this already?
No. But I have a comment. There is a trend towards producing food in the cities. Urban agriculture.
It won't make a dent.
Vertical farms are being suggested.
It won't make a dent. The amount of food consumed versus, for example, at least in the U.S., there's no such thing as urban agriculture because there's not enough land to produce it.
That's why they are proposing a vertical farms.
Well, they can propose whatever they want. It doesn't mean anything to me. I mean, like in Japan. Like in Japan.
Like in Japan.
Yeah, let me finish Japan.
Okay, well, what are they doing in Japan?
Very easy. If you go downtown, Japan,
You mentioned it.
yeah,
Yes.
yeah, you go into Reforma type street in Japan, where every building is 50, 60, 80 stories tall. In between these buildings, you'll see rice production.
Uh-huh.
The reason the rice production is taking place is there's a law in Japan. If you do not use the land, the government takes the land. So what these guys have done, you know how much rice production we're talking about? How about the size of this room? One building. So somebody wants this empty space, they could have built another building, but they don't want to build because they want to make more money. So they plow this room and plant rice, just so they can say I'm using it.
But it's significant, this amount of land.
That's what I'm saying.
But
There is no such thing as urban agriculture. This is
these
nonsense.
vertical farms are, they are suggesting to have
Doctor,
very flow.
they can suggest whatever they want.
I mean, but it is an idea, and we have to learn also. if it's
Let me tell you about
correct or not.
Let me tell you about learning. Most urban areas where there's empty space, they're all full of hazardous waste. These are called brown islands. You should not cultivate anything on them other than what's there. These brown islands are dangerous, deadly. Because what people do over the years they've done, when they see empty space, they go dump it. No. These people don't know what they're talking about. They need to go lie down and have a psychologist examine their brain. Urban forestry is another issue. Like, for example, there are a lot of people now planting trees, first to sink the carbon dioxide, and also to make the area greener. And there are tree species that are selected for the urban environment. Like, for example, if you take Minnesota, we get a lot of snow. So when we have snow on the road, how do you drive? So they put salt. And the salt melts and causes salt toxicity in the soil. Or when the car is going, when it melted, it's spraying on the tree and killing all the leaves. So what they've done, over the years, they've selected species that are salt tolerant. They plant them, and they grow fine because they're salt tolerant. They keep the area green, and they keep people from throwing things in there.
Okay, and do they have any other effect on the land, on the biodiversity?
There's no lawn, these are just trees, arborvitae. And they grow, they are pretty to look at. They don't need any maintenance.
Well, in London they planted these platinums.
Yeah, the London plain. Next time you go there, you observe. It's very sensitive to ozone.
It is?
And if you look at the leaves, they turn yellow in August.
Yes.
and go away.
Oh, and on top of that, I don't know, I haven't been able to explain it, but they released huge amount of pollen. I became pollen allergic to pollen.
One of the responses of plants to stress is to reduce the carbon allocation. Well, there are two things. Carbon allocation can result in two things. Change in numbers of seeds and fruits, change in the size of seeds and fruits. Okay. If you are talking about change in numbers, that means increase in pollen production.
So there are really stressed for trees.
Like for example, if you go to San Bernardino Mountains and look at ponderosa pine, Pinus ponderosa, the seeds are smaller, but there are more. And because the seeds are smaller, they are not very viable.
Yes. I remember when I used to visit the mines, the copper mines in Poland, the poppy flowers, they were about this size. Tiny. I had never seen them that tiny.
Yeah, if you go, for example, from Harrods across the Hyde Park towards Buckingham Palace,
Okay.
you have London plains on both sides.
Yeah.
And if you go there in the fall, not even fall, August, September, you'll see all these trees turning fall color.
Yeah.
Premature senescence. It's very, very typical.
Yes, I do.
And similar in Poland, if you look at the poplar in southern Poland,
Yes.
near Katowice, Wrocław, in those places, the leaves will be smaller than the normal healthy poplar. These are all very typical stress response. So let's look at the final one. Where are the poor people in the world? I'm comparing here the distribution of people in 1981 to 2001. If you look, the highest number of people that are poor are in East Asia in 1981. In 2001, the highest number of people that are poor are in South Asia. The reason for that is East Asia contains China and India. They have managed to change their economics much better than when you say South Asia, you are talking about Indonesia, Sumatra, Java, places like this, where people are still living in jungles. They don't have any technology to speak of. And therefore their economic situation hasn't changed. Now if you look at where the rich people are, of course, the rich people are in US, Canada, and Oceania. Oceania means Australia and New Zealand, primarily. So,
Sorry, I was expecting to see Africa where there's extremely poor people.
it is.
Well, but no.
Sub-Saharan Africa, right there.
Yes, but
But it doesn't have as much people as
South
Asia.
Asia, exactly.
Has more.
They're killing each other. There are not much people there.
Okay.
If you look at the rich people, most of the rich people are in US, Canada, and Oceania, and in Japan, and in Western Europe. Okay, common sense. Now, there is what is called as a gap in living standards. And one of the ways to calculate this gap is what is called as GDP. GDP means gross domestic product. In other words, this is the amount of product you have that you can export, import, do whatever you want. You can do the balancing of the economics. In order for the people in the poor country to reach the minimum living standard, 0.5% of the GDP, gross domestic product, you need extra money from other countries in billions of dollars. So if you look here, the aid given in 2003, Sweden is number one. They gave the most support to poor countries. Netherlands is number two. España, number three. Canada, number three. The worst guys are here. US and Japan. Now, if you want to change this and give more support to reach this 0.5% level, look at the gap. US has to give this much more money. Japan has to give this much more money. In other words, the rich countries are not helping. They are busy fighting wars, spending money.
But not Japan.
Well, Japan is another issue. They are not giving because the yen is going down and down. You see, Japan is an interesting story. I told you, we had a student stay with us from Japan. So we got to discuss quite a bit of Japan. And he told us, what happened was after the Second World War, when Japan got bombed by the atomic bomb and virtually everything destroyed, the Marshall Plan allowed Japan to reconstruct by providing support. At that time, many of the American industries went to Japan and opened up factories. General Motors, Ford, Chrysler, you name it, they were all there. But the Japanese didn't like this. They wanted to make it all domestic. So what the Japanese did was to sell bonds to the Japanese companies, interest-free bonds. So the Japanese companies can buy this and outcompete the foreign companies. So all the foreign companies went away. So everything in Japan was taken over by the Japanese. Except there was a problem. All those bonds were due 50 years from the time they were issued. They didn't have, because of the yen being inflated, they didn't have enough money to pay the bonds back. And therefore they're always in a deficit budget, internally. And that's why that problem exists. It's a manipulation of the money market.
Everybody knows that.
So here the government did this. And this is the reason why today, how many of you want a Japanese car? Anybody here?
I told you we don't have cars.
How many of you want a Japanese car? Nobody? If you, for example, buy a Japanese car in the US, a good one,
They were recalled,
a good one, it'll cost you about $35,000. Okay, you can get a good, high quality car for $35,000. When I was in Japan, I found out the same car in Japan costs 2.5 times more for the same car. In other words, I can buy a Japanese car, a nice one, for $35,000. In Japan, I had to pay $80,000 for the same car. The reason, in order to compete in this funny money market, the Japanese had to reduce the price of the cars to export.
and they recover it internally.
There, in Japan, they recovered the money they lost sending it to US and other countries by inflating. These guys are doing same as China. China would not, they will not regulate their currency. All the other countries in the world have going currency up and down. The yen never does. They have uncoupled Chinese currency from the rest of the world. All kinds of funny things people do. And then of course, the European community. I told this to my friends and my student, my wife. I said, European community will not last very long. You know why? Originally when they started, it was a good idea. Let's go back and talk about it. Do you know who is the first person that tried to form a unified Europe? Charlemagne. Thousands of years ago, historically, Charlemagne invaded Europe to make it a single country. Charlemagne was followed by many others, Napoleon, Bismarck, Hitler. Every one of them failed. Now these guys thought they could unify Europe by making a common market. Well, that's all right. But then what happened was these people became more and more and more immersed in this idea. Soon they made policies other than being a common market. One of the policies is every European country in the Union must have the same living standard. So when they admitted places like Portugal, Greece, Romania, Bulgaria, Ukraine,
Spain.
whatever, their standards of living were different. Spain was a little better. The other guys were somewhere else.
They were very poor. No, they were really, really poor.
So they had to give money.
A lot of money.
French and the Germans and the British and everybody else had to give money. Now, you can get money, but you have to sustain it. And they could not sustain the production because you had to keep that money flowing. That effect, like for example, as you probably heard, Greece is in big trouble right now, Italy, Spain, Portugal.
That was not the only problem, you know. They centralized all the bureaucracy, and it was really difficult to have this independent and response to local needs as well.
Well, the only country that succeeded completely was Poland. The Polish people took advantage of this.
But not only they all of them.
They have not been able to sustain it. I know this because I go there. They have not been able to sustain the flow. That's the problem. Spain is in trouble now. That's the problem.
For Spain was a great advantage. They were very poor. I know Spain very well.
It's not a question of poor. It's not a question of poor and rich. You still don't get it. What you have to think about is not whether you are rich or poor.
Was much worse than Mexico.
It doesn't matter. You are not understanding what I'm saying.
Okay, explain us.
It's not a question of who is poor and who is rich.
Please, you explain it.
All right. Let's assume in a minute. This is the expected standard of living.
Yeah.
Okay? This is the expected standard of living. And every country in the European Union must be at this level.
Mm-hmm.
And initially, if you are here, your standard of living is over here, while the expected is over here.
Mm-hmm.
All the countries above the expected, by law, were required to give money to this country.
Right.
And bring this country up to here.
Right.
Okay?
Right.
But then the problem is this. In order for you to remain here, you need to sustain yourself.
Oh, yeah.
And they're not able to do this. And therefore they are slowly sinking.
And with that, they are carrying the other. But anyhow, it was a great help for Spain especially, and for Italy. Go up. And then they are not foolish, they develop quite a bit.
You haven't seen anything.
And for us, was very bad is North American trip.
Let me put it this way. Spain is nothing. You go to Bulgaria, Romania, take a look. Their living standard is not on this paper. It's somewhere here. They have to give money to bring them up. Spain is nothing. It's peanuts. You are talking about standards here.
Very bad. Was terrible.
Hey, I go to Spain 2 times a year.
But I was in Spain before you.
So? Would you like to hear some more history? Would you like to hear some more history?
No, I know Spain very good.
You know when I went
I was in Spain when Franco was there.
Let me put it this way. Do you know when I went to Spain? You have no clue, do you?
No, you have been in Spain many times.
No, first time.
Not in.
First time. Do you know when I went to Spain?
No.
1965. Franco was there. So the point is, you can argue all you want. The reality is there are people over here. That's what's causing their problem. They were very discriminatory, and they let the Romanians and the Bulgarians and the Ukrainian people come in here, and they're over here. And what you will see, the reason you don't see these people, they have longer distance to go to reach the balance. You will see the first effect on these countries that are here. Because the gap is small. And so you'll see the effect first at the countries with the smallest gap. And the countries with the biggest gap you won't see because it'll take a longer time. And that's what's happening. And so now, some guys are smart. England, Sweden, Denmark, they didn't change their currency. And so they are not affected. These people are. It's really funny. I came from Finland meeting to Stockholm to fly back to the US. I thought I'd go have a cerveza because I had time.
It's really expensive.
I know, but the joke is the following. So I went there, I ordered a cerveza, and I pulled a euro. And the guy looked at me and says, we don't accept euro in Spain, but we accept dollars. In Sweden, rather. At the end of the day, this is what is going to happen. So the people here are the ones that are going to drag this thing down. But it'll take some time. But you're already seeing the effect in Greece, Spain, Portugal, Italy. Now, Italy, everything is possible. So.
What happened to US, Canada, and Mexico?
Most people in the US don't want NAFTA. If you take a poll today, they will not agree.
Mexico didn't want the NAFTA either.
Yeah, we didn't either.
And then?
Who knows, politicians.
It was worse for us than before.
Yes, that's for the US segment.
So we don't. Most people in the US don't want NAFTA.
US didn't.
They don't want CAFTA either.
I see. Well, Mercosur looks interesting, you know.
Pardon me?
Mercosur, Brazil, all these guys, South America.
Yeah. Now they signed CAFTA, they don't want that either.
I see. Okay.
There's a lot of angry people in the US about NAFTA. They don't want it.
We don't need it.
So I don't know.
What to do? What to do?
I think that we redesign the instrument and really define the cooperation. The more we don't have an open market, that is structure. But we are having the consequences of that.
I mean, even with NAFTA, I see terrible problem every time I travel to Mexico or to Canada. Both countries, they do not want change in their import-export regulations. So for example, when I go to Canada, I want to take a piece of equipment, I have a terrible time.
Well, you saw what happened when we just want to cross.
Yeah. So personally, most US people don't want NAFTA. We're stuck.
But they don't really understand the consequence of NAFTA. What is the spirit of NAFTA? Because in here we have to study, remember, at some point. And people were really interested in learning what NAFTA entrance applied to the country. And I don't know, it was something similar happening in the US. They just didn't want it.
Well, no, the problem we are having is totally different. Thanks to one of our great, we have many great presidents. Okay, and I can give you their IQ, intelligence quotient.
Yeah, I know.
There's an institute in Philadelphia studied the IQ of some of the past presidents.
Let me guess.
The acceptable IQ is 120. The acceptable IQ is 120. 120 is the comfortable IQ. That's the expected. Bill Clinton is number 1, 165.
165?
That's his IQ. He was a Rhodes Scholar in Oxford. He's no pushy. John Kennedy was number 2, 160. And on and on. But there were 2 guys that have a genetic linkage that were below 100. Both of them have the same name. Guess. Huh?
George W. Bush.
George Homer Bush and George W. Bush.
How much did they get?
Huh? 90.
90.
91, 90. Nobody below them. They were hit. So if you're asking for a reference point, they are there.
And they run the country, believe me.
The point I'm making is, when Clinton left, in our country you can only run for president twice. So when Clinton left, George W. took over. Clinton left the country with $1.8 trillion in profit. George Bush has now gotten us to $9 trillion in the hole. And all we are doing is borrowing money all the time. I joke, we are going to be soon called the United States of China. This is the problem. And the people in the country are very upset. Because in order to pay off this stupid $9 trillion, in order to maintain balance of payments, he had to import.
If there was some piece of George W. Bush, why did they vote him for a second term?
Don't embarrass me.
Sorry. I
Don't embarrass me, please. My German friend, he and I have been friends for 25 years. He's like family, vice versa. When I'm in Germany, always I'm staying at his house. And we are cooking and having a few drinks and having a good time. About 3-4 years ago when I was over there one time, afterwards I was sitting in the living room, he said, I never asked this question. I hope you don't get upset because you're my friend. But would you mind if I ask you a question? I said, sure, Jürgen, what's the question? He says, how did George Bush get re-elected? And first I said, would you believe the answer? He says, what is it? I said, most American people are not educated. You know what you think American people are educated? No. Just because you went to high school doesn't make you an educated person. And the only thing they do, they are self-centered people. What is it for me? In other words, I can get elected tomorrow. If I promise that everybody in my town will get $5,000 in services free if I get elected. That's what they're interested in, self-centered. Everything has to be what's in it for me. And if you look at the population of the United States, there are clearly two sets of population. There's population to the north that's well-educated, college. I don't know if that's called well-educated, college. Most people are holding relatively good jobs. But if you go to the south, anything past Illinois going south, most people are not well-educated. They do not hold jobs that are, I would call, comfortable jobs to raise a family. So they're not really well-educated. And if I ask people, could you tell me where Mexico City is? They can't. They don't even know where Mexico is, forget about city. That's how badly they're educated. And therefore, when people running for election utilize what is the most, sensitive issue people have at a given time. Like right now, anybody that somehow can pull the rabbit from the head about unemployment in the U.S. will be elected. It doesn't matter who that is. So we as educated people can sit here and rationalize, but that's what the common American does. It's embarrassing. That's what they do. Obama is doing a good job, but he got so many problems. How many can he do in two years? He has done a very good job of some of those problems. Healthcare. It started with Clinton, they could do nothing. Every time it came up, politicians and the lobbyists killed it. Now it's passed this year. Things like that, he said he'll bring the troops back from Iraq last month. He did. But you see, the problem is, there are people in the country who want to see Obama fail.
Yeah.
They'll do anything to make him fail. And silly things, that he is a Muslim. The guy goes to a goddamn Baptist church, which is as conservative as you can get. And they call him a Muslim?
The mosque business.
I know.
here as well.
I know. They're looking for excuses. That's the problem. There are two Americas. There's the America that is sympathetic, well-educated, understanding. Then there's America that came from Jurassic Park.
This is still there. I mean, with this gas, the creation is, and the Museum of Creation in the Norte.
Oh yeah, there are all kinds of weirdos. That's the problem. So when you say, how did he get elected, I might pass to say that most people are stupid.
Sorry.
That's all right. I mean, I've been asked this question before. Now, do you want to continue further this afternoon, or would you rather quit and go away?
No, let's go on.
Okay. What's the plan, Dr.?
Well, I think that I thought that it would be good to have a lunch at 2, so we can keep going to.
Okay, let's do it. I have another one. I have another one that will talk about biofuels and some of these other issues. That's in the computer. You might tell him to load the one that says Tusla.
I'm enjoying very much your message, and I'm sure that a lot of the people here will be interested in this as well. It's very much touching with what you do.
What is that?
Some more, please.
No, I don't want any more.
Feeling San Diego.
How do I like San Diego? I've been here many times. I like it. I not only come here many times, but my wife's, some of the family is living in Palm Desert. And what do I call, what is that place north of here? San Bernardo. San Bernardo.
Yes, with the pollution you were mentioning? Yeah?
Here?
You said that LA pollution is trapped in San Bernardino.
San Bernardino. There's another place here north of San Diego called San Bernardo.
Oh, it's different. Yeah.
That's where Hewlett Packard is.
Okay.
San Bernardo is between here and Riverside.
But
So
your
there are two different
relatives
places.
live in this one, San Diego? Not in LA?
That's San Bernardino.
But where do your relatives live?
Here,
Oh.
in Palm Desert, and then San Bernardo. San Bernardo is about a 45-minute drive from here north, towards Riverside. That's where Hewlett Packard has their main factory. Because these people are all engineers, so they work there. He was asking me whether I've been here before. I said many times.
But not Tijuana.
No, San Diego.
I asked him.
Yes, and I'm really ashamed that you cannot see me. It was bad, but I'm sure that next time will be good if you forgive us and put my hands forward.
Anyway, we can start this after. Or do you want to start now?
We can start now. If you are tired, we can break.
What time are we going to, it's only 1:25. Oh, yeah.
Yes, I want lunch to be at 2 o'clock.
Okay. You ever seen this? From so simple a beginning, endless forms most beautiful and most wonderful have been and are being evolved. Charles Darwin.
I've been to his house.
Have you?
Yeah.
There is a great deal of concern about global warming. We went through this yesterday and today we are going through again. However, global climate change and global warming are not one and the same. I think by now you know this. Global climate change includes three integral critical issues. Changes in trace or greenhouse gases at the surface, thinning of the beneficial ozone layer in the stratosphere, and changes in air temperature and other physical parameters such as precipitation patterns of the surface. Everybody agree with that?
One is how they maybe have forms because they talk about extreme present of extreme events. Sometimes they do consider draft and stuff like that.
Yeah, other factors come in there. I just wanted to use a couple of examples. But everybody agree with this? And you've seen this, so I'm not going there. Clearly, the chemical climate of the earth has been changing. We know this because when we compare the concentrations in 1800 and compare to the concentration today, everybody agrees on that. Greenhouse gas concentrations have increased. 0.6% per year for carbon dioxide, and same thing for other gases, and you can see this. As a result, at least in the last 50 years, while the daytime temperatures in the United States have declined, nighttime temperatures have increased. This is a very important point. When you read about global warming, all the data you see is average temperatures.
Yes, and there is a huge variability between seasons and days.
And for example, the work we have done, we find that the springtime temperatures have increased where we are. The summertime temperatures have not increased. The fall temperatures have increased, but not the winter temperatures. So there's a seasonality, no doubt. But independent of seasonality, if you look at the summertime temperatures, which is what, well, we are concerned about spring, summer, and fall. Because spring is when the growth starts, fall is when the growth ends. And this is the growth season. And if you look at the midpoint of the growth season, the daily temperatures have not changed very much, but the nighttime temperatures have. That's the key. Now, one of the two things people say is, because of changes in air temperature, the growth season has changed. And some people claim they no longer can plant trigo in Canada, southern Canada, and they're planting barley because barley is more tolerant to temperature flux. That's what they say. They're also saying the growth season is prolonged. Instead of, let's say, 120 days, you have a growth season of 150 or 160 or something. But because you prolong the growth season does not mean you get more yield. As the growth season is prolonged, the growth rate increases with temperature. As the growth rate increases with temperature, you get very poor seed filling. And therefore, your yield drops actually. You get early flowering, poor seed filling. The effect, your yield actually drops. It's not a question of stimulation. Here it's a question of inhibition or reduction. So that's what I said, spring, fall seasons have become warmer. Overall, these processes can prolong the crop growth season. However, induce rapid crop growth, maturity, and reduce flowering and seed filling. This is particularly true with cereals. We've seen this. Any increase in air temperature will need to be coupled to available moisture. Otherwise, you'll have drought. And this is the reason why some people are saying in the US, if the temperature increases, the corn will be replaced by sorghum, which requires much less water because it's a C4 plant. And they're claiming the corn will go north. Now, we'll have to see. But that's what they say.
Crop migration.
Huh?
Crop migration.
That's what they say. According to the World Meteorological Organization, as I indicated before, by 2020 availability of freshwater supply will be the single largest limiting factor affecting global population. Here, as I indicated to you, there are two pathways. There's a pathway where human populations require water for direct use. The indirect pathway is human populations require water for agriculture. So those are the two pathways.
What about industry?
Pardon me?
What about industry?
Industry?
Yes.
Compared to agriculture and human populations,
Is the last one, but still, energy, power plants, they need some for.
yeah, except you forget, populations are dispersed throughout the world. Industry is not. That's why there are differences between developed and developing countries. As is, 15% of the global population is suffering from starvation. Lack of food. And virtually now, because of all the complications about using crops for biofuels, ethanol and all this, virtually every major country now is importing. They are not all importing the same thing. One country may be short in soybean, another country may be short in maize, another country may be short in papas, so they're importing different crops. But the net result is they become importers rather than exporters. US has a reserve of food. They always keep this. And the thing I've heard now is the reserve is shrinking already in the US because they have to export more. And when you say export, the reason they import is not just because of the need for food, it's because of the economics. And you've seen this. Trace gases such as nitrous oxide and the chlorofluorocarbons destroy the beneficial ozone layer in the stratosphere. Ozone filters harmful UV radiation from reaching the surface. As an independent phenomenon, increase in ozone levels at the ground, part of the smog, example Mexico City, is the most important phytotoxic air pollutant worldwide. If you look at the reports on the effects of ozone on crops, there are 58 countries in the world that already have reported ozone effects on crops, reduction in crop production or symptoms or whatever. So it's number one. There's Mexico City. There is evidence that beneficial effects of the rising carbon dioxide levels on crops are likely to be offset by the increasing ozone levels. Of the 82 or 83 papers that I've looked at 2 years ago, about 75 of them showed that the effect of CO2 is removed by the effect of ozone and vice versa. So when people are talking about the effect of CO2 on plants, the conclusions they have drawn are probably incorrect unless they have used ozone in the same studies. And this also goes to carbon sequestration. There's data available now that shows where ozone is present in high concentrations. The amount of carbon in the ground is less than the amount of carbon in the ground in places where there is no high ozone. So people don't realize that. Further, increasing nitrogen in the atmosphere is part of global climate change. You never hear about this. Increasing nitrogen is part of global climate change for 2 reasons, or 3 reasons. One, increase in nitrogen will produce increasing ozone. 2, increasing nitrogen input into the soil will kill tree roots. Do you know what a mycorrhiza is? Everybody know what that is? Mycorrhiza, you know what that is? Trees have 2 types of roots. There are what are called as primary roots, and then there are what are called as secondary roots. So, if I were to look at a pine root, this is the primary root, and here is the secondary root. Now, pine species live in acid soils. All pines in North America live in acid soils. These soils have nitrogen, but the nitrogen is bound in the humus layer. It's not released, it's bound in the humus layer. So the pine tree has evolved with symbiosis to release this nitrogen. So these trees, you know what rhizobium is? Rhizobium is a bacterium that fixes nitrogen from the atmosphere. That's what you have in legumes like frijoles and whatnot. But base roots in pine, they have an association with a fungus that converts the root like this, and the fungus is growing on the outside of the root. And it stretches into the soil and slowly dissolves the nitrogen that's sitting here and feeds the root. It's like a slow fertilizer. The root in turn is providing carbon for the fungus because fungus cannot assimilate carbon. So it's a symbiosis. The carbon is coming from the plant to the fungus is feeding the plant with nutrients. If you fertilize the ground, you will kill this fungi. Net effect, your root will have no access to nutrition. It will starve. When acid rain became an issue in Europe, communists always had the best technique. I call it the brutal technique. They just beat you up and that's another problem, you will be nowhere to be seen. So what these guys did, and I saw this, I was standing here watching this. In Czechoslovakia, when acid rain became a problem, they thought, they had helicopters full of calcium hydrocarbonate. And they sprayed these trees, forests with calcium carbonate, saying calcium carbonate will neutralize the acid rain effect. Okay? In the process, they increased the pH of the soil and killed all this fungi. So instead of dying from acid rain, the trees died from this. And it's amazing. I stood there and watched this. So, excess nitrogen, plants require nitrogen. There is a normal range of nitrogen for every species. And if you have excess nitrogen deposition, you will essentially kill this. And if you kill this, the tree is dead as well with time. So, nitrogen to me is part of climate change. Now, you know why I'm saying that? If you look at the amount of nitrogen coming down from the atmosphere to the ground, it has been progressively increasing. And the reason people don't talk about nitrogen, it has nothing to do with global warming. These people are hung up on global warming, so they don't talk about nitrogen. Yet nitrogen is part of the formula. And nitrogen has its own effects. Okay? Any comments? Now remember, I made one other point. In order for plants to accumulate carbon dioxide, they have to have a set amount of nitrogen in the plant. There is always a set carbon to nitrogen ratio.
Exactly, there is a ratio. If that ratio is unbalanced,
except it's not a bottom, except it's not unlimited. So when you have enough nitrogen to carbon ratio, the plant will not assimilate any more carbon. So when people are talking about carbon sink and carbon sequestration, they don't understand this. It's not going to happen.
unless they keep that ratio.
They always keep that constant for each species. It doesn't change. And if you want to change it, you have to calculate and keep increasing the nitrogen until the ratio remains constant. In nature, you can't do this. I'll give you an example. If you take Holland, in Holland, in the southern part of Holland, you have wonderful Kaluna. You know what Kaluna is? You ever been to the Doon Valley when you were in England?
Yes.
Nottingham?
Yes.
Torquay?
Yes.
Penzance?
Of course.
And if you have been to Penzance and Torquay, you go through the Doon Valley.
It's quite nice as a bridge.
And if you look in the outside when you're traveling, you'll see beautiful ecosystem. That's called heather, Kaluna.
Ah, heather is called it's amazing in Scotland. It's amazing, but this
Beautiful flowers, natural ecosystem. In Holland,
it's called Kaluna.
no, its Latin name is Kaluna.
Kaluna is the scientific name.
Yeah, English name is heather.
Heather.
In Holland, they have the highest amount of animal production per hectare in the world. And because they have the highest amount of animal production per hectare in the world, they have the highest amount of nitrogen input in the world. 80 kilograms per hectare of nitrogen per year. 80 kilograms. In comparison, in the US, the highest is 20 kilograms per hectare per year. There's nobody like Holland in nitrogen. So when they had this nitrogen deposition, this excess nitrogen suppressed the heather by allowing tall grass to come in. Grass species are tolerant to nitrogen. Heather is not. So they replaced the heather population by excess nitrogen deposition by grass. Ugly. But the Dutch are not stupid. They figured it out. If you have cows from the high elevations of Scotland, if you introduce these cows into this thing, the cows will eat up all the grass and leave the heather alone. Biological control. So every 2 years or so, they bring these cows and release them into this field. Everything is cleaned up. And then they take the cows away. I'll show some pictures of it. So that's what happens. To me, nitrogen is part of climate change. Because it removes the changes in community composition of perennial populations and biodiversity, like heather. There are two types of plant species. There are plants that are called nitrophilic. That means they like nitrogen. There are plants called nitrophobic. That means they hate nitrogen. So in this case, heather or Kaluna is nitrophobic, grass is nitrophilic. So you can shift the population. With crops, you don't have this problem. The reason you don't have this problem with crops are, in most cases, crops are monocultures. Although in some places like England, they attempt to have mixed cultures. In general, cropping is monoculture because when you mass produce crops, it's easier to harvest one species than two species at the same time, particularly if you are using mechanical harvesting. So it's easier for a guy to go into a mice field and harvest the mice. On the other hand, if the mice field also contains soybean, he's in trouble. Because one, they don't have the same shape. Two, they are not mature at the same time. So where you have monocultures in agriculture, the cropping system is optimized for nutrients. Therefore, you don't have the problem. With native ecosystems, there's no control, so you have this excess input, and you have shift in community structure. Any comments?
Nitrogen deposition. Sources?
Same as the others, fossil fuel combustion, biomass burning. What happens is, just to give you an idea, what happens is when you generate nitrogen or nitrous oxide or nitric oxide, oxides of nitrogen, essentially what you have, it can go into multiple pathways. The preferred pathway in the summer is ozone. This is based upon the amount of energy for the reaction to go forward. In the winter time, the preferred pathway is nitric acid. This is part of the acidity of the ecosystem. Except fortunately in the northern latitudes, you don't have this problem because everything is covered by snow. In southern latitudes, you have a different ballgame. Okay. Now, once these are nitric acid is released in the atmosphere. In this case, it will react with anything that's alkaline. Calcium, magnesium, potassium, ammonium. So essentially, you end up with fine particles. These fine particles form clouds. Nitrogen compounds are highly deliquescent. They attract water vapor. Completely crazy, they attract them. So they form clouds. So this is now deposited by wet deposition. So when you say 80 kilograms per hectare of nitrogen, almost 95% of that is here. Precipitation.
I remember reading not that long ago that nitrogen deposition of our work, I don't remember who was developing, maybe the University of California, were studying some nitrogen deposition in some forests to the north. And it was huge, the amount that they were recording.
No, the highest in the US is 20 kilograms.
20 kilograms.
In Holland it's 80 kilograms.
Of what deposition, nitrogen deposition. I don't remember if I found the paper I was sending.
No, you don't have to. Just go to Google and type NADP. Right now. Just go to Google and type NADP. You find it? National Atmospheric Deposition Program? Open this. Okay, what do you see here? You see somewhere here data? Yeah, open that. Maps.
Animated maps.
Yeah. Okay. Now, type in any state you want, or any chemical you want. All right.
Okay, let's see.
All right. Okay. What is it saying at the bottom? What is it saying here?
Return to animated maps.
Oh, okay. Do this, forget that. Type that thing there. There. See, there's a map.
Okay.
It's giving you nitrate deposition per year from 85 to 2005. And it's giving you the trend. Come here, guys. So you can get this kind of data. You can also get it by each year, by location.
Okay, are you ready?
See, this nitrogen deposition map for the entire US. You can get it by the year and by location. And you can say, for example, I don't know, someplace in Arizona or something, and they'll show you. For almost every major ion.
Every city or?
No, every sample. It's not in the cities. This is in agricultural areas. Cities are useless.
Actually, the highest, with the position.
Yeah, because that's where the highest emissions are. Pennsylvania, Ohio, New York, upstate, western New York, that's where the highest emissions are. So you can do this. Here. So you can see all those ions, you can get them.
Okay, well,
There are, I believe, last I know, there are 230 sites
monitoring sites.
for this,
Okay, in the whole
US.
country.
It goes all the way back to 1976. In fact, the very first location was in Minnesota.
One question, you're talking to the Nora.
Yeah.
How is it now? I've never been there. I would like to.
Sudbury is even worse than Denora,
Really?
Canada. It's one of the most polluted places in the world. The reason Sudbury, Ontario, they have copper smelters. And people don't realize this. Most people you talk to, they say, oh my God, Sudbury smoke is killing everything. No. You know what they did? Back before the engineering technology came, they were melting metal in open pits.
Is that allowed?
Not now. This was 50, 60 years ago.
So they left polluted persistent place.
They have the highest concentration of heavy metals on the ground anywhere in the world.
Wow. I remember when I was doing my PhD, we went to collect, I took a course on collecting on sampling. The professor took us to this medieval melting place. I mean, from the Middle Ages.
Yeah.
And the concentrations were really high, see, in that.
Who is the first guy? Who is the first guy that went to walk on the moon?
Aldrin? Oh, yes,
Huh?
first one.
The first guy who walked on the moon.
I don't remember his name.
Armstrong.
Yep.
Armstrong, yes.
They needed a place to practice. And so they used Sudbury to practice the moon machine to walk. They did.
What for is to,
It's got a terrain very similar to the moon.
I see, and almost as toxic.
And I said this to you before. Virtually all our knowledge of global climate change, the effect of global climate change on crop production and yield is based on artificial studies that involve the impact of one variable at a time, although there is little resemblance to the real world conditions. And nobody can argue with me on that one. Impossible. Where models have been used, they suffer from the lack of independent validation. Let's stop right there. I'll pick it up after lunch.
Come on, guys, let's go. Let's have something great. You see, you have that facility. They don't want to move now.
How do they water those plants?
There are some gardeners and they just jump on them.
Oh, it's a jump.
Yep.
I wondered. I mean, there's no other way.
It looks like plastic, no plastic plants?
I don't beg your pardon. No, they're not plastic. No, they are natural.
Plastic. That one looks more natural.
No, that's. Sorry, that was.
That's all right.
Transportation.
All right, shall we start?
Yeah.
We were here. Today, the miracle of the Green Revolution is over, as I indicated. Over-irrigation has led to steep drops in the water table, now tapped by 1.3 million tube or pipe wells, while thousands of hectares of productive land have been lost due to salinity and waterlogging. 40 years of intensive irrigation, fertilizer and pesticide use have not been kind to the loamy grey fields of Punjab, India, nor in some cases to the people themselves.
Do you know that in this Brazilian meeting in Brazil that I attended last week, they were talking that some parts in the government in Punjab are introducing jatropha.
Could be.
No, they are for this arid land.
Well, jatropha is not going to feed them.
Exactly, but they are planning to sell it to get some money.
I don't think they can sell. It's too much of land. It's not a small area. I think Punjab area is one of the biggest pieces of land in India. No. With world population rapidly increasing towards 9 billion by the mid-21st century, there is a need for doubling the level of current food production by 2030. Clearly, that's a fearful challenge in sustaining global food security into the future. Okay. Now, let's look at some alternatives. Brazil. Here is an example of mountain of soybean hold of a cargo ship bound for China. China imports soybean from Brazil. They are the biggest single importers of soybean. So now Brazil is saying they have to cultivate more land with soybean to make profit.
We have been consuming more food than farmers have been producing for most of the time.
Okay.
But the answer is not growing more. Is it?
What?
The answer to the problem is not growing more, but is to review the consumption patterns.
Like I said, you can never grow more to balance the increase in population. Because population grows exponentially, food production grows arithmetically.
Yeah, but consuming is not only determined by the number of population.
I know, but the problem is, we'll never be able to meet. So, what is the alternative? Philippines. Continuing 2,000-year-old tradition, women harvest rice by hand on the Banua terraces in the Philippines. Even record harvests haven't been able to support the nation's 90 million people, forcing it to become a leading rice importer. It's very funny. The International Rice Research Institute, very much like CIMMYT, is in Los Baños, Philippines. Look at this, it's terrible. Humans sweep the harvested rice field, gleaning leftover grains to feed their family. Because when they plant rice, it's not in rows, they just throw it. And so there's a lot of seeds that don't fall anywhere near or fall too much. So when the seedlings come out, there's rice seeds here. See, she's collecting that. Brazil, they burn down trees in Mato Grosso, where the rate of rainfall's conversion to farmland has marched in lockstep with the price of soybean since 2000. So the better the price, the more they burn, and the more they ship to China. Look at this, more than 9 million acres of forests were damaged or destroyed last year. Now let's talk a little bit about biofuels. Here is two examples. Here is an example of a plant as a source of starch. Here is an example of a plant as a source of oil. And if you look, approximately 48 grams of sugar per square meter per day is produced by this starch system. On the other hand, if you look at the oil system, only 38 grams of sugar per square meter per day. Less sugar assimilated. If you look at 1.9 grams of sugar per megajoule is consumed. Here on the other hand, it's 2.4 grams of sugar per megajoule. So if you go down this list, this is miscanthus, by the way. This is the famous miscanthus, of course it's sunflower. The ultimate residue is 21.6 tons per hectare per year with miscanthus, but only 3.85 tons per hectare per year with sunflower. So you can see the difference. So if you were to look at to produce any biofuel feedstock with adequate stem yield and nitrogen is required, this is what you're going to see. On this axis, I have mass yield in tons per hectare. On this axis, I have nitrogen accumulation. Because remember, I told you in order for carbon fixation to take place, nitrogen has to be sufficient. It's a limiting factor. In the case of C3 plants, you see it reaches a saturation rather early. In the case of C4 plants, it's the opposite. You see the difference between this and carbon assimilation? If you remember what I showed you yesterday, C4 plants are saturated with carbon dioxide sooner than C3 plants. But when it comes to nitrogen saturation, C3 plants actually consume more and C4 plants consume less. So the question is, which one is better? When it comes to food production, C3 plants are better. When it comes to oil production, C4 plants are better.
Okay, could you repeat it?
When it comes to food production, C3 plants are better.
Okay.
When it comes to oil production, or C4 plants are better.
Okay.
Here is another example. I won't go into this. This is too much. All right, biofuels. Can we somehow focus this, or is it focus? I can't even see it.
Apparently, is your diagram the one they cannot do anything.
Was it there? It's okay there. So look at the biofuels. If you look at various greenhouse crops, this is the gas emission in percent. And this is total environmental impact. They have a formula to calculate the total environmental impact. It's based upon the amount of energy consumed, the amount of energy produced, how much of it impacts actually the environment and the corresponding economics. This is published paper in Science by Zha et al. And what we have here, I think that was the late problem. You see here, different sources of fuel have different environmental impacts. If the source is below the green, that means the impact is much less. On the other hand, if you look here, these crops, for example, soybeans, rye, and you see here canola, these are the ones that people are using right now. And they have the most impact. Negative impact, that's what we are talking about. Not positive impact. One of the ones with the least negative impact here is recycling of used oil. Now there are facilities where you can take, for example, used oil from cooking and also used oil from restaurants and other places, and they can recycle. That's the diesel fuel. Workers in India, fertile Punjab, pull an overstuffed load of rice stalks to a farm where they will be used as animal feed. High-yielding varieties high-yielding varieties along with the subsidized fertilizer and irrigation have helped India stay off famine for decades. But now it's over. I thought it was kind of funny, this picture. I think that's the last one. I can turn the light on. Any discussion, comments, questions?
It is a complex problem, of course, how to fulfill the demands of a growing population, feeding a growing population. And of course, you suggest that then, apart from changing pattern of consumption, rethinking the way of sowing and harvesting, that will help.
Only to a limited extent. I think ultimately it has to be coupled to population growth control.
It comes to that.
Because, you know, like I said again and again, the growth of population and the amount of food production are not on the same scale. Until you control the population, the gap will keep increasing. I don't care how many acres you cultivate.
I took a class with an economist in California, and he was so optimistic as to say that technology would help the production of food with the growing demand. And I didn't think it would meet the growing population.
Think of this too. You are right perhaps. Think of this too. The food habits are different in different countries. And you can only use biotechnology on so many crops within a given time to be successful. You cannot change all the crops in one day. I mean, modifying crops to produce optimally is not easy. Because one of the things you have to do is that in as much as you are modifying the crop, you have to maintain its traits. Like for example, soybean rust. Okay, it's a new disease. And in Brazil, for example, apparently it causes 80% reduction in soybean production. 80%. 80. So they use chemicals, spray the hell out of the crop so that this fungus goes away. That's the only control they have. And apparently now they have resistant cultivars. Except here's the problem. The resistant cultivars apparently don't have the same traits for which the original soybean was grown. So you cannot grow this because there's no use. This is the point. And it's the same thing with, I heard wheat for this new rust. Apparently there are resistant cultivars, but they don't have enough carbohydrates in them. So why grow? So I don't agree with this economist. That's why he's probably an economist, because he doesn't know any biology. No.
I guess he's thinking or still believing that the methods used by Green Revolution will help. Many people think like that. A lot of fertilizer and irrigation. I think there's the technology, but it's shown that it's not the case, that there are many consequences which are very negative. I was thinking also that we have not...
oh, more tea coming. I'm going to be saturated with tea. By the time I finish all this, I'll be like a tea plant. Grass.
There is another aspect very important in food production. Marine resources.
What?
Fish
fishing and things like that is also greatly affected.
Well, they are actually saying people shouldn't be eating too many fish. Now,
Long gone the days where T.H. Huxley said that there were limited
yeah.
the marine resources.
So I don't know. And then you see some lakes, like in Lake Michigan, you cannot eat the fish because they're full of mercury.
Oh, yes, I have, when you go to a supermarket in the U.S., they have the
Mercury free?
No, what they say is that most fish have mercury, yeah, in different concentrations, and they also promote wild fish. But who has access to wild fish? Very few people would have.
It's the same philosophy of organic food.
Well, that's what I say. There is what is called as these people who are organic food, they don't understand the plant physiology. Soils have only so much nutrition.
Huh?
Soils have only so much nutrients. You can only grow a crop so many times on the same soil. Repeated use of the same soil for the same crop causes a lot of problems, like increased disease,
Yeah, but
less nutrition.
Well, the biggest problem I see is that because of the numbers you showed us, that good production is for only one crop. But if they do multiple crops, it's less economically
Viable?
But not only that, but it's also when countries have too many people, they cannot rely on multiple crops. They need to maximize productivity, and that's when the problem comes.
Could you define the word organic?
Organic?
What does that mean?
What people say organic is that they supposedly use non-synthetic.
No. Let's not go there. There are two terms. Inorganic, organic. What's the difference?
Organic is biological materials, but that also includes minerals, trace minerals from rock, even arsenic is.
No. Well, that depends. If we are talking organic in the chemistry science, something that it has carbon, and inorganic is nothing that has carbon. But in terms of food, it relates to a product, a crop that it hasn't used any sort of pesticides or things like that.
No, this bugs me. I'm very particular about your thinking is molded by the terminology. If your terminology is wrong to begin with, your thinking will be wrong. So like for example, I used to drive from my office to the other campus to teach. Right around the corner where I turn, there's a coffee shop. There's a big board they put on the sidewalk, organic coffee. I almost want to go inside and ask, can I have a cup of inorganic coffee, please? Why cannot people articulate by saying chemical-free coffee or pesticide-free coffee instead of making all these funny terminologies that are only confusing people?
Well, they confuse chemists, but I think that the rest of people have already identified that as organic pesticide or chemical-free.
Yes, because we can also have organic pesticides and fertilizers. But people
No, we have biological control. Biological control.
Not really.
Organic is
There are no successful
natural.
biological control in plants for disease. There are for insects under field conditions.
I do agree.
The reason I'm saying that is, in a few years, there will be no organic product. There will be no organic plant products. You know why? They'll be forced to use nutrients and such, because they are going to exhaust the existing natural resource. Watch me. Then what are they going to call it? New organic material?
Yes, the phrasing is what's used to not cover up, but just to induce people to think of it as more positive. And people, when they hear organic, they think of it as less harmful to the environment.
Oh, I understand. I understand what they mean. All I'm saying is, if people should be clear in their mind what is happening now what will happen 10 years from now. Because 10 years from now, the methods they are using now won't work or may not work. Because one of the classical theories of plant nutrition is what is called as soil sickness. After you exhaust the minerals in the soil, you can't grow. That's why the soil is sick. So you had to add, bring it back up. And there was a fellow by the name of David Pimentel. He's at Cornell. He did a little bit of calculation. He calculated the amount of energy put in calories per hectare in 1860 or something, and the calories of energy put out. By that, what he meant was the calories of energy put in include manure from horses, mechanical plowing with the horse, the labor that the guy put in, the solid energy going into the field. And the energy coming out is the harvest. So he calculated the ratio, input to output. He did the same thing for 1990. He found out the ratio is the same. In 1990, we were getting more yield, but we were also putting in more. More fertilizer, gasoline for the tractor, all these things. When you add all this, the ratio is exactly the same. Input-output ratio.
Yeah, when I think of intensive production, as you mentioned, in Minnesota, of a single crop, I also think of what would happen after soil exhaustion, after the land doesn't want to, as you mentioned in India, that they have the salinization problem. And also I've heard that in Sonora, they had desertification in the 70s because they were irrigating land that didn't take, I don't think, irrigation. But when you have, like in Mexicali and Imperial Valley, when you have land that is not suitable for farming and it's forced into farming, how long can it last?
Any comments?
He's very shy. He
I'm very shocked and surprised with all the
Organic coffee is a very well-known name designation, and is used very much in Europe, for example. And organic coffee was the first organic to be exported from Chiapas. Yeah, it has a very long history. It's very interesting, and what they mean is that everything is so natural because they have never used any pesticides in these areas. Nothing. Fertilizer. So I guess it is already well known as such with this name. I guess so.
That also has to do with branding. So some people they make the effort to get the certification, but even if they have a certification, how certain are we that it complies with everything? So some people, when they say, oh, it's USDA, other people say even if it's USDA, it's not guaranteed to have what it's advertising to have.
Well,
that's the difficulty.
We have a saying, what goes around comes around. When I was young, they used to have what they call as homeopathy. This is home medicine. And if you got sick, this person would come with a huge box full of little holes. And in that there will be pills about like a pinhead, and they'll do it. Right? And then it went away. Out came all these pharmaceutical companies.
We still have them in here. We have homeopathy or herbal medicine.
No, herbal medicine is different. Now, herbal medicine is back. I have a friend who told me if you eat ginkgo biloba, you'll preserve your brain.
I have one in my
And I told him, I don't think I need any preservation because at the moment my brain is working fine.
I would like to know if you're going to harvest the leaves, Saga.
Huh?
I have a ginkgo biloba. You saw it at home.
You think it's improved your brain power?
I guess so. It's very expensive. But I would like to harvest the leaves.
And start a big
I don't
business.
know when it is the right time. You have to start a business.
No, but okay, no joking now, talking seriously. I think that as a chemist you should know, or you know for sure that plants as well have some certain essential oils and compounds that if they are isolated, I mean,
No, the only difference is, this goes back to the same old question about biotechnology. How do you know modifying one genome hasn't modified something else? The difference between, like for example, you know cortisone is. Cortisone is a plant product.
Yeah.
Originally, it was extracted from plants. But after they found the structure of the cortisone, they synthetically made cortisone. The problem is that if you take synthetic cortisone, it's relatively pure. When you extract from a plant or eat a plant, you don't know what other chemicals that plant has and what the side effects are. That's the issue.
And the issue is also the long-term effects. So even if they advertise benefits, it's just too costly to wait for the multiple effects that one thing could have. And when it's modified and modified again, then and the other problem is that, as you mentioned, that people are more concentrated on short-term results, and long-term is it's at stake. What we have to worry about.
Well, it all depends on how you're taking it. I know one fellow that I used to work with. I always was intrigued why he was eating desayuno. This fellow did not require any desayuno because when he was sitting in front of me, he'd have pills. By the time he ate all this, his stomach must be full. He doesn't need any desayuno.
some pills.
But this fellow was taking this,
Why?
not because doctor told him, but he had this idea by taking all this, he can live longer with less problems.
Maybe he was shortening his life.
And this is all natural products. He used to come with a big accordion-like box and open the
So
lid.
that was homeopathy or just a supplement?
No, like this ginkgo biloba.
Your doctor wants to.
If we go to pharmacy, they have a whole section of natural products.
At these shops, GNC, they're all over in Mexico. They are American shops. GNC.
GNC.
In all
They sell food
shopping-
supplements
all
and vitamins and
shopping
proteins,
centers,
and I think.
Yeah, and they are very expensive. These products, these natural products. And ginkgo biloba, I believe a small bottle of pills, 100 pesos. So I'm going to.
So you have a potential business.
I
I
can tell you this. This fellow was afraid to tell me this because he knew I would jump all over him. He was afraid to tell me about this ginkgo biloba. So when he sees my wife, he's telling her to take it. And she said to me, "Did you know if you take ginkgo biloba, your brain will become better?" I said, "Would you rather see me with a better brain?" She says, no, don't take it. We have enough problem already. But this fellow has been taking this. I have not seen any change in him. No. He's not Einstein. He's still who he is.
When I think of those products, I usually think of the benefit of stimulating people like a placebo.
Yeah, placebo.
Just encouraging people to think of the benefit and also to give them more of a hope.
Well, I don't know about hope. Here is placebo. Christmas time, our families.
So it's more the mentality that people take it and they think it's good for them and then they are happier.
At Christmas time every year, all our family used to get together for dinner, and then all the men will disappear into the next house and play cards. Okay, we'll all play cards for fun, and all the women go someplace else and do whatever they do. And this one fellow, about 2 cervezas, he used to be like a rocket after that. And so one day we decided to test him. So we went and bought alcohol-free cerveza.
Only barley tea, or what about it?
Nothing, just looked like cerveza, but no
It has
sin
a flavor,
alcohol.
but no alcohol.
And they feel happy.
Yeah, we gave him 2 cervezas. He was normal. He was behaving exactly like the time we gave him the real beer. Placebo.
Okay, I do agree that there is this placebo effect. However, come on guys, there are substances in the things that we are drinking and eating that for sure are as well a stimulant, a natural stimulant. Like alcohol, like drugs,
like Viagra, ginseng.
Like all of that, yes. I mean,
like Viagra, natural product.
Natural?
Natural as well. I mean, there is this plant where I was born in Oaxaca that is called toloache, the famous toloache. Have you heard about toloache? It's a datura mexicanas. It's a small plant. We have some very nice flowers, and in the place that I was born, it's used for witchcraft and sort of to dump some men that, I mean, to ensure the loyalty of the others. But actually this plant is high in, it's a highly hallucinogenic content. So of course you are doing something. If you smoke
yeah, it's hallucinogenic. It's called, I think it's called Jimson weed.
Ginseng. Ginseng.
No, Jimson.
Oh, Jimson weed.
It's a large white violet flower.
There are 6 types.
Here.
Actually, in the whole of the world there are 6 species, and 5 are native to Mexico.
I mean, I don't think anybody is disagreeing with you.
Okay.
Obviously, plants are secondary products. Alkaloids, flavonoids, terpenoids,
definitely.
phenols, and tannins, and da-da-da. I don't think anybody is questioning that. The question is, what about the other compounds that coexist with this main compound, and what are the interactive effects? So that's the question.
Yeah, so it's similar to what you were saying, that if they isolate a dosage of ozone, it's not doing much as when you were showing on the towers that it accumulates and it goes up. So it's, seeing the multiplicity of effects, not just one of them.
I completely agree, and that's because chemical isolation of natural products is
I mean, like for example,
subject.
my wife is anemic. She cannot take iron pills because she's got side effects from iron pills. So she eats a lot of spinach because spinach is full of iron, papaya. So she's chewing up a lot of spinach to get rid of the anemia.
What some people do is they just take the green powder of spinach or supplements that are just easier to take in.
Yeah.
Because too much chewing or too many leaves is just...
Does it work?
What, spinach?
Yeah.
Yeah, because it's got a lot of iron. I take iron pills. I'm not allergic, no. I take iron pills. But she takes spinach. She can't take the same pill I'm taking.
Yeah, when it comes to that, I usually think of for myself, I look for alternatives that I can eat, and instead of taking a supplement, I go for the most plant-based or whatever I can find instead of supplements.
To begin with, you should eat more verdura. Most Americans eat more meat and less verdura. At home, we at least eat verdura 3 times a week, uncooked, either way.
And most, or the people I met in the U.S., they usually have just canned peas or canned vegetables or vegetables that are frozen, so they're more convenient. But I'm not sure what the difference would be in the intake. So if it's less nutritious to have the processed vegetable, but what I've read is that people are the freshest are the better.
Of course, because you are not well, let me put it this way. When you freeze, water in the cells form ice crystals. When you thaw, ice crystals generate heat. And therefore you are changing the permeability of the tissue. Therefore you could actually be losing more into the water you're cooking.
Yes. Also, other things I've read is that they say that supposedly flash freezing, that it preserves the freshness of berries. But if you can take them fresh, it's better for you, what I think. Because whatever process they use, if it's heat or cold, I mean that it's reducing the natural of it.
Yeah.
And well, one time I flew on an airplane and I took orange juice from Humex. You know Humex? That's a brand.
Okay.
So what they did is because it's pasteurized, it's lighter in color, orange juice, and it's just too acidic for me, and I won't take it. And when I take orange juice, I do it. It doesn't affect me as much.
Well, the real thing is, clearly medicinal plants are important. That's the whole basis of medicinal chemistry and our pharmacology. So there's no question about it. But the issue is, are the so-called natural products per se better than the purified products? And if you, for example, ask the Food and Drug Administration, they will tell you the purified product has less contamination from other substances, so we know the dose, exposure, and response. But with the other things, there are so many other known and unknown compounds, we can't tell. This is the argument that they offer. But independent of that, if climate was to become an important factor, forget about temperature, increase in carbon dioxide and nitrogen alone would change the behavior of these plants. See, that's the other thing. One is not clear whether these plant products are being tested for the composition and how steady they are.
That's true. So do you think that those variables could prompt a genetic change?
No, I think it's a metabolic change.
Metabolic change.
Like for example, if you have excess substrate, a reaction that normally might go in one direction might go someplace else.
Mm-hmm.
I mean, very simple. If you take carbohydrate, you get oxygen, you get sugar, or respiration. If you turn it up, you get ethanol.
Okay.
And so we don't know. But meanwhile, people like my friend, he thinks somehow he's become brilliant by eating ginkgo biloba. I don't want to hurt him, so I never say anything, but I haven't seen any change.
A potential customer.
And Doctor, I will be chewing ginkgo leaves pretty quick.
It's a big market, all the supplements and all the natural. I have a friend who was taking these, what's it called, tea? Magical tea, I tell her.
This magical tea.
No, that's the phrase I use for her. Because some people get into weight loss, and they try all these different things, and none of them work, because lifestyle has not been adjusted.
Mm.
And I have one of my brothers, it's a bodybuilder, and he takes this big, protein, right? And it says it's natural. It says natural and below artificially flavored. And I tell them, what if they put artificial on top of natural, and then they have flavoring? And it says pure protein, and I tell them, why don't you look for the, not natural, but for the, whatever you can. And I tell them that some plants have even more protein. What I read, that hemp has the more protein in vegetable, hemp seed oil and hemp protein powder. You know those?
You know what hemp is?
Yeah.
What is it?
But what they use is the seed of hemp.
No, but do you know what hemp is?
Yeah.
It's same as marijuana.
Yeah, but what they use is a variety that doesn't have as much hallucinogenic properties. So this, in Canada, it's legal to use that plant because it doesn't have the effects of the popular marijuana.
I always get impressed. When people make it legal to have marijuana, I get very impressed. I was in Netherlands one time, in Amsterdam, and this fellow that was with me has never been there. So he said, maybe we can take a walk and then have dinner. I said,
He
sure.
went to a coffee shop, I'm sure.
Huh?
He went to a coffee shop to have some hash.
No. We were walking along the river Amstel, and here was this big sign that said, Club de Professors. And he says, we should go there. I said, first take a look. So the window was at the street level, we kind of put our heads. Everybody inside was, they were all smashed from marijuana.
Marijuana, hashish, pills, peyote, you name it. Yeah.
Yeah.
But you know that it has the lowest rate of violence in the whole of Europe, Amsterdam.
I believe it. Because I think half the time they don't know where they are.
So you didn't try any?
No. No, no. No, I had no intentions.
So I was surprised that Canada legalized that specific type because it doesn't have the hallucinogenic that the other type would have. And it's also frost resistant. So they use it for fiber, for clothing, for paper, and now they are making it for oil and for powder, for supplement. And they also sell the seeds. And what they claim is, I don't know, is that it has the most protein of the vegetable foods.
So, what is this got to do with climate change?
Well, so what it has to do is that
maybe an option, crop.
Is to seek an alternative. So when I think of it as an alternative to protein, I think that it's less exhaustive on the soil than a cow would be or than any of the other protein.
I have good news for you. Viagra. Okay? This fellow that I know actually dissolved Viagra in water and he grew some frijoles and he sprayed them every day with Viagra. They actually grew faster than frijoles that were not sprayed with Viagra.
No
So
kidding.
hormone beans?
Go do it.
Wow, why?
But it would be expensive.
Nobody knows how it's acting. He just made a solution, sprayed the plants every day. After a week, the plants are bigger than the ones without.
But the plants or the beans themselves?
I don't ask him. He said he was doing the study and he found the plants were growing better.
You should email us the results.
Huh?
You should email us the final results of that experiment.
But hormone food?
Hormones.
Viagra has testosterone. And
So, macho beans.
Macho beans. Frijole variety macho. So I don't know. But tell me, what is this got to do with climate change? I'm still hanging on to it.
Yeah, so when I think of it, as I said, to me, is to look for alternatives that are less exhaustive, like using animal products.
The point is, we didn't talk about it. Climate change will result in altered nutritional quality of plants. Okay? Like grapes, for example. Grapes, red grapes, and Doctor, you must be expert, Cabernet Sauvignon. The color of the red is caused by tannin and phenol in the grape. And if there is a change in carbon dioxide, nitrogen, and ozone, likely the composition of the grape will change. Same thing with something like papas, tomato. So there will be a change in nutritional quality. And in as much as there is a change in nutritional quality in plants, there might as well be a change in the medicinal quality of the plants.
You see, very few people mention this. What they are more worried regarding climate change and agriculture, it will be drought, lack of water, or the most sophisticated talk regarding that will be heat stress. But no more than that, not about the nutritional content.
We have published a study on the effect of long-term chronic ozone exposure on alfalfa.
And what do you find?
And we found that the exposed plants had more lignin in the cell wall.
No.
That means the animals must chew chew much more in order to digest. And we found this tissue had less sugar and more of this garbage.
So it's tougher and less nutritious.
And there are a number of papers. Actually, I wrote a review article on the nutritional changes in plants to air pollution.
So it's going to matter for the vineyards that the doctor is so interested in. That if they migrate the crops, I mean they migrate the whole of the vineyard to avoid the warmer region. Because at the end of the day, they are going to still be exposed to air pollution.
Ask him to put 6 and 7.
6 and 7.
Are you doing other experiments besides alfalfa with any other
Yeah,
crops?
there are a number of crops. I wrote an article synthesizing all the literature.
So you're using staples like tomato or and potato too?
Well, let me show you something. I'll show you my favorite slide. Here is one of mine. There are 2 slides. This is one of them. This is a model. Well, how they model is the following. They can model the temperature. Okay? All these models, what they do is they double the carbon dioxide. And they assume carbon dioxide is heating the air so much. What happens if the concentration doubles? So if you look at all these models, it'll say global temperature scenario under doubling of carbon dioxide. That's what they mean. Okay?
General circulation models do this?
Pardon me?
The general circulation models do.
When it comes to effects.
Okay.
Now here is wheat trigo production. How it's changing or how it will change if there was doubling of carbon dioxide. In the future, trigo will mostly be grown here. Tundra. There will be very little trigo in Mexico. You'll be finished. You'll have to move to tundra.
Can you explain the color?
Yeah, the darker the green, the better the production. The darker the brown, less the production.
What about India? It's gone?
Yeah,
No more?
they're already gone. Green revolution is over.
In Pakistan?
They're under the flood.
Yeah, but it's mostly a desert, so I'm surprised they still have some.
Here is Pakistan right here. This is Punjab and there is Pakistan. Now, forget this. Now I show you my favorite slide of all time. Right there. These are based on 2 different models. The model on the right is NASA's climate change model or global warming model. The model on the left is NOAA's climate change model. According to one model, the red leaves you see here is the present distribution of sugar maples. According to one model, it will migrate to the west under global warming. According to the other model, it will migrate to the east. Which one is right?
Well, the 2 of them seems to be one small place there that there are coincidence, so it is likely that you may go there.
I mean, this is what,
under the same conditions. Under
yeah,
the same
doubling of CO2. This is what models do. It depends on how you initialize the model. And this is not made by me, NASA, NOAA, two of the biggest organizations on climate change. These are the same guys that wrote the IPCC report. I know who they are.
Is any of those closest to what you are finding or not?
What?
Is any of the two estimations?
I'm not even going there.
No?
No, I deal with facts, not
Yeah,
fiction.
because estimation is just a stretch, ultimately. Because how can we predict all the variables and all the different...
You can't. That's the point I'm trying to make all day. These people have simplified a complicated issue. And they don't tell the public. So everybody believes in this. This one was produced by Cynthia Rosenzweig at NASA. This one was produced by Jerry Malman at NOAA. I know who they are.
And are they chemists or what?
Modelers.
climatologists.
They're climatological modelers.
Yeah, you told us the majority are government employees.
Yeah, these two are.
And they wrote the IPCC section in vulnerability, impact, and the rest for the whole of the North American. Rothschild, I think.
Yeah. There was a guy from one of the most well-known institutions in modeling. It's called International Institute for Applied Systems Analysis. This is in Austria, IASA. One of the guys came to the United Nations in this meeting and started talking about this. And one of the climatologists from England looked at him and says, "We don't need to hear this. This is a lot of hot air. You have no proof." So he had to sit down. That's it.
And then,
Kaput.
okay, and
This is the point I'm making. I think if these people stick to the fact of what they know, I don't think there'll be any argument. If they talk about increasing carbon dioxide, increasing ozone, nighttime increase in temperature, which are all proven, changes in precipitation, there's no problem. But to say the entire world is changing by 1 degree or 2 degrees or 3 degrees is nonsense. See what I mean?
When I hear that it's just the simplification that they do, it's to make it just easier for the general audience to digest. But at the same time, they are claiming that what's complex is simple, and it isn't.
Well, let me put it this way. If you look at the IPCC report, you would not be able to understand. You would not be able to understand anything in that report. Because that report is based upon science, complex science of climatology. So if you think the public needs to understand, the IPCC report is not the place. Somebody needs to take the report, digest it, break it down to simple language. That's what I tried to do in this paper that Dr. showed earlier. For example, I have one section that says, is global warming occurring? I put in English whether it's possible or not. That's written for common people, that article. I don't know whether you can print that or not. If somebody can print it, they can have it right now.
yes, okay.
2 copies.
That's what
You have a copy, right?
I don't know.
Well, I'll send you an email. I'll send you an email. It's on my stick. I can send it to you tonight. You can have what's his name? Irina print it.
What's the other image of England?
Pardon me?
Do you have an image of England What does it,
Oh, England, this,
what does it show?
I'll show you.
Oh, go back to,
Oh, he's removing the stick
yeah.
when he comes, he's removing the drive. When he comes back, we'll do it.
How many copies?
3, Dr. And I don't know whether you want it, I don't know whether you want or not. As soon as he puts it back, I'll show you. No, it's file number 1.
Which one?
It says global, it's a Word file.
Do you want to see the paper?
No, these people want copies of the paper.
Yeah, no problem, but with the presentation, they are going to print it now. You
Yeah.
want to continue seeing the presentation?
I want to show him something. He asked me a question. There. This is what is called as NDVI. It simply means NDVI means normalized difference vegetation index. Okay? Now, if you look at most papers, they'll talk about photosynthetic capacity using satellite data. NDVI also uses satellite data. The difference is the incoming radiation into the plant is red wavelength. The outgoing radiation is infrared. So what you do is you calculate NDVI by taking infrared radiation amounts minus red radiation amounts divided by infrared radiation amounts plus radiation. This gives you the energy exchange. It's better than photosynthesis. Okay? Now what this picture shows is the difference in NDVI in England between 2003 and 2002. In 1 year, all these brown areas are areas where the vegetation has declined in its capacity to assimilate. And if you can do this year after year, you can follow a trend. How climate is modifying net primary production. You understand what I'm saying? And the green areas are the ones where there's an increase actually in primary production. This is a much more sensitive technique than using photosynthesis. You can get this data from the satellite. You have to calculate the data by longitude and latitude, but you can get it from the satellite, you can download, and you can calculate. In fact, you can get NDVI from the satellite. There is a subfile link.
Just
Already calculated by longitude and
for
latitude.
the whole of the world.
Yeah.
It'd be interesting to see what is going to happen to the Santo. How has the NDVI developed in San Quintin and Mexican?
But he was asking me what it was. He saw the picture of England. He says, "What's that?"
It's a small witch. Salided witch. It's what England is.
I thought of it like a rabbit. the ears on top,
There is a witch.
but not which.
100. What they teach us. That is a little witch with a coat.
This is what we use in our model, not for climate change. We have a different problem that we are working with. If you're interested, I can tell you about it.
Which is what?
Huh?
Yes, please. What is that?
We are working, here, let me show you something. Oh, since I got all the time, I will show you something. After being a student of doctora, I'm prepared for everything.
Yeah.
Oh, here we go. There is a file here called Alberta, PowerPoint.
Okay.
That's what we want to see.
Let me see the guy.
Yeah, when he comes. We can wait. So anyways, I'll show you what I'm doing. This is a completely different issue. Nothing to do with climate change. It has to do with emission control.
However, these are things that be related to a time series of the climatic conditions as well.
Well, yeah, but what I'm saying is you can calculate this over multiple years. To begin with, you can use the satellite data or ground data on temperature and precipitation as a beginning to see either one controls this in this case. In this case, I know it was drought.
Okay.
So you have to go at steps. You cannot include everything without knowing what each step is. It takes time, patience. Because if the step is wrong, the first step, then all the other steps following it will also be wrong. So you want to do it stepwise.
What sort of crops do they have there in this?
By the way, 0 center point, -1 to +1 means you have almost no production. If you have 0.1 to 0.4, it means you have dry vegetation. And if you go to 1, everything is kaput. And you can see the color as it changes. So this is all cereals. Trigo, barley, oats.
France was a little bit affected.
Pardon me?
France, the piece of France that you got.
Yeah, I don't know what France is doing. Difficult to predict what the Frenchmen do.
Very difficult, yes.
No, it's a PowerPoint file. Sorry, Alberta is a PowerPoint file.
Yeah, no problem. Let's see if we are able to find out. Alberta.
Yep. You didn't want a copy?
Yeah, no.
talking to all the students.
To what?
To the students.
Where?
We have in Montesquieu.
Don't you have copies of this on the hard drive?
I really don't know.
You do? You do?
Okay.
Alberta, yeah. Right there. He's got it. Okay?
That's it. Your USB.
No, I had to move this.
It's not moving?
No.
Okay.
There. Alberta is in Western Canada, at the border of Northwest Territory and rest of Canada in the western border. This whole area is the biggest reserve of oil right now, more than Saudi Arabia. And therefore, they're extracting oil using $1 trillion of money, more than the entire budget of the United States for 1 year. And the oil in this area is in the ground, in tar, asphalt. And so what they do is to mine the asphalt, as you can see here a little bit. I'll show you a better one. There. This is a mine where they mine the asphalt. And then they extract the asphalt with steam and they get oil.
This is an open pit in Terras.
Pardon me?
This is an open pit, an open pit
Mining, correct.
in Terras. How deep is it?
it can go to almost 100 meters.
I see, and that is the reservoir, the
No,
park.
this is where they mined. It's the water that they run off from the mining.
Yeah, and that is a huge problem as well.
Yeah. See?
Yes, wow.
There are 10,000 people employed here. And there's no place for them to live. So they live in tents.
Oh, wow.
This whole area is remote. There are no roads. There's no electricity except at the plant. And so when I go to do work, I have to go in a helicopter.
And what do you work on there?
Aha, always trying to get ahead.
Sorry, just interested.
There are 3 extraction plants.
So they do mine, and then the whole piece of tar is taken somewhere else, or is
Right there.
right there with the steam is
Big plants, extraction plants.
Okay.
So, you have mine, extraction plants, you have power plants.
So they have thermoelectrics there?
No. Once you extract, the asphalt is coke. And they take the coke and put it in the power plant and generate heat.
Oh, coal plant, kind of.
Yeah. Oops. Large diesel vehicles to remove that thing. Do you know the size of a tire?
Oh, I have been to mines, many mines. They are huge, big.
You've never seen anything like this. These are the biggest tires in the world.
I have seen some very impressive ones in South Africa.
Yep, but these are bigger.
Bigger. Gosh.
You know what they do? They're only good for 6 months.
I wonder.
You know how much they cost? One tire is $80,000. One tire. They have 12 tires on each of this. That's $80,000 a piece. So every 6 months, new tires.
Because it's really abrasive.
No, they wear out, just like a car. Going through all
So
this.
they're like mud extracting them.
Yeah. Then there is road dust.
Yeah, that is the main problem associated to open pit mines.
There is forest fires. There is regular traffic. And then there are others.
Runoff, infiltration,
Huh?
water.
Yeah, lagoons and things. So all these are in the same place. And there are 3 of these.
How big are they? Hectares?
What would I call it? How do I say in size? It's about the size of, you ever been to Mexico City? I'm sure you have.
Yes, of course, I used to live there.
It's about the size of a Chapultepec Park.
Ah,
One of them.
okay.
Okay? It's about the size of Una. Okay.
Not that
Huh?
not that big.
Not that big? No, these are big. A big area.
But that picture is summertime,
Yeah?
because during winter they wouldn't have all that green.
They would have what?
All that green, it would be all covered.
There is no green.
No.
Oh, I see the pine tree.
No.
Oh, the conifers.
That's a conifer forest. They'll be there in the winter. Conifers don't lose their needles.
No, but they are covered or with a blanket of snow.
No,
During winter, no?
no. They are above the snow line.
Oh, okay.
And look, all these terraces, they mine them,
This
and they
is-
keep using it as roads. So
This whole operation is 180,000 square kilometers. Just 3. There's going to be 3 more. Okay? And the whole area is nothing but boreal conifer forest. And the question is, how are all these things impacting the environment?
So you are doing that.
Huh?
You are in charge of doing that.
I'm not in charge of the environment, no.
No, you are researching what is going on there.
So what I'm doing is trying to find out what percent of each of these is deposited where and what it's doing. Now remember, there is no electricity, there are no roads. So how do you do this?
How do you monitor that?
How can you monitor when there's no electricity and there are no roads? 180,000 square kilometers.
Well, so
Yeah,
maybe
you
some
are
satellite
monitoring,
images and
Huh?
some satellite images and see how the
We are studying the impact.
winds on in situ. Okay, are you taking some monitors on maybe collectors,
Natural collectors.
lichens?
Epiphytic lichens. And so we have a grid of 300 sites of epiphytic lichens. Everybody know what lichens are?
Yeah.
Well, explain. Do they know?
Líquenes, los que crecen en los árboles, eso como una mancha gris sobre los troncos de los árboles.
Okay.
Esos son líquenes. Y se utilizan como biomonitores.
Now, you can do dispersion modeling of each of these to see where the plumes are going.
And then sample in that direction.
Problem, you have to validate. So to validate, we are using NDVI.
So the plume, assuming what, that the plume,
These plumes are coming at different heights.
yes,
This thing is a big chimney.
yeah, I know.
Excuse me, this. This thing is a big chimney. This is at the surface, the mine. And this is a mobile source, it's moving around.
Yes.
So all these plumes go at different heights. And the dispersion is dependent on the height because the wind velocities are different at different heights and even directions.
Yes.
So we use plume dispersion modeling. We have to validate whether the model is right or wrong. Then when you have forest fires, it's a whole different story. So it's a very complicated system where we are trying to separate all this by using sulfur and nitrogen as tracers
In the lichens.
in the lichen. Sulfur comes from the extraction plant,
Okay, yeah.
nitrogen, excuse me. Sulfur comes from the power plant.
The one is combusted.
Okay?
Mhm.
So we have a grid. 180,000 square kilometers. This is divided into a grid. 300 of them. And in each of this grid we sample epiphytic lichens. And we analyze the epiphytic lichens for sulfur and nitrogen. Okay?
Using what, the wet chemistry? Or?
Wet chemistry, but ashing and wet chemistry.
Okay.
Now, having done that, he doesn't tell us anything. All it's telling us is in some parts there's more sulfur and nitrogen. In other parts there is less sulfur and nitrogen.
Okay, so I remember that a certain guy that I think that is known to you directed a PhD thesis on using lichen as biomonitors.
Yes.
From a very quality.
I know a few of them in England.
Okay, but you should know what I'm talking about. But he noticed, and that was a huge scandal, that the lichens have certain number of years to grow. and then to work as an optimal biomonitor. So I think that it was something like 5 years.
Yes.
And before that, it was not a proper collector.
Yeah.
So how are you managing that in here?
Yes. We are only using sulfur and nitrogen as an indicator.
Okay.
We are not studying sulfur and nitrogen. We are not interested. The question is, why is it in some places there is more sulfur and nitrogen, while in other places it's not?
Well, it's supposed that in those regions that are giving different results, they should give the same, is the first question, or there are other factors?
No, the answer hypothesis would be, where there's high sulfur and nitrogen, there's more deposition from these sources. Where there is less nitrogen and sulfur, there is no deposition or less deposition from these sources.
And what is making deposition? The humid relativity in the region, or what?
No, the dry deposition and the wet deposition, which are natural processes.
Okay.
So the question then, how do you know where sulfur and nitrogen came from?
Well, it seems that you don't really know.
No, I don't.
Okay. Where do they come from?
I had to prove this. Where did it come from?
Can you do any isotope analysis?
First we do ICP mass spec,
ICP, okay.
and we get 50 elements.
Okay. So are you using what, yttrium or any sort of funny inner element as
Argon.
Argon. No, but the argon is for the plasma.
Yeah. What are you asking?
I'm asking if you are having a witness another metal, another element.
I got 50 elements.
Yes.
I have the whole periodic table in front of me.
I know. But sometimes you need a tracer. Are you using a tracer?
There's no need for it in this method. I'm going to explain to you.
Okay.
There is what is called as chemical mass balance.
Yeah.
We use chemical mass balance to determine which side the mass of trace metals predominantly came from what source. Because for each of these, we have source fingerprints.
I see. So how, let's say, what are the element fingerprints of the power plant?
That would be mercury,
Okay.
arsenic,
Yeah, sure.
and cadmium.
Cadmium, yeah.
Okay? Except you cannot measure mercury.
No, not by ICP. It's too volatile.
It's volatile. And we cannot measure reactive mercury from gas-phase mercury from organic mercury. So we do mercury isotope
Okay.
fractionation.
Sure.
And from that we know how much is in what phase. Now,
How do you figure out?
if the isotope fractionation shows that most of the mercury is an organic fraction, it's aged mercury. If most of the mercury is in the inorganic fraction, it's fresh mercury. That tells us the age of the plume.
Sure.
Now, the next question, how do you know how much is local and how much is not? How much is regional, how much is local? Okay? We use lead isotope tracers. The heavier isotope is regional. The lighter isotope is local. Ratio. We always use ratios. We don't use one at a time. Then we use the fingerprints. We have the 50 elements here. We have the 50 elements on the lichens. And we already mapped the high sulfur, high nitrogen, low sulfur, low nitrogen. So we try to see which source contributed what percent at each site.
Which source is contributing the most?
Not yet. This is going on.
Good luck. This is a very interesting study.
It's going on. There are 11 people working on this project. We have so much work to do.
I do remember my ICP-MS and IES.
We do what is called as the state-of-the-art source of receptor modeling and source apportionment. Two of the members in this group are EPA. They are the ones that developed receptor modeling. Other people are copying them. They are the ones developed the receptor modeling. So I went straight to the fountain. So that's the work I'm doing. Now if you look, this is what you have. This is the power plant. Every one of them has one of these. Okay? Here is the extraction plant. This is the Athabasca River. So what happens is, when you fog, the plume goes right into the fog. And you get in the river complex chemistry because all the sulfur nitrogen is converted by water molecules to something else.
Wow. How is the, what are fishes in that river and life, and do you have any data?
Apparently there are live fish, but I'm not a fisheries guy.
No, it's because maybe someone is interested in doing some biomonitors like Daphnia magna, things like that.
I think somebody else is doing that.
Okay.
Zoologists.
Possibly, yeah.
This is the boreal forest.
And what is that?
Okay. In the middle of this boreal forest, we have a meteorological tower.
Sure. To measure.
And we have 13 of these. And these are all driven by solar panels because there's no electricity. So once a month we go in a helicopter, collect the data. See, there is a close-up. See? We have 13 of these. It takes us a whole week to collect the data, and it costs us $20,000 a day for the helicopter.
How tall are they?
These are 10 feet above the canopy.
10 feet above the canopies?
The canopy is approximately 50 feet tall.
Meters?
15 meters tall, the canopy, and the tower is probably close to 20. Now, there is a technique called passive sampling. These are samplers that do not require electricity. So for example, we can use this to get a relative view. In other words, in 13 sites, we can say at site number 1, there is more sulfur nitrogen deposited compared to site number 2. Okay. We can get this relative value once a month. And they look like this. Here are passive samplers. And this passive sampler, for example, collects ozone. Now how does it collect ozone? You coat this filter papers with sodium nitrite. Sodium nitrite reacts with ozone molecule to produce sodium nitrate. They bring the filter to the lab, extract, analyze. So for example, here is SO2 and NO2. And here is hydrocarbon. And these are on a pulley. So we can lift this above the canopy. We also have inside the canopy. And we can raise these up and down to collect the samples, replace the filters, and up it goes. There is the helicopter. And to prove, in fact, I'm not giving you the story.
Brother?
You see, this is what it looks like. This is a boreal forest. There it is. So we have 13 of these, and we also have 8 continuous monitors. Those continuous monitors are unfortunately closer to the sources because that's where they have power. So we can run the continuous monitors closer to these extraction plants. Further out we use this. Then even where we have continuous monitors, we have these to cross-calibrate. So these are cross-calibrated against the continuous monitors. Oh, there it is. That's what I do.
Very interesting. Very interesting. well.
Huh?
Quite creative as well.
Quite what?
Creative.
Well, yeah, I mean, there's no other way.
No, sometimes we need to figure out how to solve problems.
I'm also managing another program there.
Mm-hmm.
I'm looking at carcinogens.
I see.
Carcinogens using lichens and using mass spectroscopy.
Okay.
We collect in a puff sampler. You can collect organic compounds in polyurethane, passive sampling. So you look at a puff sampler, extract the organic compounds, do mass spec, then we look at the lichens at the same site
Okay.
for carcinogens.
And are you finding any?
Oh, yeah.
With that plant, with those plants, yes.
Well, the question remains, how much of that came from actual combustion? How much came from fugitive emissions?
Can you differentiate that? So, well, I would expect that the combustion processes are contributing the most.
Depends on this distance. If you look at the distance closer, it's large particles. You can see it almost on the surface.
Okay, that would be what, for what source? Fugitive emissions?
No, yeah, fugitive emissions when they're mining, when they're doing all these funny things, fugitive emissions. When you go farther out, it's gas-phase condensation. And the species are quite different. The ones closer to the source have one type of chemistry. The one farther out has a totally different type of chemistry. So that's what in 2 projects. This one and the other one. And then next summer we'll start the 3rd one.
In the same place?
Yeah, everything in the same place.
And what are you
We'll compare all the measurement methods at one site. So we can correct for inter-method artifacts.
I see. And for how long these projects have been running?
This project started last summer,
Okay.
and this is the 2nd year. The first year we did the pilot study to make sure everything is in place, our extraction method is correct, our quantification method is correct. Like for example, we can show you initially when we analyze by ICP mass spec, we found very high concentration of arsenic, very high concentrations of arsenic. And we got worried because anytime you find an elevated concentration of arsenic, we should also find the elevated concentration of mercury and cadmium. But we are not finding it. Mercury, of course, kaput. Cadmium, we are not finding it. It turns out when you do not have super high resolution mass spec, the arsenic elutes at the same place as argon chloride. Argon is used for the matrix plasma.
Yes.
So the argon and the arsenic come exactly at the same place. So you get the wrong idea, you have a lot of arsenic. You don't.
You have more.
So we took the same sample, put it in a high resolution mass spectroscopy and separated the two peaks. And we could separate these 2 peaks by small changes in extraction.
Spectral interferences, that is something that I faced in my PhD.
So these are the kind of things I do. So first we establish the protocol, the methodology, the precision, the accuracy of the method, and then do the real experiment.
You can always use modeling.
And so now, this is the 2nd year. We have 2 more years to finish this project. And then the organic compound carcinogen project, this is the first pilot year. Next year it will become the full project. And next year we do the cross comparison study pilot. The following year it becomes full project. So you see various steps, one at a time.
You know, I was sort of happy to leave them out, but now I regret.
So that's what I do if you want to know.
Thank you for
That's my field research.
And what's the food project about? You are planning a food project?
Food project? Somebody else's.
Oh, not part of your team?
No, they have, this whole area has Indian people.
Yeah, the river has the name of the...
Athabasca, yeah. Well, every place up north has Indian name. Doesn't mean anything. But this one has Indian people. And they eat the animals in the area. They eat the berries in the area. And therefore they're worried about nutrition, whether these things are accumulating and going to the system. So they have two people, a nutritionist and a person who actually communicates with the Indian people. So they have those two people in the project, and when they need help for analyzing, they'll come to us. But I'm not running it. I have enough doing 3 projects, I don't need one more. So that's what I'm doing right now.
It's very interesting. So find out. It's to take the lab outside and then do physical measurements that are meaningful. Sometimes we spend too much time in the lab doing.
Well, the nice thing is, I don't go up there very often because it's very far away, and we can't spend a whole week because the helicopter only has 3 seats plus the pilot, so it's not a tourist helicopter. Right? People can go. So what I do is at the beginning of the summer, I go make sure everybody knows exactly what they're doing, and I make them tell me exactly what they're going to do, and let them do the work, field work. Then at the end of the summer, I go back and look to see whether they've done it right. Because if they've not, we have one more chance before the winter comes. Okay. Then I come back and routinely have meetings with these guys that are doing the analysis to make sure all the analysis is done right. Like for example, the mercury analysis is being done at the University of Michigan. Joel Bloom at the University of Michigan is world renowned for mercury speciation. He's part of my team. The lead isotope work is done by Joe Graney at the University of New York. He's expert, he's a geochemist, expert in mercury lead isotope work. The ICP-MS work is being done in Raleigh, North Carolina, where EPA headquarters is. The guy doing the work is an EPA subcontractor, so EPA has the right to examine him. And the 2 guys in EPA work with me directly. Then we have a modeler at EPA who has done this type of work before, who is part of our team.
Chemical speciations.
No.
So,
And then the carcinogen work is being done at Research Triangle Institute, which is the biggest non-profit institute in the world for environmental research. So their main chief of research is a friend of mine. So he's doing the work on carcinogens.
What's the name of the place?
Place? Research Triangle Institute, RTI.
And where is it?
Raleigh, North Carolina.
Oh, North Carolina.
These are named in environmental sciences.
So it's part of the U.S. government, the school?
No, it's non-profit.
Oh, but it's not government funding or subsidized.
They get funding from everywhere. They cannot take any profit. It's a non-profit institution. It has got 230 PhDs and 2,000 staff. And they do primarily environmental research, biotechnology, human epidemiology, and economics. They study epidemics in Africa and things like this. Big institute. I'm sure, Dr. you would appreciate it if I told you they have 18 mass spectrometers. 18. Every kind you want. All the way from laser ablation to mass spectroscopy.
I used to have one.
No, I mean,
Yvonne, and she was quite temperamental, you know.
yeah, the lucky thing for me is, because I've been in this field so long, I know a lot of people. I know who are the good ones and who are not. And if you don't see the name of somebody behind my name, that means I don't trust that person. The ones I trust are always the ones I cooperate.
What is your opinion of the Imperial College?
That's a good college.
The guys who are doing mass spectrometry there?
I don't really know what they do with mass spectroscopy. My connection there has been primarily Nigel, because I've known Nigel for so long. I never went to the main campus. Always went to Silver Park.
So sometimes we must have coincidence.
Yeah, and Ashmore was there one time teaching, but he didn't invite me. Instead, he came and saw me at my hotel. So there are good institutions in some areas everywhere. The question is, you have to identify the right institution. Like, for example, with this mercury speciation, I went to University of Michigan because I knew Joel Bloom at the University of Michigan was a world-renowned scientist in mercury speciation. So I asked him, would you like to participate? He says, yeah. So I brought him in. That's how you do this.
And I'm working with the last student that I have in England. We are still preparing a paper on our selenium speciation in coal mines in some of the paddy fields in China.
Yeah. So anyway, you've heard everything I know.
No, I don't think so, but we have heard differently from that.
I hope you too had enjoyment this afternoon, having fun doing all this.
Even if we don't know much about isotopes and heavy metals.
Sorry, I was carried away. It's not that...
You know, my undergraduate degree was in biology. When I received my first degree, it was in biology, plant biology. After that, I never was in plant biology. I became farther away from plant biology.
I thought that you were a chemist.
Yeah. My PhD is in organic chemistry, terpenoid.
So that's why you were asking us about organic, the definition of organic?
And my master's was on purification and function of two enzymes that simultaneously attack the same substrate. I looked at the rates of the two enzymes to determine which one is acting when.
What kind of enzyme?
It was an enzyme that was destroying auxin, two of them.
Oxygen?
Auxin. Auxin, indolestic acid.
Oh, protein, oxin?
Auxin is not a protein.
No.
What is it?
It's an indole compound. It's a secondary product.
Oh, okay. It's too much info.
Too much info.
So there you are, in a nutshell.
Next time we need to invite the chemistry people, they want the same credential.
And she said,
As he says, they knew. I mean, they were here, some of the researchers around
or maybe if they
2 or 3 weeks ago, they knew.
If they found the lecture in Cicesta because they have more people there.
Cicesta is 1 hour from here. They could have come easily, and they have come before.
Maybe they decided they are not interested in the subject.
I don't know about that. I don't know if it was like that. I know that.
Anyways, I'm glad I enjoyed my trip here. I guess we have one more day, but not in this building.
And the hot springs?